dan fungsinya strategis, menggerakkan semua sumber daya. Bergerak, berjalan, berlari, menyelam semakin dalam, terbang semakin tinggi. Cita-cita BUMN bisa menjadi nyata, kala tata nilai budaya dibangun untuk kemaslahatan semua. Akhlak bukan akronim biasa. Akhlak adalah kemudi BUMN membangun bangsa. Akhlak adalah inti agar BUMN semakin mendunia.
Kita juga perlu sebuah fondasi yang kuat, sebuah nilai yang menjadi panduan kita untuk bergerak. Hari ini juga saya ingin menetapkan akhlak sebagai core value.
Amanah.
Kami memegang teguh kepercayaan yang diberikan.
Kompeten.
Kami terus belajar dan mengembangkan kapabilitas.
Harmonis.
Kami saling peduli dan menghargai perbedaan.
Loyal.
Kami berdedikasi dan mengutamakan kepentingan bangsa.
Adaptif.
Kami terus berinovasi dan antusias dalam menggerakkan atau menghadapi perubahan.
Kolaboratif.
Kami membangun kerjasama yang strategis.
Tata nilai Wijaya Karya lahir dan tumbuh sebagai budaya. Agility.
Kami insan WIKA bertindak terginas dan cepat terhadap peluang dan perubahan bisnis.
Caring.
Kami insan WIKA bertindak proaktif dan peduli terhadap pemangku kepentingan.
Excellence.
Kami insan WIKA memberikan hasil unggul bagi pelanggan dan pemangku kepentingan. Agility, caring, excellence.
Core values BUMN sejatinya selaras dengan core values WIKA. Pada tata nilai budaya keduanya terdapat beberapa perilaku kunci yang berkaitan.
Wijaya Karya siap menjalankan core value akhlak dan ACE berjalan seirama dengan penuh tanggung jawab. Saya meyakini bahwa solidnya core value berkontribusi terhadap identitas, karakter, dan segala aktivitas WIKA yang kuat. Ketika semua lapisan WIKA dapat menyerap dan menerapkan akar budaya akhlak dan ACE, insya Allah akan tercipta insan ACE yang berakhlak.
Indonesia dianugerahi sumber daya alam yang melimpah. Beton, Sulawesi Tenggara, disinilah tersimpan kekayaan berupa aspal alam. Kekayaan langka yang hanya ditemukan di 2 tempat di dunia. Aspal alam Beton, yang kualitasnya telah mendapatkan pengakuan dunia itu, turut diproduksi oleh PT WIKA Bitumen, entitas anak PT Wijaya Karya Persero, Tbk. Dengan 2 tambang seluas lebih dari 400 hektar di Lawele dan Kabunka, material aspal dibawa menuju pabrik. Berbekalkan mesin modern dan canggih, serta didampingi tenaga ahli, aspal WIKA Bitumen diproduksi dengan kualitas terbaik. Untuk distribusinya, WIKA Bitumen juga membangun jeti Banambungi. Dari daerah inilah 2.000 ton aspal dihasilkan setiap tahunnya untuk mendukung pembangunan konektivitas di Indonesia. Kualitasnya menegaskan kesiapan WIKA Bitumen untuk memenuhi kebutuhan aspal nasional untuk menghasilkan infrastruktur jalan yang berkualitas. WIKA Bitumen juga menunjukkan kepeduliannya meningkatkan kualitas hidup masyarakat dengan membangun fasilitas air bersih. Tidak lupa, mobilitas yang kerap menjadi rintangan juga dijawab dengan membuka serta memperbaiki akses jalan di wilayah tersebut. Bekerja, berkarya, dan bermanfaat untuk bangsa. WIKA Bitumen, commitment to deliver excellent product.
PT Wijaya Karya Bangunan Gedung or WIKA Gedung is one of the companies under PT Wijaya Karya Persero, which is established in October 24, 2008. Our vision is acting as the chosen partner to creating space for better humans' life. And our mission to commit to keep customers' trust as a capital to face competitiveness, to create high-quality products and services, life caring, stakeholders engagement, good corporate governance, and business ethic practices. An innovation to increase growth and to create value of ACE, agility, caring, excellence. WIKA Gedung is the best chosen partner to build building construction. Throughout its corporate history, WIKA Gedung has had satisfying track record, both experience and performance, that are profitable for shareholders. This is in line with the corporate's main target, to be world-class building contractor. By positioning itself as a total solution contractor, WIKA Gedung provides integrated construction services using advanced technology to give comprehensive construction work solution by upholding safety and quality. WIKA Gedung has developed solutions and precast or prefab building through backward integration approach to strengthen supply chain or company core business. To develop forward integration business, WIKA Gedung focuses on business development through property business towards investment and concession, to gain from recurring income through concession SIM and BOT or build, operate, transfer. Has been succeeded in completing various projects, WIKA Gedung has promising future business prospect. Those achievements are resulted from hard work of the whole corporate member that optimally contributed to guard customers' confidence and continual innovation. Therefore, the products meet and even above the expectation of the customers. In line with the company's motto,
creating space for better humans' life.
WIKA Gedung has run its business for 8 years and received various achievements. As a part of WIKA Group that operates all over Indonesia, WIKA Gedung is recognized and trusted as contractor in construction industry in Indonesia. The achievement of WIKA Gedung from year to year has increased significantly. WIKA Gedung has developed its business capacity through the initial public offering or IPO plan, as well as transforming as public company.
Pemanasan global dan perubahan iklim kini menjadi perhatian banyak orang di dunia, apalagi melihat banyak dampak negatif yang dirasakan oleh bumi. Kedua faktor tadi menjadi alasan kenapa pembaruan energi terus dilakukan. Tindakan ini demi memperbaiki lingkungan yang perlahan mulai rusak. Salah satu alternatif energi yang dimaksud adalah fotovoltaik atau yang lebih sering kita kenal dengan nama panel surya. Panel surya mempunyai banyak manfaat yang bisa dirasakan oleh lingkungan dan juga manusia. Manfaat untuk lingkungan diantaranya adalah hemat energi, ramah lingkungan, kualitas udara semakin membaik, pelestarian sumber daya alam untuk masa depan. Dan manfaat yang bisa dirasakan oleh manusia adalah hemat biaya energi, tidak bergantung terhadap satu energi saja, dan menjadi investasi yang menguntungkan. Matahari berikan energi untuk dunia, WIKA sebarkan manfaatnya untuk Indonesia.
perusahaan pengembang properti yang terus tumbuh dan berkembang. Dengan brand Taman Sari, perseroan mewujudkan berbagai proyek properti dengan konsep lingkungan yang asri, teduh, dan nyaman. Konsisten dalam menerapkan unsur kearifan lokal pada desain properti yang dikembangkan, serta pilihan lokasi yang strategis dengan fasilitas yang lengkap untuk mendukung kebutuhan penghuni serta menjadi peluang investasi yang menguntungkan. WIKA Realty. Kami telah berkarya selama lebih dari 30 tahun, sejak bulan Januari 2000. WIKA Realty secara resmi berdiri menjadi anak usaha PT Wijaya Karya Persero Tbk, BUMN terbaik di bidang konstruksi, infrastruktur, dan investasi. Hingga saat ini, WIKA Realty telah menciptakan peluang investasi dengan mengembangkan ribuan unit hunian tersebar di kota-kota besar di Indonesia seperti Jakarta, Bogor, Tangerang, Bekasi, Bandung, Semarang, Yogyakarta, Surabaya, Bali, Balikpapan, Manado, Samarinda, dan kota-kota lainnya. WIKA Realty fokus pada lini bisnis pengembangan properti dan manajemen properti. Perseroan mengembangkan produk-produk properti unggulan dengan brand Taman Sari di lokasi-lokasi yang strategis sehingga menjadi pilihan utama bagi konsumen dan investor. Dengan konsep dan karakter pada desain, banyak produk kami pada akhirnya menjadi ikon arsitektur kota di mana Taman Sari dikembangkan. WIKA Realty juga mengelola berbagai aset properti investasi seperti hotel, office, apartemen, sport club, area komersial, kawasan industri, dan lain sebagainya. Saat ini, WIKA Realty sedang mengembangkan berbagai proyek landed house atau rumah tapak, low-rise, dan high-rise property seperti resort hotel, apartemen, kondotel, service apartemen, gedung perkantoran, properti komersial seperti trade center, mall, F&B arcade. Pertumbuhan perseroan tercermin pada kinerja keuangan yang solid serta kepercayaan masyarakat pada setiap properti yang diluncurkan perseroan. Kami terus mengembangkan kompetensi sumber daya manusia untuk mendukung usaha kami. Kami bangga dengan kemajuan yang telah kami capai untuk mempertahankan pertumbuhan yang berkelanjutan. Sebagai pengembang profesional, kami terus berkomitmen untuk menghasilkan produk berkualitas dengan konsep Taman Sari. Kami selalu memperhatikan dampak pada kualitas lingkungan sekitar dan turut menjaga kelestarian alam. WIKA Realty tumbuh dengan bertanggung jawab melalui kontribusi dalam kesejahteraan masyarakat sekitar dan turut serta menjaga kelestarian lingkungan dan kearifan budaya lokal. PT Wijaya Karya Realty Tbk melangkah dengan pasti untuk menjadi perusahaan yang terdepan di bidang properti dengan menghasilkan produk properti unggulan yang menjadi pilihan utama bagi konsumen dan investor. WIKA Realty, best partner in property.
Nama saya Samsul Bahrianuar sebagai Project Manager dari WIKA Gedung untuk proyek MRT Stasiun Lebak Bulus, Fatmawati, dan Cipete. Paket pekerjaan kami adalah struktur baja untuk lantai concourse maupun platform. Kemudian dilanjutkan pekerjaan finishing dari pekerjaan atap, pekerjaan lantai, dinding, ceiling, balustrade, dan semua pekerjaan untuk interior maupun eksterior. Untuk paket yang kami kerjakan dimulai dari Agustus tahun 2017. Untuk kontrak sendiri selama 16 bulan, berakhir di Desember 2018. Tim WIKA Gedung dari engineering, construction, komersial, finance, termasuk safety, total berjumlah 72 orang. Tantangan dalam proyek ini adalah dikarenakan proyek MRT ini adalah yang pertama di Indonesia. Belum pernah ada bangunan MRT di Indonesia sebelumnya. Jadi diharapkan dalam proyek ini adalah tuntutan untuk standar yang cukup tinggi dalam mengerjakan proyek MRT ini. Desain MRT menjadi bagian yang melekat dari infrastruktur perkotaan. Desain stasiun menunjukkan penampilan modern yang dimaksudkan untuk berbaur dengan lingkungan sekitarnya. Stasiun Lebak Bulus menjadikan warna hijau sebagai warna dasar. Diterapkan sebagai warna stasiun untuk menyuntikkan sentuhan alam ke pemandangan kota. Warna biru diterapkan ke stasiun Fatmawati untuk menyelaraskan dengan area yang dekat dengan lingkungan. Warna coklat di stasiun Cipete untuk memunculkan analogi sungai yang berbaur dengan lingkungan dan perkotaan. Karena kata ci dalam bahasa Sunda artinya air atau sungai. Harapan kami MRT ini dapat bermanfaat bagi masyarakat. Kedepannya jalur diperluas sehingga lebih banyak lagi masyarakat yang dapat menikmati. WIKA Gedung siap jika diberikan kepercayaan untuk mengerjakan paket-paket selanjutnya.
I am your city. I house you, feed you, care for your loved ones. I provide you with work and pleasure. I am a living, breathing, unstoppable organism made up of you, people. My drinking water is disappearing, depleted by demand and leaking away in a maze of crumbling infrastructure. My buildings are failing, threatened by age and poor design. My sanitation system is outdated and overwhelmed, endangering our health and safety. And I'm getting hot. Dangerously hot. Soon, I may be too hot for you to live in. If we're going to have a future together, things need to change. We can't keep using the same short-term thinking. We need to plan for those who come next. You created me, and now I need you to stand with me. Build me better, never failing. I am your city, and we are one.
Caring. For those who design, for those who produce, for those who build, and for those who live in buildings. Caring for the safety and benefit of all, making lives easier, more convenient, and more comfortable. Caring about people, listening to what matters to people, and taking into account their needs. Helping everyone to grow. Responding to the multiplicity of challenges in today's world and adapting to the diversity of the lives that populate it. Caring about today, but also caring for the future, taking responsibility to lead the change and build a tomorrow that is in harmony with its environment. Where some merely sell a product, we care about people's lives. Weber, we care.
Suprajaya 2001, your best construction partner.
Terima kasih Vanessa dan Mas Rizal
sudah menghibur hari ini, sudah membuka acara hari ini.
Ya, dengan suara merdu.
Iya, dengan membuat para peserta lebih semangat lagi.
Iya, pastinya. Sebelumnya kita buka dulu acara pada hari ini.
Iya.
Assalamualaikum warahmatullahi wabarakatuh. Waalaikumsalam warahmatullahi wabarakatuh.
Kok dijawab sendiri?
Yang namanya salam juga harus dijawab dong, Mbak.
Oh iya sih, memang kalau misalnya salam itu kan saling mendoakan kan, berarti mendoakan kembali diri kita
betul
sendiri.
Betul banget, harus saling berbagi kebaikan.
Iya, betul banget. Tapi alhamdulillah kita sudah sampai di hari ketiga ya hari ini ya.
Hari ketiga di acara Forum Engineering ke-11 Smart City for Sustainable Urban Development.
Yeay.
Oke.
Sebelumnya kita mau ngucapin makasih juga buat para sponsor nih.
Ya sudah mendukung acara hari ini.
Dari kemarin
hari
sampai besok.
Ini sampai besok ya. Ada siapa aja?
Ada WIKA Beton.
Ada Piranti.
Ada WIKA Gedung.
Ada Indogres.
Ada WIKA Realty.
Ada Microsoft.
Ada WIKA Rekayasa Konstruksi.
Ada Cakra Steel.
Ada WIKA Bitumen.
Ada PT Wijaya Karya.
Ada WIKA Industri Manufaktur.
Ada Utomodek.
Ada WIKA Serang Panimbang.
Ada Suprajaya.
Dan ada Lingga. Terima kasih sudah membantu acara hari ini.
Oke.
Iya,
Ya, kita mau ucapin selamat datang lagi kepada seluruh peserta dan pembicara yang sudah hadir pada hari ini.
Iya.
Hari ini ada apa aja, Mbak?
Hari ini pastinya nanti
ada acara-acara yang menarik ya,
iya,
ada paparan-paparan yang bermutu, berbobot dan pastinya ditunggu sama teman-teman semua.
Iya.
Nanti ada dari salah satu sponsor kita dari WIKA Beton, nanti ada Bapak Ignatius Hari Sumartono. Kemudian nanti juga ada paparan dari AllPlan.
Tapi sebelum kita ke materi, kita mau nyapa-nyapa teman-teman dulu, boleh nggak ya?
Pasti.
Coba di sini yang udah hadir dari universitas mana aja ya?
Ayo boleh komen di
live chat dulu ya. Di sini udah banyak yang udah bilang hadir. Ada Muhammad Rizky,
sudah banyak ya.
Ada Kelvin, terus ada Fauzan. Itu dari mana ya? Ada dari Pertamina. Halo Pertamina UNES.
Universitas Krida Wacana hadir. Politeknik Negeri Pontianak. Banyak sekali yang hadir ya.
Kelautan dan kemarin
USU, ISTN, Universitas Narotama Surabaya.
Luar biasa.
Oke,
mana lagi nih? Oke, Min. Armanto.
Ada Untan, Armanto Umanailo.
Ada Undip. Ada dari WIKA Beton juga.
Universitas Sulawesi Barat, UII, Undip, WIKA Beton banyak. Waduh,
ada yang bikin aku agak
rebutan semua ya.
Iya, ada Unsut.
Ada
Wijaya. Ada dosen aku juga tahu kemarin.
Kampus saya nggak ada nih, Universitas 11 Maret. Dubai Mas Bay. Oh ya, siap.
Temennya Mas Bayu ini ya.
Buzzer juga teman saya ternyata
ada
ya.
Institut Teknologi Kalimantan.
Iya.
Nih dari teman-teman juga bisa ajak lagi teman-temannya buat nonton.
Bisa share link ke grup keluarga, grup kampus, grup pacar, siapapun lah boleh di share ya.
Iya, karena acara hari ini memang bermanfaat banget gitu. Oke, ini ada UI Yogya juga banyak.
Pokoknya banyak banget peserta hari ini, jangan lupa di-share, jangan lupa juga untuk memfollow Instagram PT Wijaya Karya, BIM WIKA dan Forum Engineering. Ya.
Iya.
Jangan lupa juga nanti aktivitas selama 1 hari ini
sampai
kalian,
pokoknya selama aktivitas di Forum Engineering ini kalian harus coba posting-posting hal-hal yang menarik, entah apa aja itu.
Betul.
Nanti kita punya surprise buat teman-teman, ada 10 pemenang, 10 orang beruntung yang paling menarik postingannya yang tag ke IG kita. Itu
untuk
nanti
10 peserta yang beruntung akan mendapatkan hadiah dari panitia ya. Oke, jangan lupa juga hari ini kita masih ada door prize juga.
Iya.
Masih ada pop quiz dengan hadiah yang banyak dan menarik pastinya ya.
Iya.
Oke.
Ya udah kalau gitu teman-teman mungkin gak sabar untuk dengerin perkenalan dari WIKA Beton, apa sih WIKA Beton dan segala macamnya. Langsung saja kita
sambut Bapak Ignatius Hari Sumartono. Ya, saya sebutkan
dari manajer Biro Penelitian dan Pengembangan WIKA Beton.
Pagi. Ya, pagi Pak.
Bapak.
Ya, beliau ini merupakan lulusan dari Teknik Sipil Universitas Parahyangan Bandung.
Wah, orang
dan
Bandung
jabatan
Pak.
sekarang sebagai manajer Biro Penelitian dan Pengembangan WIKA Beton. Selamat pagi, Pak.
Selamat pagi, Bapak.
Ya, selamat pagi.
Kita manggilnya Pak siapa ini, Pak?
Panggilnya Pak Hari saja.
Pak Hari.
Hari, baik.
Selamat pagi Pak Hari.
Pagi, selamat pagi juga para peserta Forum Engineering yang ke-11 ya.
Iya, 11. Baik, Pak Hari.
Langsung saja kepada Pak Hari, kami persilahkan ya Pak.
Iya, baik. Baik, terima kasih atas waktunya buat panitia. Hari ini saya dari PT Wijaya Karya Beton ingin memaparkan terkait infrastruktur Pracetak untuk penunjang Smart City. Jadi sekilas tentang PT Wijaya Karya Beton adalah perusahaan anak perusahaan dari PT WIKA yang bergerak di industri beton, khususnya Pracetak dan ready mix. Saat ini juga kita menyediakan jasa terkait bisnis-bisnis utama kami. Jadi untuk menyingkat waktu, mungkin kita langsung ke isi paparan pada pagi hari ini. Jadi sesuai dengan definisinya Smart City ya, Smart City merupakan wilayah kota yang mengintegrasikan teknologi informasi dan komunikasi dalam tata kelola kotanya dan kehidupan sehari-hari ya. Jadi kalau saya baca ini tujuan utamanya adalah untuk mempertinggi efisiensi, memperbaiki pelayanan publik dan meningkatkan kesejahteraan dari warga kotanya tersebut. Tentunya penerapannya itu harus diimbangi dengan solusi yang baik agar tujuannya tercapai dengan sempurna. Sebagai contoh, kalau permasalahan yang sudah umum di perkotaan seperti permasalahan kemacetan akibat galian kabel-kabel listrik atau masalah banjir ya akibat kemacetan yang diakibatkan oleh banjir atau air yang tergenang di jalanan, itu sering kita alami di daerah perkotaan walaupun kota besar seperti Jakarta ya. Tetapi permasalahan tersebut tentunya tidak dapat diselesaikan dengan penggunaan teknologi informatik dan komunikasi saja gitu. Sehingga memang terus kita harus membuat suatu infrastruktur untuk menyelesaikan solusinya agar solusinya tersebut dapat dirasakan oleh manfaatnya oleh warga kota tersebut. Coba, mungkin tampilannya bisa ditampilkan. Oke. Jadi contohnya untuk permasalahan, mungkin tampilannya bisa di, ya oke. Jadi seperti ini permasalahan yang sering terjadi di daerah perkotaan adalah akibat galian-galian kabel. Nah, kami menawarkan konsep-konsep Pracetak untuk mengatasi masalah-masalah tersebut ya. Salah satunya adalah konstruksi di bawah tanah dengan sistem Pracetak ya. Ya tujuannya memang untuk menempatkan utilitas perkabelan yang memudahkan pemasangan dan perawatan jaringan tanpa membongkar pasang bangunan di atasnya. Ya dapat berfungsi sebagai air bersih, kemudian ada untuk pembuangan limbah cair atau limbah padat, kemudian juga bisa digunakan sebagai sistem pengendalian banjir perkotaan, jaringan gas untuk tekanan rendah dan sampai menengah, kemudian juga dapat digunakan sebagai jaringan listrik untuk tegangan rendah maupun tegangan tinggi, dapat digunakan juga untuk jaringan kabel telekomunikasi, fiber optik, kemudian untuk kabel listrik penerangan jalan raya. Nah ini gambaran seperti konstruksinya seperti ini. Oke, next. Nah, hal-hal yang harus diperhatikan dalam suatu utilitas bawah tanah adalah tentunya kalau kita bicara ruangnya, utilitas basah harus dipisahkan terhadap utilitas kering ya. Jadi utilitas untuk pipa atau air limbah itu harus dipisahkan dari utilitas yang berisi kabel listrik atau telekomunikasi. Kemudian utilitas tersebut harus mempunyai akses masuk setiap jarak tertentu untuk memudahkan dari sisi maintenance dan pekerjaan di dalam utilitas tersebut. Kemudian di dalamnya harus terdapat akses jalan untuk yang memungkinkan untuk pekerjaan pemasangan atau penggantian jaringan. Kemudian harus juga memiliki ventilasi, penerangan, pendeteksi kebakaran yang memadai. Yaitu mungkin bisa digabungkan dengan konsep Smart City ya, yang menggunakan teknologi komunikasi untuk membuat sensor-sensor yang dapat menentukan keselamatan di struktur tersebut. Kemudian ada juga untuk pipa dan kabel itu harus pipa dan kabel dalam jaringan harus diletakkan dalam posisi permanen yang aman ya. Ini untuk menghindari kerusakan akibat adanya perbaikan sehingga itu harus diletakkan dalam posisi yang permanen. Selain itu kabel dan serat optik juga perlu dilindungi dari gangguan binatang pengerat ya. Ya tidak menutup kemungkinan memang karena letaknya di bawah tanah dapat terjadi ada binatang-binatang pengerat yang masuk ke dalam struktur tersebut. Selanjutnya, next. Nah, ini contoh-contoh dari komponen pracetak yang dapat digunakan untuk utilitas bawah tanah. Di sini ada box culvert ya. Box culvert ini dapat dibuat dalam ukuran kecil, biasanya untuk saluran-saluran. Kemudian ada juga untuk yang dimensinya besar untuk utilitas bawah tanah atau bahkan sampai untuk box culvert untuk jalan raya. Nah, ini ada tipe-tipenya, ada yang single box, ada juga yang double box. Nanti kalau digunakan sebagai utilitas bawah tanah bentuknya akan seperti ini. Jadi ruang yang tersedia disediakan jalan untuk orang kerja, kemudian juga terdapat rak-rak yang digunakan untuk menaruh kabel untuk instalasi listrik atau telekomunikasi dan juga untuk pipa-pipa apabila ada pengairan untuk limbah-limbah cair dan padat. Nah, selain itu kita juga sudah punya konsep pracetak berbentuk untuk utilitas data bawah tanah. Ini contohnya, ini konsep ini sebenarnya sudah dirancang sejak tahun 90-an gitu. Tetapi hingga saat ini belum terrealisasi proyeknya, sehingga memang pada kesempatan ini mungkin kita harus berpikir kembali bagaimana untuk mengatasi permasalahan-permasalahan yang ada di sekitar kita. Walaupun secara pelaksanaan apabila kita bicara pemasangan pada konteks kota yang sudah jadi akan lebih sulit dibanding kita membuat utilitas bawah tanah ini pada kota yang baru ya, yang benar-benar dari lahan kosong. Kemudian untuk komponen-komponen pracetak yang sederhana, contohnya ini manhole untuk menghubungkan instalasi listrik. Jadi di sini ada beberapa komponen bagian atas, kemudian komponen bagian tengah, kemudian komponen bagian bawah. Nah, ini kita rangkai menjadi satu struktur manhole yang digunakan untuk sebagai penyambung pipa yang akan dipasang di bawah tanah. Nah, ini tampak yang warna orange ini adalah pipa yang dipasang di antar beberapa manhole. Kemudian pipa-pipa jaringan tersebut akan dimasukkan oleh kabel-kabel listrik sehingga secara pemasangan dapat lebih praktis dari sisi precast-nya, tetapi dari sisi fungsinya kita dapat menghindarkan masalah galian-galian yang terjadi di perkotaan. Kemudian bagaimana cara memasangnya? Ya tentunya memasangnya ada beberapa cara tergantung dengan kondisi lokasi. Contohnya kalau seperti ini kita memasang dengan cara open cut, di mana lahan kita gali, kemudian komponen-komponen pracetak tersebut kita pasang sesuai dengan desainnya. Kemudian setelah saluran atau utilisasi jadi, kita pasang rak-rak yang akan ditaruh oleh untuk peletakan pipa-pipa atau kabel-kabel yang akan melalui saluran tersebut. Nah, apabila di daerah yang memang sangat crowded seperti perkotaan, tentunya masalah-masalah lingkungan harus kita hindari sehingga penggunaan teknologi akan mempermudah pemasangan dari komponen-komponen pracetak tersebut. Ini gambaran seperti kita menggunakan micro tunneling untuk memasang produk box culvert di daerah perkotaan. Sebenarnya teknologi ini sudah teknologi yang dikuasai oleh WIKA ya. Pernah ada proyek Sudetan yang menggunakan konsep micro tunneling juga untuk memasangkan segmen-segmen sebagai saluran air. Nah, sekarang beralih ke masalah yang lain, yaitu masalah genangan ya pada perkotaan ya. Ya karena kita memang di negara tropis yang memiliki curah hujan yang cukup tinggi. Ya kondisi genangan di daerah perkotaan itu sering kita jumpai ya. Memang menjadi kendala bagi masyarakat karena memang menyebabkan kemacetan sehingga terganggunya kegiatan masyarakat di perkotaan. Jadi ini kita tawarkan satu produk baru. Produk ini merupakan teknologi dari partner kami di Jepang, Yamau Corporation, yang bergerak juga di industri pracetak. Jadi Aquaponds ini adalah bangunan reservoir yang berada di dalam tanah yang digunakan untuk penampungan sementara air hujan. Ya tujuannya untuk menghindari terjadinya genangan atau banjir di permukaan tanah atau jalan. Jadi cara bekerjanya pada saat hujan nanti kelebihan air akibat kapasitas saluran drainase yang tidak mencukupi akan ditampung masuk ke dalam produk Aquaponds tersebut. Kemudian pada saat kondisi saluran drainase sudah normal, air dalam Aquaponds akan dipompa keluar sehingga ruang Aquaponds kembali kosong untuk menampung kelebihan air hujan pada saat kondisi akan hujan kembali. Ini gambaran Dewan Direksi kami yang sudah menandatangani kerjasama dengan Yamau untuk memasarkan produk-produk Yamau di Indonesia. Nah, berikut komponen Aquaponds. Jadi sistem ini merupakan sistem bangunan yang menggunakan komponen-komponen beton pracetak. Bertujuannya untuk mempercepat konstruksi bangunan, pelaksanaan bangunannya, dan agar lebih efisien dari biaya pelaksanaannya, maka dibuat dalam bentuk komponen-komponen. Jadi kalau semakin kecil tentunya alat angkat yang digunakan untuk setting dan instalasi komponen tersebut akan lebih murah karena penggunaan alat beratnya yang lebih kecil kapasitasnya. Jadi komponen Aquaponds ini terdiri dari komponen pracetak. Yang pertama adalah komponen dinding berbentuk L. Ini kalau dinding L itu yang ditaruh di bagian sudut. Kemudian komponen dinding tipe T. Tipe T ini adalah komponen yang digunakan untuk produk bagian daerah perimetri dari Aquaponds. Kemudian ada juga komponen kolom. Komponen kolom berbentuk cross yang diletakkan di bagian tengah. Kemudian di bagian atasnya akan diletakkan komponen pracetak plat. Sementara untuk plat di bagian bawah kita menggunakan pekerjaan cor di tempat gitu, sehingga struktur komponen ini akan membentuk suatu ruang yang fungsinya untuk menampung air sehingga dapat menghindari genangan pada bagian permukaan atasnya. Nah, ini berikut foto-foto komponennya. Ini adalah komponen L, dinding L yang akan diletakkan di pojok, kemudian komponen T, kemudian komponen kolom tipe cross, kemudian ada juga komponen slab yang diletakkan di bagian atas. Berikut salah satu dari referensi proyek pertama kami untuk produk Aquaponds ini. Jadi dilaksanakan di depan halaman kantor gubernur di Sulawesi Selatan. Jadi Aquaponds yang diproduksi untuk modul panjang 70,4 meter dengan lebar 8,2 meter. Dari sisi kapasitas tampungan hingga mencapai 1026 meter kubik, dan komponen produk beton ini menggunakan spesifikasi beton dengan kuat tekan 35 MPa. Jumlahnya seperti berikut. Komponen L ada 4 buah yang diletakkan di bagian keempat sisinya, kemudian ada komponen T sebagai perimetrinya, kemudian ada juga kolom tipe cross sebanyak 102 buah, dan total slab yang digunakan adalah 140 buah. Dari aplikasi pemasangan di proyek kami yang di Makassar, jumlah total hari kerja yang diperlukan adalah 66 hari kerja. Jadi pekerjaan ini simultan dari pekerjaan pabrikasi di pabrik WIKA Beton di Makassar dengan pekerjaan galian di lapangan, sehingga dapat meminimalisir waktu pelaksanaan pekerjaan Aquaponds. Nah, ini lokasinya, kalau kita lihat di Google Map, ini adalah kantor gubernur Makassar. Kemudian Aquaponds itu ditaruh di pinggir jalan masih di daerah kawasan kantor gubernur Makassar. Ini kondisi saat kondisi hujan, kondisinya seperti ini, terjadi genangan di pinggir jalan sehingga motor cenderung mengambil ke arah sisi tengah jalan dan menghambat lalu lintas. Nah, ini foto-fotonya sebelum dibuat Aquaponds. Nah, berikut proses-proses produksi yang kami lakukan di pabrik WIKA Beton di Makassar. Jadi pekerjaannya pekerjaan penulangan pada bagian cetakan. Kemudian ada juga pemasangan beberapa aksesoris yang digunakan yang akan dipasang pada panel beton. Kemudian setelah itu pekerjaan pengecoran dan penghalusan untuk permukaan komponen pracetak. Nah, ini beberapa aksesoris yang digunakan. Ini untuk sebagai pocket pada komponen balok. Kemudian ini adalah untuk lifting point-nya untuk komponen slab. Nah, seperti ini jadinya. Kemudian ini sistem cetakan untuk komponen dinding tipe L dan tipe T ya. Ini adalah setting cetakannya. Tampak di sini beberapa aksesoris sudah dipasang juga. Nah, khusus di daerah untuk komponen dinding tersebut ditaruh juga aksesoris berupa sambungan ya yang akan nanti merakit dinding satu dengan dinding yang lain. Ini kita namakan fitting joint. Nah, kemudian ini gambaran penempatan aksesoris insert yang digunakan untuk penyambungan stek keluar dari komponen. Kemudian ada juga ada untuk lifting point yang akan digunakan untuk titik angkat saat instalasi nanti. Ini produk jadinya. Jadi kalau kita lihat setelah jadi komponen dinding ini terdapat aksesoris fitting joint yang nanti akan bertemu antar panel yang satu dengan panel yang lain. Ya tentunya masalah kepresisian ini sudah kita perhatikan karena kita menggunakan cetakan yang presisi ya, sehingga dipastikan saat pemasangannya nanti fitting joint ini akan bertemu. Ini untuk komponen kolom cross, ini cetakannya, kemudian ini aksesoris yang terpasang pada kolom cross, kemudian ini hasil dari pengecorannya. Kalau kita lihat di sini terdapat alur-alur beton yang nanti di situ akan menjadi lokasi aksesoris rubber supaya mencegah kebocoran-kebocoran yang terjadi pada komponen produk Aquapond. Ini produk jadinya untuk komponen tip cross X dan ini penumpukannya di pabrik kami di WIKA Beton. Untuk proses produksinya sederhana karena memang berat produknya tidak terlalu berat, berkisar maksimal di 1,8 ton sehingga bisa menggunakan angkutan tronton biasa ke lokasi. Jadi tahapan dari pemasangannya tentunya harus diawali dengan perencanaan yang baik. Kita harus merencanakan bagaimana barang itu masuk, kemudian di mana barang itu ditaruh dan bagaimana kita memasang produknya. Nah, tadi sempat saya singgung bahwa pelaksanaan produksi dan pekerjaan lapangan ini bisa overlap ya, dalam arti pekerjaan fabrikasi dipekerjakan di pabrik kami, kemudian pekerjaan lapangan sudah bisa mulai konstruksinya. Konstruksi pertama ya tentunya adalah penggalian dari tanah lahan yang akan digunakan untuk memasang produk tersebut ya. Jadi setelah digali, lahan tersebut kemudian dipadatkan untuk pekerjaan pondasinya, kemudian dibuat lantai kerja ya. Nah, setelah lantai kerja jadi, kemudian dilakukan marking untuk posisi peletakan aquapondnya. Ini dilakukan secara manual. Setelah ditembak, terus kita buat garis untuk sebagai acuan saat proses instalasi nanti. Kemudian pemasangan komponen diawali dengan pemasangan komponen tipe L menggunakan alat angkat yang memiliki area jangkauan yang memadai. Kemudian harus juga posisi ini dilakukan survei untuk memastikan bahwa level dari komponen pracetak dan posisinya sudah akurat. Nah, setelah dipastikan akurat, kemudian dilakukan penyambungan sambungan antar komponen dinding dengan menggunakan sistem baut. Sementara untuk melevelnya kita menggunakan adjuster bolt di bagian dasar sehingga kita bisa menyesuaikan level komponen sesuai dengan survei. Nah, kemudian sambungan bolt tersebut kita tutup dengan mortar. Kemudian celah yang terjadi antara komponen pracetak kita tutup dengan sealant adhesif untuk mencegah kebocoran pada konstruksi aquapond tersebut. Tahap selanjutnya adalah pemasangan komponen kolom yang diletakkan berada di antara ruang aquapond. Sama metodenya dapat di-adjust dengan menggunakan adjuster bolt dan diangkat menggunakan lifting point yang sudah disediakan. Kemudian tahap selanjutnya kita lakukan proses penulangan untuk plat lantai dasarnya seperti ini. Kemudian kita lakukan pemasangan plat lantai bagian atas. Jadi plat dasar ini belum kita cor, tapi kita lakukan dulu pemasangan sebagian dari plat bagian atas. Ini tampak metodenya untuk memudahkan proses pemasangan plat. Proses pemasangan plat dilakukan secara selang-seling dulu. Ini untuk memastikan adanya ruang untuk pengecoran dapat dilakukan. Nah, kemudian ini proses pengecoran dari plat lantai dasarnya, kita buat backcasting di bagian sisi seluruh perimeternya, kemudian kita tuangkan beton melalui bagian plat yang belum dipasang, kemudian dilakukan finishing bagian permukaannya. Nah, ini gambar bagaimana plat bagian dasar hasil pengecorannya sudah selesai. Nah, kemudian pemasangan komponen plat terakhir dilakukan, kemudian dilakukan pengencangan dengan baut dan bagian celah yang terjadi antara sisi plat diisi dengan silen adhesif, sehingga jadi seluruh komponen ini terpasang pada lokasi ya. Nah, ini tampak yang sudah jadi, tampak strukturnya, kemudian dilakukan dengan pekerjaan rehabilitasi lingkungan di sekitarnya, jadi pekerjaan penimbunan dan pekerjaan taman, karena memang komponen ini dibangun di bawah taman, tetapi tidak menutup kemungkinan kalau komponen ini dibangun di atas lahan parkiran ya, sehingga memang dapat memanfaatkan ruang atau area di perkotaan yang dapat dimanfaatkan sebagai lahan serapan. Jadi ini evaluasi selama 1 tahun, ini kondisi genangan sebelum dibangun Aquapond. Nah, ini tampak di gambar kedua ini lokasinya, tampak di situ Aquapond yang sedang dibangun. Nah, ini kondisi jalan sebelumnya. Nah, setelah dibangun Aquapond dalam kondisi hujan, genangan air tidak terlihat karena memang ditampung ke dalam produk Aquapond tersebut, sehingga dipastikan jalan dapat tidak terjadi kemacetan akibat genangan. Nah, ini gambaran inlet untuk masuknya Aquapond. Di situ kita gunakan jaring untuk menyaring sampah-sampah agar tidak menyumbat atau bahkan tidak masuk ke dalam Aquapond. Kemudian ini gambaran pengeluaran air ya. Jadi setelah saluran drainase utama kembali normal, kita lakukan pemompaan pengeluaran air dari Aquapond tersebut. Jadi kesimpulannya untuk sistem Aquapond tersebut adalah ini merupakan salah satu solusi yang untuk mengatasi genangan ya, khususnya genangan di daerah perkotaan di mana luas bidang resapan dan kapasitas drainasenya sudah tidak mencukupi. Kemudian Aquapond ini kelebihannya dia tidak merubah tata guna karena dapat dibangun di kawasan seperti pertamanan, perparkiran, jalan raya atau fasilitas umum lainnya. Ya, dalam hal ini tidak memerlukan lahan khusus. Kemudian Aquapond ini terbuat dari beton Pracetak dan teknologinya khusus sehingga menghasilkan produk yang dengan kualitas dan akurasi yang tinggi ya. Dan kegiatan produksi yang dapat dilaksanakan paralel di musim kemarau dapat mempersingkat waktu konsumsi pelaksanaan pekerjaan Aquapond tersebut. Kemudian operasional Aquapond ini cukup sederhana dengan menggunakan inlet sistem gravitasi, kemudian outlet menggunakan sistem pompa. Dan untuk mencegah masuknya sampah digunakan jaring untuk mencegah kotoran masuk ke dalam Aquapond tersebut. Jadi mungkin demikian paparan sekilas tentang Aquapond. Saya punya satu video yang akan menggambarkan bagaimana sih proyek kami yang di Makassar kemarin. Mungkin bisa di-setelkan. Berikut gambaran proyek kami yang dilakukan di Makassar. Ini kondisi sudah semua panel penutup atas sudah terpasang. Jadi kalau kita lihat di sisi kiri itu ada jalan Urip Sumoharjo, yaitu mengalami genangan akibat saluran drainase yang tidak cukup apabila terjadi hujan yang lebat ya. Nah, ini kompleks area di depan kantor gubernuran. panjangnya 70 meter dengan lebar 8 meter. Ini sistem aquapon yang tadi sudah saya jelaskan. Jadi ini tipe-tipenya. Ini gambaran bagaimana kita menstok modul-modul pracetaknya dan proses produksi modul aquapon tersebut. Suaranya nggak ada ya? Ini proses pengecoran. Kemudian setelah pengecoran kita lakukan perataan di bagian permukaan atas. Ini proses pengecoran untuk komponen cetakan yang vertikal. Komponen-komponen aquapon ini diproduksi di pabrik kami yang berada di Makassar. Kemudian memang menggunakan beton FC35 atau K400. Ini tampak sistem cetakan yang kami gunakan sangat memudahkan proses produksi dari komponen aquapon. Ini bisa dilihat untuk pembukaan cetakan untuk komponen kolom hanya dengan menggeser cetakan keluar sehingga cetakan sudah bisa terbuka dan produk bisa diangkat. Nah, ini modul untuk komponen plat penutup bagian atas, kemudian ini modul untuk komponen pilar yang berbentuk cross. Kemudian ini ada komponen panel dinding bentuk T dan komponen T. Ini marking untuk posisi peletakan komponen-komponen tersebut. Kemudian ini proses instalasi komponen dinding. Tampak di situ sudah dipasang aksesoris karet ya. Jadi ini untuk mencegah kebocoran silen adhesif saat dia dipasang silen. Kemudian ini sekuen pemasangan komponen kolom. Jadi ada beberapa pertanyaan juga yang masuk ya sambil kita nonton videonya. Bisa ditanyakan tadi beberapa pertanyaannya yang masuk. Jadi ada pertanyaan dari Mas Erik Depar Praba. Mau tanya Pak, apakah pemasangan aquapon yang ada di Makassar hanya dipasang di depan gubernur atau satu titik atau ada lanjutannya di wilayah lain di Makassar? Jadi seperti yang saya sampaikan tadi, untuk aquapon ini adalah pilot project kami dengan PT Yamau ya. Walaupun kalau di Jepang ini produk ini sudah banyak digunakan. Jadi untuk kondisi saat ini masih di depan gubernuran Kota Makassar satu titik ya. Nanti kedepannya mungkin kita juga sudah mulai memasarkan produk-produk ini tidak hanya di Kota Makassar. Tinggal mungkin kalau ada pemirsa hari ini mungkin dari Departemen Pekerjaan Umum atau dari swasta yang berminat terhadap produk aquapon ini, ya silakan segera menghubungi kami agar bisa kita tindak lanjuti. Kemudian sama pertanyaannya mau tanya berapa lama usia aquapon ya? Ya kalau dari usia tentunya kalau dari Yamau memang disebutkan bahwa bangunan ini sebenarnya tahan gempa juga gitu, sehingga saya yakin ini bangunan ini bisa sampai di 50 tahun. Karena betonnya pun menggunakan beton yang bukan beton rendah ya, tapi hampir mencapai 35 MPa. Kemudian jenis bangunan seperti apa saja yang dapat menggunakan metode Aquapond? Apakah metode Aquapond ini hanya terbatas bangunan utilitas saja? Ya, jadi konsep yang kita sampaikan di sini adalah memang untuk mengendalikan genangan air banjir ya, yang khususnya di perkotaan. Tetapi tidak menutup kemungkinan penggunaan ini pun dapat digunakan di fasilitas gedung. Contohnya untuk fire apa ya? Kalau misalnya ada suatu gedung kan harus ada kebutuhan air yang digunakan saat darurat ya, seperti kebakaran, sehingga dapat digunakan juga sebagai fire pond untuk menyetok air apabila terjadi suasana darurat pada suatu gedung. Kemudian mengapa plat beton di Aquapond dibuat berbeda? Ada plat L, plat plus, dan plat T. Bagaimana proses maintenance aquapondnya? Jadi memang bentuk-bentuk modul Pracetak ini kita buat sesuai dengan kegunaannya ya. Kalau tadi saya sudah paparkan bahwa ada plat L dan plat T itu dipasang sebagai perimeter luar. Kemudian untuk plat cross ini digunakan sebagai pilar yang berada di bagian dalam untuk menumpu plat. Kemudian maintenance-nya tidak terlalu susah. Jadi pengecekan berkala saja. Setelah berkala seperti pembersihan apabila ada setelah hujan ada maintenance rutin. Nah, memang kita sudah siapkan manhole yang dapat digunakan sebagai akses ke dalam aquapond ini. Ini tampak kalau di gambar ini tampak manhole-nya yang dapat digunakan sebagai akses pekerja untuk maintenance bagian dalam dari aquapond. Ada juga dari WFE, izin bertanya, lebih baik menggunakan aquapond atau perbaikan drainase? Bukankah menggunakan aquapond akan memakan biaya yang cukup besar dan menciptakan kemacetan saat pembuatannya? Nah, inilah kenapa kita menggunakan konsep Pracetak. Jadi Pracetak itu dapat menghindari permasalahan-permasalahan di lingkungan sekitar proyek ya, seperti permasalahan kemacetan, karena memang semua komponennya dibuat di pabrikasi ya, sehingga tidak terlalu mengganggu masalah di lingkungan sekitar. Dan memang konsekuensi dari suatu pembangunan tentunya akan ada dampak di masyarakat sekitar, sehingga Aquapond ini diharapkan memang dapat mereduksi masalah-masalah sekitar. Kalau dari sisi biaya memang karena konsepnya Pracetak dan sistemnya lebih cepat, tentunya tidak berbeda jauh dengan konsep konvensional. Ya, diharapkan memang penggunaan lahan yang kosong seperti lahan milik pemerintah atau lahan parkiran atau pertamanan dapat digunakan sehingga menyelesaikan masalah genangan yang sering terjadi di perkotaan. Ya, karena mungkin waktunya sudah cukup dari panitia sudah habis, saya ucapkan terima kasih atas perhatian dan waktu yang diluangkan buat para peserta forum engineering pada pagi hari ini. Apabila ada hal yang ingin ditanyakan, silakan menghubungi website kami, akan kami jawab sesuai dengan yang Bapak Ibu tanyakan. Demikian, saya kembalikan ke panitia, saya ucapkan terima kasih. Wassalamualaikum warahmatullahi wabarakatuh. Sudah.
Oh, Ratna cintamu abadi. Oh, Gali, duhai Ratna, tiada petaka merenggut kasihmu. Oh, oh, oh. Merenggut kasihmu, oh Gali, oh Ratna cintamu abadi. Oh, duhai Gali, duhai Ratna, tiada petaka merenggut kasihmu. Oh, oh, oh.
Yeay.
Aku merasa dipanggil tadi, masa dinyanyiin.
Gali Ratna, bukan Gali Retno.
Oh bukan ya?
Iya.
Pikir ada Gali Retno dipanggil-panggil dinyanyiin.
Oke, teman-teman semua masih semangat ya ini ya? Masih semangat ngikutin acara forum engineering ini? Coba untuk nunjukin semangat, kita mau nyapa teman-teman di live chat YouTube.
Bener loh, ada Guhai Gali dan Duhai Retno.
Langsung, tapi dari tadi ada satu yang apa namanya semangat banget, ngasih komennya apa? Dangdut.
Coba
Sabar
gimana
dong.
coba kalau dangdut?
Jangan dong,
Seperti
udah
mati
kemarin
lampu
dangdutnya.
kan kamu nasar KDI.
Aduh, masa mati lampu lagi? Jangan dong. Oke, kita mau sapa yang ada di live chat YouTube.
Ada Makassar.
Min, Mbak MC-nya cantik, titip salam ya.
Waalaikumsalam.
Cuma Mbak MC-nya aja ya, Mas MC-nya nggak usah. Ponorogo hadir. Ada dari Magelang, Surabaya, Cilacap, Lombok. Oh, ada dari Lombok juga.
Oh, Surabaya banyak nih.
Jogja. Tuh ada. Madura hadir Kak. Waduh, udah mulai absen lagi. Surabaya, Lombok, Surabaya hadir, say something.
Ini ada dari Semarang.
Ya, kita juga mau ngingetin, jangan lupa infoin ke teman-teman yang lain soal acara ini, bisa di-share dimanapun. Silakan juga upload aktivitas kalian hari ini dengan nge-tag BIM WIKA dan
BIM WIKA, Forum Engineering, dan PT Wijaya Karya. Ada Universitas Siliwangi. Kemarin tuh bahkan ada dosen aku juga loh.
Ada ikut?
Ada dosen aku juga dari Universitas Brawijaya.
Aku masih nunggu nih Universitas 11 Maret masih belum ada sampai sekarang.
Coba teman-teman yang punya teman di universitas.
Bayu, adanya Nasar KDI.
Hai Saudra.
Dari Bangka Belitung ada Balikpapan, ayo.
Kalau Polban itu aku suka inget, bener nggak? Kalau yel-yelnya Polban tuh yang jeg gitu. Iya bener, itu yel-yelnya kayak gitu. Jadi mereka punya yel-yel tuh kayak main gergaji gitu.
Oh gitu, gue gergaji.
Bener nggak ya orang-orang Polban? Hai Polban. Masih kayak gitu nggak teknik sipil Polbannya? Terus apalagi nih ada masih banyak banget yang nganjuk.
Iya. Ini masih rame ya, pada absen semua. Kita
namanya ada yang tampan dan berani.
Kita juga mau ngingetin kalau hari ini kita masih punya banyak hadiah. Kita mau bagi door prize dengan total jutaan rupiah.
Iya, ada voucher-voucher.
Ada voucher tiket traveling yang wajib kalian tunggu dan ikuti sampai akhir acara nanti.
Betul.
Oke,
langsung aja kali ya. Teman-teman kayaknya nggak sabar juga mau ini nih.
Mau belajar lagi
Mau belajar lagi.
Ya, mencari ilmu yang bermanfaat. Oke, setelah ini kita ada dari AllPlan.
Iya, dari AllPlan.
Temanya Introduce AllPlan 2021. Oke, yang nantinya akan dimoderatori oleh Bapak Siswanto.
Iya.
Itu dari PT Piranti Sarana Teknologi. Baik.
Oke, kepada Bapak Siswanto.
Kami persilahkan Bapak Siswanto.
Hai.
Halo
Pak Siswanto.
Ya, selamat siang rekan-rekan semua.
Siang Bapak.
Semoga teman-teman berada dalam keadaan sehat di tengah pandemi ini.
Amin.
Saya Siswanto dari PT Piranti Sarana Teknologi. Saya di sini akan menjadi moderator untuk sesi workshop berikutnya. yang akan membahas mengenai AllPlan Engineering serta AllPlan Bridge. Sebelumnya saya akan memperkenalkan rekan saya Stefan Tinemans. Saat ini posisinya adalah Sales Enablement Manager daripada AllPlan Jerman. Latar belakang pendidikan dia sebetulnya adalah arsitek. Namun beberapa saat terakhir, sekitar 20 tahun terakhir, dia berkutat dengan AllPlan Engineering, lebih tepatnya ke arah bridge. Jadi perkenalan beliau dengan AllPlan Engineering dimulai pada tahun 2007 saat dia menjadi support engineer di SKIA. SKIA adalah reseller AllPlan di Benelux. Dari posisi sebagai support engineer, lalu trainer, lalu menjadi software consultant, dan akhirnya menjadi team leader. Pada tahun 2018 dia bergabung dengan AllPlan langsung sebagai Sales Enablement Management sampai dengan sekarang. Dia mempunyai pengalaman panjang di engineering offices, rebar detailers, dan juga kontraktor dalam penerapan secara praktis dalam penggunaan BIM. Dia juga terlibat langsung dalam pembuatan panduan pengaturan BIM pada Scientific and Technological Center for the Construction Industry. Secara garis besar, sesi ini akan terbagi menjadi 3 bagian. Pertama adalah referensi daripada proyek-proyek yang menggunakan AllPlan secara real. Selanjutnya, AllPlan Engineering hands-on introduction modeling and rebar, jadi akan membahas mengenai tulangan-tulangan. Yang ketiga, AllPlan Bridge hands-on introduction pre-stress concrete bridge, jadi akan lebih spesifik ke arah jembatan. Untuk teman-teman yang ingin mengajukan pertanyaan, silahkan jangan ragu-ragu untuk terhubung dengan platform slide.do kami dengan cara tentunya cari dulu di Google, setelah itu masukkan kode hashtag FE20. Baiklah, tidak berpanjang lebar, mari kita akan langsung mendengarkan pemaparan dari Stefan Tinemans. Waktu dan tempat kami persilakan.
Hi everybody, welcome to this WIKA workshop about AllPlan Engineering and AllPlan Bridge. There are 4 parts in this workshop. First, we'll take a look at some reference engineering projects. Then there are 2 hands-on introductions, one about modeling and rebar in AllPlan Engineering, and one about AllPlan Bridge. At the end of the presentation, there will be some time for Q&A. First, I will start with reference projects. What is the idea about these reference projects that I will show maybe more in-depth looked in some of the case studies. So on the AllPlan website, there are case studies, which is a PDF document explaining these different projects, but I will show these projects live in AllPlan so you get a better understanding and a more in-depth look or behind the scenes of how these projects have been created, how they can be used in AllPlan, what they bring to the designer and the contractor for the construction. So we see here for Samotobel Bridge, for example, we have another one which is the dry dock in Dukum in Oman, and so you see your case study, Stamina Bridge is also one. So I will show a couple of these, and then you can take a look at these case studies also to get then also the other side of the story. First one is for Samotol Bridge in Switzerland. It's over a gorge in the mountains. It's about 150 meters long, and the span between these supports is 80 meters. We'll take a look at the 3D model to see construction phases, and also to see what is inside of this model, where you can see the rebar. And then we can also check the rebar stages. We'll also take a look at drawing to see how this can be represented, for example, with the Swiss standard. Next project is the dry docks in Dukum in Oman. It's part of a large harbor project. These are 2 dry docks for about 400 meters long and 100 meters wide. And we'll also see how a massive project like this can be managed, how these individual elements can be reinforced and managed. Next is the Tamina Bridge, a fairly recent bridge in Switzerland also. And the construction sequence was quite special. I will show you this also in AllPlan later, how you can see this or simulate this from the 3D model itself. The total length is about 450 meters, and this main span here is 260 meters. And I think the gorge for the river below is also about 250 meters high. And we'll take a look here to see in this project also a lot of pre-stressing tendons together with a rebar detail. Next project is then a civil engineering project, and you would say this is a tunnel, but it's actually an aqueduct. This part that we see here is a canal for the boats to cross the road. So you could say this is tunnel, but to say it nicer or more special, this is actually a bridge for boats to go over the highway. And we'll take a look also about rebar detailing in this segment of the project. Then we come to the last reference project, which is the flyover Kehadiran. It's in the Netherlands, not too far from where I live. I live in Belgium. Ramon lives in the Netherlands, so it's between the two of us. We always pass by this under this flyover. It's about 650 meters long, and you have 11 spans of about 50 to 60 meters between the piers. And here we'll also take a look at rebar detailing, construction stages, and you also see here the tendons. For tomorrow, AllPlan Bridge, I can also highlight the possibility of creating these tendons in a segment in AllPlan Bridge. So today we'll be focusing on these reference projects and showing some workflows or what the 3D model can mean in a BIM environment for the designer and for the constructor. Okay, so let's go to AllPlan. Yes, so we start off with Versameltobel Bridge in Switzerland. We can see also that in AllPlan you can have your digital terrain model to see how it fits into the environment. And we can check also the 3D model and then see, for example, the detail for these guardrails. We can see in the bottom that we have these tendons. Yeah, so you get a good overview, or you can imagine how this project would fit in a 3D terrain, for example. Okay, now I will also show some functionalities for AllPlan. In this case, you have this curved road. There is the bridge itself; it's straight, but you have connection with the curved road. In AllPlan, there is a functionality to represent this in a good way, and this is section along any curve. So you see here actually the road axis, and I can make a section along this road axis, which can be curved, so it can be circle, straight line, clockwise, so it can be a whole road axis. And with this function, you can just click the axis, choose the direction that you want to look, and now the model will be cut or a section created along the terrain with a depth of 0 in this case. So you see here, let's make this a little bigger. So we see here that this terrain, there's a gray line, has been cut along this axis, and you see also all the elements. Now I can also make another section here along these lines. So you can choose from which side you would like to look, from this side maybe, and then a section will be created just through this line, and then would be that this has been taken where you have this support foundation. You can see it now here with the bridge deck and also the terrain. So it's very easy and very precise to create just a section along any curve and to see all objects. And it will be any object, like a terrain, 3D lines, a 3D surface. It can come also from other software. If you have there a terrain, you can just import a 3D surface, and then it will also appear on this section. More with this section, what we can do here is we can use a dimension, and then you can dimension the section and just place these dimension points, and then you will see exactly the height within the section. So this is like 700 meters high, 700. So you can just click points, and then relative to the absolute elevation, you will get these heights. Okay, so this is about the section along a curve. Now I will go back to the 3D model, and here we will take now a look at some construction stages, maybe not really stages, but to see how this model has been built up. So you have a specific structure in AllPlan where you have divided your project in different files. This will be visible in all of the projects. Sometimes I will go a little bit more into detail about this. So here we have model and rebar, and we also have the terrain. So let's just say I would like to turn off the terrain here, and then we'll see the bridge. And yeah, these height lines, for example, you can say, okay, I would like to leave them on, so you can also just turn them off here. And then we get a clean look at what our construction or 3D construction is. Okay, so turn off this one here. And then we see the actual bridge construction. So this is all 3D models generated with freeform modeling. And now I can say I would like to build it up from the start to show different phases. So for example, we have a foundation on this side, we have the foundation on the other side, we have then the abutment on one side, abutment on the other side. These can be subdivided in smaller parts. It's just now here to show the different elements. And this can represent also a construction stage. Then we have the main span or main deck. We have the guardrails, and for example, at the end, we have also the road covering. Same thing that we can also do for the reinforcement, but it can be done also with different detail. So we have here, for example, the rebar for abutments, and then abutment itself. We have the foundation for this supports. Then we have the support. So for a visualization, for example, you could choose, okay, I would like to show now where we have this boat also with a 3D model. Yeah, so you have this structure integrated into AllPlan where you can show how it's build up, make some visualizations of it if you want to do this. But this is part of how you organize your projects. And then let's continue here. So we have then the support parts. Yes, we can take a look in detail a little bit more. These are all 3D rebar, and from 3D rebar, 2D design will be generated. I will show this in the last project exactly what the relation is between 2D and 3D. And now we take a look at the main span, for example, here, and then you can just add, okay, show different parts of each segment to see when the pour should be done or what rebar will be needed for each phase. Okay. Let's focus maybe on just one in the middle. So I will turn off everything here and take a look at the one in the middle. So here we have a rebar, and this is actually different bar shapes with different mark numbers. And in this object tree, we can go into detail here about reinforcements. For example, you see there are 62 different bar marks, and you can say, show me where bar mark 1 is. And you just activate it, and then you can see here, okay, this is bar mark 1. Where is bar mark 2, something like this. So you can go through the project and still check in the 3D model where each bar mark is located. So these it gives some overview about how you could organize a project. So 3D model together with rebar, and now I will show you actual plan layout that has been created from the rebar. So here we see, and I can show maybe in color. So this is the design of the middle part that I showed. This is according to Swiss standard, so it can look a little bit different than what you're used to, and then you can see details of the rebar with sections. I will also show later how this works, how you can design a bar shape, and how you can create a section, and that would be in the last part today. Another layout is the one about the pre-stressings. So, and here you can see then a detail about pre-stressing cables. This is something that can be very well created, the tendons with AllPlan bridge, also possible with freeform modeling in AllPlan. Okay, so that's it for this project. Now I would like to go to the next project, which is then the dry dock in Oman. Okay. So these were these two dry docks, about 400 meters long and 100 meters wide. And okay, make this a little bit lighter. So here we see our project again. So these are all, I'll show the edges, so then you can see a little bit better. So now about the scale, so 400 meters, that means one of these floor steps, this is one single pour, 40 meters long by 20 meters wide, and I think 2 meters thick, so massive elements. The engineering office is done, the construction is done by Daewoo from South Korea. In the beginning, the engineering office, they wanted to just create calculation of how much reinforcement was needed, but then just like a typical sketch or typical detail without the need of having actual details being created in 3D. They were the contractor, they had a very tight construction schedule. So they say, let's invest and put the effort in the beginning so we can actually design all these 3D elements with 3D reinforcement. So when they are poured on the construction yard, we're sure we have all the rebar being produced already, and we are sure that it can fit on the construction yard, and we don't lose time by needing to fix some problems on the construction yard, certainly for each of these massive elements. So if you check a little bit about the scale, this is, I think, about 15 meters high, 40 meters, so one segment of these walls is 50 meters high, 20 meters wide. So we can also check here, there is some access roads going to this side. So each element can be similar, but actually they're all a little bit different. Also for this gallery on top, there are connections which are more heavily reinforced. So if we take now a look a little bit into detail, for example, this drainage tunnel here. So how does the reinforcement again fit in a model like this? I can just turn off this object, this drainage tunnel here, and then we can see there is actual reinforcement inside. So let's check maybe a little bit deeper. So if we see here, this is very heavily reinforced. And then we can take a look around, also see where it goes to the pump room, to the other side, so where it actually comes from. So this is the entrance, or where the water comes from the dry dock, it goes to the pump room. Yeah, so this is something you also have when you have a 3D model with the reinforcement. You can check the relation and get a better understanding how these things are organized or can fit together. There will be other elements. Let's take a look at maybe one of these called sidewalls. So how would you structure a project like this? Because there are many elements and they need to be, let's say, handled individually. And you would like to be able to work with multiple people because this is a large project. So for this, there is the building structure. It's called building structure, and you can organize a project in the way that fits your needs. So what we see here is an organization, and this is very flexible. So you can create this how you would need it or see fit. So we have dock 1. Let's make this a little bit smaller here. So we have dock 1 on this side. We have dock 2 on the other side. And this is also how this is organized here. We have dock 1 and dock 2. And then we have corner walls, head walls, side walls. So let's take a look side wall north, which is this one here. And then you have each of these elements. So N1, dock 1, north wall, number 19. So each object is numbered and each object is an individual part of the project. So let's, for example, just turn on this one here. We don't need to have the drainage tunnel anymore at this point. So you see, you can just turn on, turn off these different elements. And now we will see here everything together. If I turn off now the full model here, then we see this is this one object. And then we can take a look more into detail about just one object. So easy to manage, easy to find again in this structure where this model would be. And on the right-hand side, this is how this customer has organized it. We can have the same thing here where we take a look and for the reinforcement, for example. So now on this side, I have the 3D model. On the other side, I have the reinforcement. Open them both again. focus on the thing that you would like to see, so not the full model, just this one. And if I turn off now, you can actually see there is already reinforcement. This is slightly transparent. So if I would turn off now the element, then you would see the reinforcement in the different colors. Each color can represent or a diameter or a mark number. So this is up to you, or a reinforcement layer. Yeah, so this is the rebar model here. Okay. So we saw the organization. We saw this drainage tunnel in detail. Let's take a look maybe at the drawing linked from, generated from this model. And this is generated, I think, according to a British standard. So let's just take a look at one for the drainage tunnel, one of these sections. So here we see each label. So the label can be customized. You can, for different standards, like we saw the Swiss standard, this is then more British standard. You can configure how these labels should look, and they're linked to the reinforcement. So we have the different sections here for the different parts of this drainage tunnel. Okay. This was the second project. Now let's take a look at the third project, which would be the Tamina Bridge. Tamina Bridge in Switzerland. So this was the one about 450 meters long, and this gorge of, or the cliff about 250 meters high. And what you will see first is the view of the full model. And you see that this looks quite strange. This is the purpose, of course. So you see that there is some steel construction with cables, but that doesn't really match the, could even, the bridge. But what we see here is actually different states of the project or the model in one step. So I've activated everything here. So I see multiple, let's say, disciplines, multiple stages of this project at the same time. Let's maybe focus on the finished bridge like this. So we have a DTM, we have this deep gorge for a river, so about 250 meters high, I think. And the construction here on the internet, there are very nice pictures about how this bridge has been constructed. Also in the case study, there is something, let's see here, yeah. So you see this arc here, how this has been constructed. It's quite impressive because it crosses this gorge, so they need to make the formwork, and actually it's hovering over this gorge just by generating this arc segment. So first they create a support arc, and then they put the actual bridge on top. Also here I can simulate the workflow, so let's start by turning everything off. We have, of course, digital terrain, and then here we can see there is some cutouts already for the foundation. So we'll just go through here. We have the foundation on this side, and we have the foundation on the other side, and they work on both sides simultaneously. So one group works on this side, the other on this side, and they just construct then the first, let's say, connection, so some kind of abutment connection with what the road would be. And this is a massive concrete block here, where this is. Oh, don't show again. I think we're full. That's good. Many attendees. So this is one massive block of concrete, and then the bridge lays on top of this and is held down with some kind of cable to hold it down on this massive concrete block. And then you would have the deck on top. So this could be done as a couple of stages, and then we have the next one is then the foundations on this side for the support parts, foundation on the other side, and then the actual support is also being generated. So for this, temporary formwork is used. I didn't include this in this project here. So when this is done, now the special thing starts to create this arc, and maybe first this connection also here. So we have the bottoms and then we have the tops of the deck. So this is actually finished and then keeps it balanced there. And this side also, and now they start with the arc. And for the arc, they need first to have this temporary construction. So here, I just did it in one step. Normally, it would be the erection of this part and then just each arc, but then there would be too much clicking, so I just grouped them a little bit. So we have first, let's see, each one is a segment, and the segment is generated, and we see this clearly on this picture here also. So this is the formwork. You can see the size. It's full of reinforcements. It's a hollow core arc, but then cast in place. And you see this, each one is one of these arc elements, fully modeled in 3D. It gets thinner in height and in width, so it's also quite complex, but very efficient modeling, because it's, let's say, in relation a thin shape. So then we go to the next phase here, and then we see the next support structure and the next set of arcs. And now, because this is also a little bit lower, so they generate it and they would like to come together somewhere in the middle, so they start on this side, and now they start constructing temporary structure on the other side, and they start with these arcs here. And maybe in this arc, I can show also a little bit of the reinforcement later. So then we go to the next step. It's actually on this side, and then on the other side, the same thing. And then here, the last part with the arc. On the other side, also the temporary steel structure. So they have on two sides, and now by arranging the tension on the cables, they can move it so it can fit perfectly together. So they still have control to move it like an inch or a little bit, so it can it's perfectly aligned. And then when that's done, they put this key in the middle. And then this structure is completed. The support structure, of course, it can support itself because it should support also the bridge on top. And then you can just say, don't show anymore the support structure. So this is the actual state, this project at this specific point. Then we can continue with the deck, and then they start in the middle. So that seems like the most risk to start on this arc in the middle without any connection there, but then they put this formwork here, very impressive construction. Okay. And then let's say first is this part being constructed, and then is the deck on top. And like this, they go to the different steps where they put first there with again some temporary formwork, which is then put on top of the arc. So they work more or less in symmetry, so on each side, and then they have this both of these supports. Then they will construct the next part here. Other side. So not fully symmetrical, because this side is a little bit longer, so it's a very detailed design. There is nothing which is actually the same. The system is the same, but the actual design is different. So there are many variations in thickness of the deck. This would then be almost the last part there. They start from the support again, so a cantilever, and then they put the middle section. So this was finished first, and now in the end, this is then the last section here. So now the bridge is complete. Then you can say, okay, put the other elements on top, and now you have the main, or the bridge is complete right now. So this is the exterior. We see the construction stages and also the parts in the 3D model. Now let's take a look at what is inside. And for this, I will put transparency on. I will turn off the details here. Let me collapse it again. So set the transparency of this surface. Something like this. So now we can see a better look in the structure. Some details are highlighted with green for the blisters for the tendons. And for example, here, the reinforcement. Let's check here for this main. So here you can see now clearly the segments. So check the rebar for this arc. And we have the first part, which is then the rebars which are generated or coming from this main foundation, just sticking out because they wait to be connected with all these couplers. So they use a lot of couplers here. For each arc there is couplers, not sure how many, but I think there are more than 1,000 bar in total longitudinal for one segment. So then we have the second part. So here we see now, this is the first or second part rebar, but this is for this segment. So you see there is a segment, here is also a segment. So the rebar, I will turn it off again. So first set, this is just rebar waiting to be connected. Then we have the second set. And again, it has also this rebar waiting to connect and two sets. Yeah, so with a lot of overlap. And then we have the third part connected like this. Yeah, so each segment is done with this kind of solution and within this 3D arc structure. So set how they constructed also segment by segment with the rebar. So this is also what is seen here in this picture in the case study. Okay, now let's put on some more reinforcement here, like this, and this is then the rebar around this connection with the support. So there is a lot of rebar in there, which is also a very complex shape. So take a look here. So this is then also where the tendons will connect, and tendons in the sidewall, tendons on the top and the bottom. So for planning wise, seeing then this 3D model with the 3D rebar is very valuable also to just understand how it needs to be generated. And now let's take a look at the tendons. So there are a lot of tendons, I think about 120 in this deck, and we can just activate them. So activate here all. Yeah. So we have here this segment. You see here from the start there, and then they continue here from the blister. Some they end, so they see this is then for this structure. So depending also on the construction, they have these tendons going through. For the walls also, a whole set of tendons. You see going from the start all the way here to the end where they cross each other. And then also at the top, there are tendons here. So tendons is a very important part in this bridge. For now, they have been 3D modeled. With AllPlan Bridge, you can generate this parametrically in each section, how this tendon would be, the variation of these tendons. Yeah, so now it's with a section long curve, you can design then the curve and make a 3D line out of that. Okay, so what I would like to show now here, let's turn off the tendons. So we have our deck, and maybe put the transparency off again so we can see the edges. So you see that this deck here, there is a curve. Again, there is a slight curve where it gets thinner. Then we have this connection with the arc. And I think the only thing that is not variable is the width of the deck. So the width of the deck, if we check, we have the walls. This width doesn't change. The thickness of the wall changes, the thickness of the bottom slab, the height, but it's just the width that doesn't change, but everything else is variable. Now, how can we create reinforcement in one step, not the connection like we saw here, but let's say the main reinforcement that could be used through the whole deck to get quickly quantities or something, or see what design could work. I will turn on now the edges. So here we can see, just to get a better overview, we see these green lines. There's the thickness of the bottom deck. We have this line here which resembles the thickness of the top slab. So these are the edges that your reinforcement would follow. And I will focus on the main deck here. So we don't need to have the DTM at this point. And nothing of this, just the main span. So let's, and then we see here already one reinforcement, and I will just show Oh, sorry, the support structure we don't need to have this. Like this is fine. So I will show now how to create some reinforcement like this. This is still a parametric reinforcement. So if I would check here this rebar, you see, if I move over, I can still select it. It's still being analyzed as rebar. I will show you now how to create something like this. So we have a section, and in a section you define your solution or your bar shape. Can be multiple sections. In this case, it's just one section at the beginning, and this bar shape will be used and will be generated by the lines that I have here. Maybe make it a little bit more dark so you can better see the lines. So for this function, I will use specific reinforcement. So sweep, this is similar to 3D modeling. You can have a sweep function or a loft function. This is similar to that, meaning you have a rebar, bar shape defined, and on your 3D object, I just generated here these lines so you can, it's easier to understand what lines they will follow. So this element needs to follow these edges and the shape will be variable along these edges. Now there's one main thing that you need to do also here. You have to choose the main path, and this is the one that you see here in black, because the reinforcement should always be vertically and should be horizontally perpendicular to the axis. So there is one axis that you use to control how the bar shape is, the orientation of the bar shape. So vertically, because it can be independent from the actual bridge, because the bridge goes down, but all the reinforcement should always be vertically. Yes, so you have control over this to this level of detail. So here, I will select then the edges. So this is the main path that I need to select. I will make sure that we see the whole path like this. Yes. So this is the main path. You can see it goes from the start to the end. And now I will select all the other paths. So here, if I move over the mouse, you can see then this is the edge going to that. And this would be for this point. Yeah. So I will select these edges. This is at the top. So that means these 4 edges give the orientation 1, 2, 3, 4 points. And then in the bottom, I just need these 2. So the other ones I don't really need because this one is just defined by 6 points. So 1, and now you can see the edges going all the way through the other side. So depending how many points you have in your bar shape corresponds with the number of edges you select. So let's say here I will use every 5 meters. Yeah. So, okay. And now this is generated along this 400 meters length. And then you can see, and make it lighter a little bit again. So then you can see how it varies, but it also takes into account this gap, for example. And what we have, the bridge deck, the super elevation is going, so let's see, you can see that here it goes down to this side. So on the other side, it should go down the opposite way. And here you can see also that it goes the opposite way. This is because it's defined by the edges. So you have a bar shape that goes from left, and then if we take a section on the other side, will go to right super elevation. Yes, so this is what can be defined by the edges. So let's say, okay, not 5 meters. This was just to show what I would like to have. It's each 5 meters, like 50 centimeters, a half meter, and then you can see it generates just along the full edge, full length. So this 400 meters, this variable bar shape. So it's quite performant also. So here you can see now better what happens. So as soon as we hit this point, it uses this edge, and then you can see it follows nicely this curve and on the other side. So you have control over your actual, or because of your actual 3D model with the specific shape that has been designed, you can reuse this shape to generate quickly the main reinforcement. For the detailing, you can make then sections at this specific place to create a reinforcement into more detail. Okay, I think this is what I wanted to show for this project. Let's go now to another project. There are 2 more projects that I would like to show.
Sinar mata
simpan kekayaan hatimu. Oh, di dalam senyummu ku dengar bahasa kalbumu, mengalir bening menggetarkan. Kini dirimu yang selalu bertata di benakku, dan aku kan mengiringi bersama di setiap langkahmu. Percayalah, hanya diriku paling mengerti kegelisahan jiwamu, kasih, dan arti kata kecewamu. Kasih, yakinlah, hanya aku yang paling memahami besar arti kejujuran diri. Indah sanubarimu, kasih, oh, di dalam senyummu ku dengar bahasa kalbumu, mengalun bening menggetarkan. Kini dirimu yang selalu bertata di benakku, dan aku kan mengiringi bersama di setiap langkahmu. Percayalah, hanya diriku paling mengerti kegelisahan jiwamu, kasih, dan arti kata kecewamu. Kasih, yakinlah, hanya aku yang paling memahami besar arti kejujuran diri. Indah sanubarimu, kasih,
So let's check here the next one. Now let's go to another type project that I mentioned here in the beginning. So this is the aqueduct. Like, there's a tunnel. Some people say it's a tunnel, yeah, but they call it aqueduct because there is a small canal for the boats to go over. This is in the Netherlands, so they have maybe some competition or cooperation between roads, cars, and waterways, so highway and waterway, and this is a nice place where they are put together. So if you check here, for example, you can see it's also designed where there is a road on top of it, so it's half open, and then there is this part section which is actually a tunnel. So if you check here, we could go to the center or take a look here in the middle, for example. We'll take a good position. So here we see like rotating back. So you can check here, take a look at the different sides. And now we'll activate also the rebar in here. So this bridge model I would like to turn off. So the segment. So now you see we are here in this segment. And then I can turn on the rebar. And then we have here a rebar at the floor, all rebar. So here we can see then the rebar solution with these walls and these curved openings. So this was on the construction of the rebar for one of the parts for the aqueduct or the canal. Yeah, so you have your full model, 3D model, and then you have your rebar model. They exist next to each other, and you can zoom in or focus on the part you would like to see. Okay, now we come to the last reference project. This is the one in the Netherlands, flyover, a highway connection, about 600 meters long. And what is special about this project, from the beginning, it was like a BIM pilot project in the Netherlands. So they thought before the project started about a good way to be able to generate or to manage the project with as much BIM as possible. And there were some interesting discussions in the beginning, because some people said, okay, this 3D model and BIM is all nice, but we first need to make sure that we get the correct 2D representation. Yes, 2D representation is important, but the goal of the project was to see how far we can go with BIM and 3D and get then, as a result, still good 2D drawings. So the approach is a little bit different. Some people need to invest and, let's say, take a risk to invest in the 3D model, generate 3D reinforcement, and then see what drawings you can get out of it. But because the workflow is a little bit different. If you do 2D, then you start with the drawing and you have a plan ready and there is no link with anything else, but you have your plan ready, let's say, in a day. If you do 3D modeling, you can first do all the design, and then at the end of this phase, you will generate drawings. So you will have some time without any drawings, but after a while, you get all these drawings at the same time, and they're related to the 3D model. So this was specific because it was a cooperation between the engineer, the main contractor, and also the rebar contractor. And why is this important? Because rebar contractor could influence have his expertise to how this can be built efficiently. For example, if we take a look at one of these piers or piles of piers, the engineering office, they just say, okay, we do one bar from the top to the bottom, but this again is like, is it 2 meters or 3 meters thick? So there is a varying height of these piles, and they think, okay, we have one rebar solution, this is structurally strong enough, this is fine. But then the rebar contract said, no, this is very difficult for us to have all these bars, and then we need to do it on site. The weather is not so good here, so actually there could be a lot of problem if they need to construct all these piers on the site with do the rebar detailing, the rebar construction or assembly. They wanted to see if it would be possible to generate it in a workshop. So this is what I will show later for this project. First, we have this deck again, 600 meters long with all the spans. Yes, so we have the full model here. And then, so if I turn off the main model, so now we have with the different, didn't turn on the pier, sorry for that. So we have the reinforcement model, we have a pier, and we also have the tendons here. So you can see that the tendons along the whole deck, and they have a special variation where they go like wider and higher. So this is also something can be quite complex. With AllPlan Bridge, you can manage this and do this parametrically. So here we will check for the rebar faces, for example. So let me show the drawing files like this. Okay, and then we have the different stages. So, okay, yes, and this one we don't need yet. So about construction again, so this is for each segment of the deck. Like this, you can see the different stages. You can also see this polystyrene blocks, for example, and then we have the different, so it's constructed not from one side to the other. It starts here in the middle somewhere and then goes to this side first and then to the other side. So again, this is something we can visualize here. And I'll focus maybe on this segment 4. where it's connected with the abutment, and then we can see here the different layers of the reinforcement. So this is pour number 1, where they put like from the abutment, pour number 2, pour number 3, so abutment, and then this is from the column. I will zoom in on that later. And then we have for the deck also the longitudinal rebar. See here, and then the different, we have the transversal reinforcement, and then a lot of other reinforcement is coming together here for the tendons. And maybe I can turn off these different sets here, like this. So now it's really full of reinforcement, where we have the tendon heads, and then to the side also, yes. So we can also see here the different parts. Okay, let's focus on just this one column, and then here I will show the relation between the rebar and the drawing, or how you create actually or manipulate actually a reinforcement. So here we have one pile with the foundation and the foundation piles. What we see here is a 3D model with 3D rebar. So we can check again the bar reinforcement, for example. So you see you have 200 different mark numbers, and here if I move over you can see where all these bar marks are located. So it's again object tree to the, or the tree to the object level to mark number. And now let's take a look at where or how this is actually created. I will put this to the right. To the left, sorry. So we have 3D model here, isometrical view, so you can have multiple visibility or views next to each other. Maybe I don't need this one here. And then what we see here, this is a drawing, just like what we've seen in the layout editor. So this is the preparation of the drawing, but we talk about 3D rebar, and this is a drawing of 2D rebar, but this is still very much the same. So your model is a reference. There could be some sections created, but you see when I zoom in here and I select this bar or move over or hover over, then you see this bar being highlighted. Yeah, so this is actually this bar. Same for this one here. Let's say I would like to change this rebar, so you can just click in a section. So this is a 2D representation of your 3D model. You see this is bar number 9. If I move over, you can also see with the tooltip bar number 9, it will be, of course, bar number 9 right here. Bar number 9, you can select it here also. And we see we have 5 times of 5 bars. Also in another section, you see this is also being selected, and this is 9 bars here. Sorry. Number 9 and 5 bars. So if I would change one, and you can do this with direct input or through the properties. So let's say I would like to have 7. Then I can modify them here. And now you see in the 3D model there are 7 bars. Also the label has been changed to 7, but also in the other section, the label has been changed to 7. So I will go back. So one modification, 5, change it, and now we will have 7 bars. Yeah, so 3D model and 2D is the same thing. 2D is just a representation of what you would like to put on a drawing file. So you can very well create all the 3D reinforcements with all the sections that you need to create it. And then after that, or at the same time, the sections can be used to put on drawing, but you can create multiple sections afterwards to just create your plans. Yeah, so it works both ways. You generate reinforcements in your 3D model and you can modify it. Maybe I can show this right here. Not a good example, but just so you can see how this would work. So I can say I would create in this section a bar shape. So you just choose bar shape, and I will place maybe bar shape, just design it there in the section from there to there, something like this. Okay. Nothing special. You can still say, okay, I would like to have this edge 1 meter and this edge also or end segment, sorry, 1 meter. And then you can do the placement. And then depending on the settings, a rebar will be generated. You can make it generate automatically. Then you see here along the length where it can be applied, you generate in the 3D model just with this section a rebar. So it's located from there to there. It detects the geometry automatically. You can also say, I would like to have it in a specific position. So it works both ways. 3D model, you can generate sections from it, from a specific place to give this detail. Like in the last example, there were 9 sections needed. And at the same time, you can create the sections to generate reinforcement in the 3D model. So this shows this relation, 2D drawings, 3D reinforcement, actually the same. You can use both of them to get 2 different representations, but the reference is a 3D model. So the BIM model is the reference, and you can create drawings, but the quantities and everything, the labels, will show what is in the will come from the 3D model. So if you get rebar quantities, doesn't matter how many sections you have, like this bar, 9, 7, here also 7. I will not get 14 bars in a report. This will be just 7 because it's counted from the 3D model. Okay, now one more thing here. There are multiple sections, so you can create as many sections as you want. That doesn't take much time because you just create a section through an element. And then you see here, for example, a side view or front view from the pier. And then you would like to see here where these bars are located. You can just, again, hover over, select them, and then you can see them being selected. You're also, so you can see actually what is this bar about that they show in the drawing, where is it located. Same thing here, these are all these small stirrups. They're all different sizes. And then if you select them here, you can see them being selected. So you can say, okay, all these bars, they're actually at this layer of the pier, at this height. Yeah, so you always have the relation between the two. Now, talking in the beginning about design. So what is special about this one is the design for the pier. So the rebar contractor and the main contractor, engineering office, they sat together at an early stage. So while the design, or let's say the drawings, have been created by an engineer, the design of the rebar has been created by both of them together, because of course the engineer need to check if this rebar design would work. And then the rebar contractor can say, okay, I would like to have this as not one bar going through the bottom of the pier or so the foundation to the top, but I would like to split it, because that would be very efficient workflow-wise. And then the engineer, of course, need to check it if it would be still structurally okay. So then let's come to the last part here, which actually show what this project then was about. We've seen 3D model. We've seen the design or the 2D representation, but about the actual design, and I have some images here from the project. So let's say maybe first here, so we can see, compare the segment that we saw in the beginning, and this is done on the construction art with the polystyrene blocks and the tendon heads or anchor heads. But this is what is really about. So because of the 3D model, the rebar contractor, they could design this in their workshop. So you see these bars, they're actually not elliptical. They just bend it with a couple of very shallow angle, or not a sharp angle. And they could design this whole pier in their workshop, fit it together so they can do an assembly in a controlled environment, not influenced by the weather. And then they could ship cages. They're actually located next to a river, so the first stage is really put on a river and then put them on trucks, so they can design the cages so they can be transported. But they can all do this in their workshop, and they can deliver on site as it's requested, so they don't need to put tons of rebar on site for the people to work on the construction site to put the rebar together. They just create these piers and they're shipped to the construction yard when the concrete needed to be poured. And this is what we see in this picture here. So you can see these cages being slid in. There is one in the bottom, so this would be maybe 3 cages for this pier. They use formwork, which is very expensive and not so easy to get. So they can reuse now the formwork for the next pier, because they can maybe in a couple, I'm not sure how many days, but if you would need to construct the formwork, or sorry, the rebar inside the formwork, it would take maybe 15 days, a month to do this with a couple of people on site. But now they can just slide in these cages and then pour the concrete in just a couple of days, and then they can move on much quicker to the next pier, because they just have to get these from the workshop shipped to there. So, and then they have because they have a 3D model, they had full control over the rebar. They put the cage together there, and then they're sure they can fit it. It fits on the construction yard. So for them, this exercise was really to efficiently design, but also to be able to efficiently construct. Efficiently means time-wise. So they gained a lot of time. I think this project was open, and this doesn't happen too much for an infrastructure project, 3 months ahead of schedule. So it was a success in that regard. And also for the costs for mistakes and things that needed to be solved, they had full control over it. They created it in the construction yard, so very efficiently, and not much and losses because of faults or mistakes on the construction site. So this was very interesting. Okay, I think this concludes the part with reference projects. I can now go to some hands-on part where we will take a look at 3D modeling and rebar detailing in AllPlan engineering. So this is an example project, and you see here then there's a double curved deck, and you see also that this kind of abutment needs to then be created from this shape of the deck end. So I would like to show now some hands-on modeling, just some steps, so you can see how this works. There are 2 ways to do this modeling. You can do freeform modeling, but you can also do parametric modeling based on a Python, for example. So I will show this part here. Okay, so let's go to preview here. Okay, so we have our view here on the right-hand side as a reference, and I will turn off some elements here so we can focus on my section. So this is actually the bridge section, main section in the beginning, because you see here this is now flat. There has been a part taken there, but if you would take a look inside the bridge here, you would see that this is now, yeah, so this part here, sorry, I clicked somewhere on the wrong thing. Okay, let's check here. So here, make this lighter a little bit. So here you see this part is where the deck ends. So this is the main section of the deck, and we would need to create something for the abutment, which is slightly different. Doesn't matter exactly how, but in this case, this is because there is this part where you connect the deck, so this needs to be a little bit thicker. For example, this is just like an example of how we can generate something like this and model. So I will generate this last section of the deck that can be added to the deck here. So we'll use some 3D, some freeform 3D modeling functions here. And I will mostly use something like extrude and shell to make objects a little bit bigger, use like some drag functions. So this would be extrude, for example. I would like to make this a little bit thicker. So like this, and then you just select the edge, select the thickness. So this is now 1 meter thick. Okay, and here now I would need to be make this, like we see here on the right and left, make this side a little bit higher and thicker. So I will create use the shell function now, and then maybe change the color so we can see what we're doing right here. So I will generate now here from this bottom, from this element, I will choose this edge or this surface and this surface, and now I will make something which is 2 meters down. So what does this shell do? It takes this object and then along the edges or the other surfaces then generates the an additional object. So okay, this is then something a little bit bigger. Now this is horizontal, so I will need to cut it horizontally. So for this we use a slice function. So select the object. So this is just still one object because I generated at the same time. And I would like to slice maybe through 3 points. You can choose a surface also, but from this point it should be like 1.5 meters down. So I say minus 1.5, for example, and then you can see the crosshair, the red dot. So this is this point, and then you can use the track lines just to say I create now a 3D surface. to make sure that like this, and then you see here this is now cut. You can delete it. So we have now this part on the left and the right, yeah, and now I can union. Union means you make one object again. The first one you click will be the property. So if this has already attributes and texture and stuff will be also transferred to the other one. So now I have one object, one full 3D object. So this is with some main functions like extrude, shell, slice, union, typical Boolean operations. Also, you can generate this object. So go a little bit further here. Use again the shell function now from the top. So from this object, I will use the top surface. And then again, along these edges. But here I would like to go down and 0.5 meters. Like this, okay. And then you can see here now this object. I would like to fill it to get to fill the hole so it's straight. So I will use now subtract, and I would like to keep my original shape. So I have the one that I will use to fill minus this one, and then you get two objects generated, and I can use again Boolean to union them like this. Yes, so this is done. Let's say this is almost finished. We just need to have this cutout at the top for the connection with the other deck. So we'll use here the extrude, for example, and then from this surface, and you can generate a whole, or sorry, extrude a whole surface, or choose on which surface you would like to extrude. So I would like to extrude on this point from this one here, and then I go down. It's minus, let's say, 0.2, so 20 centimeters, to this point also minus 0.2, and then here. So this is now extrude, and then you can see green will be adding to it, and you can see this also here. And then, like I would say, the depth now is, let's say, 0.2 on the other direction, minus 0.2, and you can see the red, and now this will be cut out. So let's say this segment is now finished with a couple of functions. Now I would like to generate this abutment. And what you see here, there is a gap, but the gap is different. Like this would be 10 centimeters, and this is maybe 50 centimeters. So I would like to take this shape to make the cutout for the abutment. So when you do 3D modeling, there are many different possibilities, many different workflows. It doesn't matter how you approach it. You can do this with different functions also. So I just show one possibility here. You could also first design this one and then cut out, but I will just start from the same object that I used before, so just from the surface. So I will use the shell again and make now color a little bit different. Oh, not the line color. And then select the object, and here I would use a shell and use the shell for multiple surfaces. So let's take a look on this side, because I would like to do an offset of all the surfaces at the same time. And I would like to do an offset from 0.1. So this is then the gap, okay, that is generated right now. So you see here, this is this 10 centimeter, but at the bottom I needed to have more. So I can use the shell again. Click element, so the green one now, select the surface you would like to have, and now I can say this should be 0.4. So because of the options that you can set here, you can choose, okay, it should be perpendicular to the surface, or it should follow the edges. So here follow the edges is right, and then I have here now this part, the cutout of the abutment. So let's just union these two. Okay, so now I have my main end of the bridge, and I have this cutout. So now I can start with the abutment. So let's say this first part here. I will create a box. I'll use orange again. And now I will generate it also with some offset. So instead of clicking the right points, I will use relative points. So relative from this one that I have here. You can see here also. So let's say from this point, I will use a half-meter offset, for example. So you see this is in relation or relative to a specific point in your 3D model. You can use this to do modeling, so you don't have to, so you see here, put this on the point, you don't really need to create it first and then move it or change it. You can just do it like this to generate the object based on the relation of these points. Actually, I just wanted to show one point here because it needs to be wider, or it doesn't need to be deeper. So this is then 0.5 on this side, and on this side here again minus 0.5. Okay, and then the height of this section, or the height, should be something like let's say minus 5 meters. So you see always the preview, and then if you confirm, then you get this object. Yes. So okay, now you see this is wider a little bit. I could just generate it also and then extrude for like that, but you can enter it the first time right if you know this offset to a relative point. Again, here I will use the subtract. So from this element, I will subtract the main bridge. No, I will subtract actually this green part because that is the cutout. Would you like to split? Yes, because I still have this element that now can be cut. So now I have the abutment really taken over from this element with the depth here in the bottom. So now I don't need to have this green part anymore, so I can delete it. These objects can be parametrical objects. The bearings, you can design them 3D modeling. It can be like a smart symbol, a block, so many different ways to do this. Then you can get all the attributes from it. They can even be generated from AllPlan Bridge, for example, at the right position. So here I will go now a little bit further with modeling this abutment, just 2 or 3 steps more. First, I will make this again a little bit thicker. So let's say 1 meter here, 1 meter. So like that. And now here I would like to create a block here on top. So also we can do this with extrude, but then with a rectangle maybe, or a polygon like this. Just choose the surface, and then you can say, okay, I would like to put it there, there, and in this direction should be 0.4, something like this. And then the height should be as high as the other object. Yes, so then you can see you use the other object's relation to model it, and I can do the same thing on this side. So use the extrude function, or just put a block also on top, doesn't matter too much, on this surface. And then from this point to this point, and now again, so you put your mouse for the reference, and you can give a direction, enter a value, and then click another point for the height. Yes. Okay, so here almost finished. It should make this a little bit longer. Now, again, there are multiple ways to do this. You can put a block there, or extrude one step, or multiple ways, or one element, other element. So I will use here extrude again, and then create the polyline. That means from a surface, again, select the surface, I can define now this shape. So here, click on the points. Maybe I can change the color so you can better see where this line is being created there at this point, and it will stay within the surface. So here it should be 0.6, for example, in this direction. From the bottom, again, and then go to the right, it should now be 1 meter. So I have generated the surface, and now you can set this here, and this maybe is like 4 meters or something. Yeah. On the other side, the same thing here. So click some points, take over the points, choose a direction, put a value, bottom 1 meter, okay, and then extrude to this side 4 meters again. So now I have this element almost ready. Now we'll create just one box below it for the main foundation plate, let's say, and here I will box, and then choose again these points. So minus 0.5 for the reference, so, and then 0.5 to the other side here. 0.5 minus 0.5, and then you can set the height is like 2 meters. So, -2, for example, yes. So here now I have these elements. For the representation, you can see texture can be automatically assigned depending on the color, but I can also say, okay, this object here, I would like to have assign it a different surface. So maybe from this project, I would like to use some other type of concrete, maybe this one, and then the object will be generated with this surface. Yeah, so different possibilities also for visualization. So now we've seen here, this is a freeform modeling. Now I will put next to it a parametrical abutment with Python. So Python is programming language that you can use by yourself to generate objects for Python. So this open API. If you have experienced people with Python, they can create these parametrical objects to be used in AllPlan. And here I will just take a standard one. A standard one from the default library, engineering, and here there is, for example, abutment. I can place it maybe at the same point as this one in the bottom here. You can see with the trackline references, and I would like to change it with an angle of 90 degrees. So it represents more or less the same point. So I place it here, we'll just escape. You can see there are handles, there are a lot of values here. But now this is a parametrical object. That means I can modify it after a placement. The other one, 3D modeling, can still modify it with the Boolean operations or 3D modeling functions. But this one is generated by parameters. That means for some things, it can be very easy to modify something. So I just double click it. For example, we have the angle between these two, between the wing wall and the main support for the deck. This angle can be changed, for example. So we have wing wall here, should be now 60 degrees, for example. Then you can see, you can just put a value here, or it can be a handle, and then this object will now be different. If you need to do this with modeling, then you need to slice, you need to cut, you need to change some parts. So this is very user-friendly and quick. And it can be, with the Python part, you can make sure that it follows some rules or parameters or things that you have set that make sure that the object is not out of specification. So here, let's say, you can take this one here, and then you can make it also wider, and then you can see what happens with the bottom element. So everything is linked. You can make this a little bit lower. You can make this also wider. Yes, so you can quickly adapt it with parameters. So it can. This is then the advantage of a Python part, where you can change parametrically and still be able to modify it later. Okay. Then maybe the last part right now, and I will go into some reinforcement. So I will open just this one file that I have here. Maybe we don't need to have the parametrical element anymore.
So we both better go out. Don't need a reason to keep on dreaming. No, we don't need, yeah, we don't lose. I don't need a reason to keep on dreaming. No, yeah, we can win at anything at all.
Okay, so now we'll go here to a plan view, wireframe. So this is the top view for the 3D model, and I will create some section or visualization from this element, similar to what we've shown before with the pier, but now go step by step also with the views and sections, and then generate a couple of rebar. So views and sections, you can generate a section around the element through part of the element. So let's say I would like to have a front view in this case. I will just put this here. This is a front view. You can also configure how you would like to see it. So can be, would you like to see bitmaps, for example? I will just place it here and then modify them afterwards. So this is one view, and I will create another one with the same boundary of the section, but now a free view, so it will be an isometrical view, and I would like to take over this view here. So I click on the right to take over this view, and then I will get this representation. So again, how you would like to see these elements with the bounding box, with the colors, these are things you can configure. So let's modify both of them here. And I would like to modify both of them. I don't want to see a clipping path, for example, and I would like to see them with some texture. So that means the same textures that we use here. And I would like to see shadows, maybe. Not sure if you will see anything. And maybe for layers also, you can choose in these two, I don't want to see maybe any reinforcement layers. So if I would use reinforcement, I don't want to see them here, because this is for representation and not for reinforcement. So you have now your two elements with the references I've set here. Maybe is the shadow is not. So here you can see also how you can set the shadow, maybe 45. Do I see something different then? So here you can see now there is a little bit of shadow. So depending on how you set the values, you can see a different kind of shadow. If you need to have this, yeah, so okay, that's fine here. Now let's make a reinforcement section. Maybe I would like to place some reinforcement just in this part here. So I will create again a new section. You can create a section from a section. So let's say from this one, I would like to create something where I see this part, for example. And I would like to look from this side, just to have a view from the section. And in this case, I don't want to have any texture. I just want to see this here, so it means no shadow or no light, anything. Maybe, and this is just a view. And now I would like to create a section again from this one or from the model also. So you can choose wherever you want to create your section from. So let's say I will create a section here that shows this part. And I look from this side. And now for this section, for this section, so hide from the elements, like this. Okay, so again, nothing from this setting. So these can also be a favorite where you configure it how you'd like it to look. You can also set if you want to see clipping lines. Would you like to see hidden edges? Would you like to see a filling when you cut something, different elements or different parameters, line thickness, line colors, things like that. So here you see the object is now just a black line and filling for the section, so you can see it's a section. And now I would like to maybe turn on this one here, some hidden lines, formats. So you can do this whenever you create the section or modify it afterwards. So here I can see now these hidden lines. So I would like to place reinforcement here and reinforcement in just this top part. Very simple, just to show the workflow. So create views and sections. And then here I will create, you can see there are multiple bar shapes that you have. You can set here also, or choose from the schematic. A bar shape is defined by a steel catalog, cross-section catalog. So depending on the cross-section catalog, you can have different diameters, and depending on the standard that you have, the calculation will be different. So here you can choose different kind of standard, ACI, British standard, Euro norm, and also a concrete cover are linked to the standard. And for the labeling, for example, you can also choose how this label should look to make it sure that it's localized. So different countries have different types of labels, so you can just choose for how you want to see something and in what position you would like to see something. So you can just drag and drop. This one should be another position, so you can configure these labels also. Next to that, we have a cross-section catalog. So the cross-section catalog is something that you can also define or can download, and there are depending on the country standard you have. So I'm working with the Belgian country standard, so I have the Belgian cross-section catalog for my rebar, and then I have different diameters, different steel grades. So you can also modify one where you say, I would like to have different diameters with different settings. So this is all taken into account when you create reinforcement. So here I will generate reinforcement, just a free form, and just click some points. So I click points in the 2D section, taking over the edges. Diameter 25 doesn't matter here, it's quite thick, but okay. And let's say here, in the two segments should have the same length. Both of them should be 2.5, for example, and this should also be 2.5. Bar shape is generated or created, and now you can see also that the placement is done automatically if it's the full length, or I can say I don't want it to be the full length. I would like it to be just from this point to this point. And then you can see that you can control by yourself where this rebar should be generated. Okay, or I would like to define it again from this point to this point. Yes, and you can set the spacing should be different, maybe 0.2, for example. Things can be set, or you want to have a number of pieces. So this is, let's say, the first bar. Now, for the next bar, I would just use a straight placement. You can create it with free form, or here and just make it react to some of these lines. So, okay, 25 doesn't matter also. For the placement now, I will place it against an existing bar. So instead of defining the position myself, I will say, okay, place it against this edge with a spacing, or so you can see it will be generated along this edge. I can say it should have a spacing, or it just have a number of bars. So I can say, okay, just put 3 bars there, or I would like to have a spacing of 0.2 also in this case, or 0.5, for example. You can modify it. You can also modify it later, like we have seen before. And then we have the rebar in 2 different views, also in the 3D model. So let's turn this transparent maybe a little bit, that we can see the rebar here. So rebar in the 3D model. And now I will do some representation. So for this one here, I would like to see just the middle bar, okay, and for the horizontal bars also the middle bar. And then I can add some labels to it, maybe with dimension lines. So here, this configuration comes from the options. You can still set, if you would like to see the spacing or other things, you can define also how it should look. So we'll use a dimension line with dimension line options here. So, okay, this one is placed from there to there. Okay, dimension line with the label, wherever you want to put the label. And this one here, for example, should be there. You can say show bar markers, for example, that you can see here also that it with what bar it links to. So we have here this 5 bars, diameter 25 every 50 centimeters, and we have every 20. So this can be set, should be millimeters, should be meters, things like that can all be configured. And as the last part here, I will do another type of label where we have a com, for example. So you have com, maybe I can show the difference here. So select the placement here. You can see all bars are selected. You can still choose, I would like to have a dimension line with the preview, or I would like to have a fan. And then there are still different configurations like this. Would you like to see all leaders or no leaders, or just a start and end leader? So many things can be configured for this label. I will go to the COM. And then for the COM, for example, we have here with a different offset, and then you can place this bar like this, for example, or below. Up to you how you would like to define this. And maybe this with a normal label to the other side. And depending on options, where you are with your mouse, you can also say, okay, it should be automatically positioned. So we have bar mark 1, 2, nothing special in the 3D model. If you go back to my object palette, we can, of course, also see this here. We have bar reinforcement. We have our different bar marks. So wherever I select them here, you will see them in all views and sections. Same here. If I select this bar here, you can still modify this. For example, with the direct inputs, should change the value, should change the length or the distance in between. And maybe as a last thing, I can put a schedule next to it. Just a very simple legend. And then we get here the overview of this bars. So this is taken again from the model. So if I would modify one, and I will put this here bottom. So let's say if I change now placement, for example, here of this open stirrup, I would like to have it every 30 centimeters, 0.3. So that would mean you see the label changing here, 20. You see this label changing, and also, of course, you see what is changed in the schedule. So you don't need to manually recalculate, check your drawings. Everything is coming from the reference 3D model. Our quantities and our labels come from this 3D model. Okay, this is everything I wanted to show about 3D modeling and rebar detailing in AllPlan engineering. Now we will go to the next part and dive in AllPlan Bridge, where we will do an introduction of the possibilities, how you work in AllPlan Bridge, what the parameters are, what the links are between different elements, and we will do that with the getting starting example. The getting started example is included in AllPlan Bridge, so it's easy for you to start with, and there's also a manual included. So we'll go through this example. So when you start AllPlan Bridge, you will be greeted with this welcome screen, and there are examples, and this is very interesting if you want to get into the software. There are multiple examples, different types of combinations, with different types of designs, and each of them has something integrated where you can experiment with to see how this has been done, some small explanation. And here for this getting starting example, there's also actually a PDF manual included with all the steps to create this from scratch. So if you want to dive into AllPlan Bridge, try out something by yourself, this is a very good way to create your first model. It includes many steps, the setup of the parametrical model, and also goes into analysis. So we'll start with this example. And this is a concrete bridge with tendons. So here you can see the bridge model with the color coding for the different types of elements. You can see the tendons also. And I will put this here. Okay. So with the interface, you have the action bar with the different task areas that you have, and you have then a palette where you navigate to different parts of your project or your model. There are different ways to visualize also something depending on the materials that have been defined. You can also say, okay, this is like now we see concrete texture, for example. So there are different ways to set this up. Steel can look differently. So there is also some different visualization types possible here. So what do we have here? We can see we have a bridge with two piers. We have tendons. We have actually a different phase. You can see that there is overlapping tendons. So there will be one phase here, another phase. I think there will be 3 phases. So this is just this getting starting example has everything included, and we can go over the different elements just to see what they mean for AllPlan Bridge. for the parametrical model. And after that, we will do some step-by-step where we go through how we can create a model like this from scratch. From the design perspective, so we are here in geometry, the structure, similar to what you have structure in AllPlan. And we see here the different, let's say, steps or main elements. We have axis definition. So axis is a geometric element. You can see this here in red color. This is the axis. We have to define some cross sections, multiple for the pier, for example, for this one here, for the main girder. We have variations. And here we can define tables. For example, how the height of this bottom of the deck should be variating. Not necessary this one. You need to have axis cross-section, yes, but the variation tables or the variation is something that you can define if you need one. And then you have the structural members. This is actually the 3D objects themselves. So you have an axis defined, you have a cross-section defined, and with these two together, you generate your 3D model. In this 3D object, let's say main girder box, which is the blue one here in the bottom, you have still all definitions from cross-section and axis. So if I check here, stationing, what is stationing? Typically, the stationing is what you have here. You see 0.5 meters. This is stationing along the axis, not necessarily defined by the axis, because you can, in the main girder itself, you can define, or when you create it, and afterwards also, you can define additional stationing. That means the stationing is not limited to the stationing you have in your axis or in your profile. So it gives enough flexibility to add stations by yourself. So if you check here, the stations, so these are all the stations being used, so you can just add a new station somewhere if you need it. You can also see in light blue where a pier is attached to it, for example. Cross-sections. Cross-sections, you will see here what actual cross-section is used on what station and what variant it generates. Yes, so you get an overview from this is this main girder, and there are many different variations because of the variation tables, different parameters being used. And then at the end, the third one here, you have an overview of all the variations being used. So we have, for example, web width, and then we see that it varies. We have the thickness of the bottom. We have the height of your cross-section. Yes, so there are different tables. I will show later where this exactly comes from. But you have the stationing along the axis. You have a cross-section which is applied to stationing, and then you can also get the overview of what variation actually is being applied with what value. So you have this table value where you see the actual value being used at this point. For the piers, the same thing. You have a stationing, cross-section, variations. Now, if you go a little bit deeper here, with the axis, for example, so we have our axis. How is the axis defined? If I check the axis in plan, then you will see the elements that have built up this axis. So we have a starting point. We have a first segment, which is a line, 15 meters. We have then a spiral or clothoid with this specific definition. So it starts at 0 and then has a specific length and a parameter at the end, curvature. And then we have here a radius. These are parametrical elements. That means I can change the radius. For example, I will change this now to 200. And then you will see the axis being changed from minus 200 this way to 200 going this way. So it connects still with the other objects. If I regenerate my model, then you will see that everything will be recalculated depending on the elements that you choose to be recalculated. Like at this point, I've also set the analysis model to be recalculated. You can just choose, I just want to see the geometry being calculated because I'm still modeling the geometry and don't want to update the analysis results. Then you can also set this. So here now we see that the bridge has changed. We see that in this case, the axis has changed, but the super elevation at this point is not right because it is for a turn that goes the other way. Okay, you can set this, can have control over all these parameters individually. If you want, you can also link different parameters with each other. Maybe at this point, because I rechecked the analysis model. For the analysis model, we can also go to the results, for example, of the cross section. So here we have the cross section, and we have the different variations. And if I check here variation, then you will see this display of the cross section calculation with the different values. Yeah, so you get this here for each different variation. Then you can see clearly also how the super elevation changes, how the height of the section, cross section at that place changed. So you see it very well, which one you're being used in here in 3D model, and you get the results right here and all the values. Okay. So let's do other update or another check here for the. I will first generate the geometry again, maybe change the axis back to its original value. So minus 200, for example. Oh, no. Yes, so minus 200, enter, and then we can see this being original situation again. We have the axis, and at the same time we have the profile. So the profile is along the length of the axis. It's 155 meters. You can set heights. You can also set a point, and then by a tangent or by a radius, you can set also how this curve should be calculated. So at this point, if I check here, you see the rounding type is being applied with a radius to generate this curve. So these stations are actually generated by the profile, and no need to have them here in the axis, for example. Okay, then so we have defined these two elements, axis and profile. Together they form your 3D axis. Okay, so I will do a final general recalculation. Also with analysis result, then we will go into some analysis display. So if you check the results, for example, you can choose to highlight different combinations. So let's see if I have my analysis model. There, yes, okay. So we have 3D model, analysis model. So depending on what you choose here, what combination you choose, you will get a different part of your model and different visualization. So for example, if we check, for example, here in the bottom, I would like to see for the wind loads, for example, wind, different types of combinations have been set here without traffic, with traffic, for example. So we can highlight it. I don't want to see the diagrams, for example. I would like to see the deformed structure, and then you choose here what case you would like to have, and then you can visualize these different parts. Okay, so if I go up again to, so we have here with the tendons, temperature, braking, wind, so different types of elements that you can visualize. And here you can choose then what load cases you would like to see, for example. And then depending on the diagram you activate, you will see some different element. Yes, so you have full control over the different parts, and you can just activate which one you would like to see. Okay, so here you can see, for example, the deformation also being set. You can play with these values to see exactly how it's represented. And then you can see, for example, I don't want to see these diagrams, for example. You just want to see the deformation type for wind, for example. So you can choose what elements you would like to see, how you would like to visualize it to give you a good impression of the things that will be happening in your model, and compare the analysis results. Okay, so let's go back to the 3D model here, the geometry. So we've seen axis and plan. Yes, and then next step would be taking a look at the cross section. So in this cross section, main girder box, you can choose any type of name you would like. And here we have all the different elements that are defined in the cross-section. So we have our main girder, we have then the additional elements being added to it, like a barrier, for example, which are not part of the structural element. Everything is defined by reference points and parametrical lines. So you see here these gray lines, parametrical lines. What does that mean? It's how I can control how this section behaves. For example, the one here in the bottom, if I click on it, you can see possibilities, and I will change distance. And now if you change the distance, you see what happens here. The web wall on the side, they will be just keep its own orientation, but the main girder will become higher. So the cross-section will become higher, but if you see also in the bottom will become actually smaller or less wide because of the angle of the web is fixed. So you can define this also how the different elements should behave. If I click another line, then here you will see now that the thickness of the bottom can be controlled. But that also the chamfer that you have on the right-hand side, this one here, it just follows web and the bottom of the deck. Yes, so everything can be linked with each other. So this is the definition of this parametric lines. You have a line, you can set it to parameter, and you can link another line to each one. So again, if I change this one here, you can see the bottom thickness doesn't change. It just follows this main line. That means this one is linked, and you can see it in the preview also. This line is linked to this line. And we see also that this line is linked to the main reference line, which is through the axis. So that means if the bridge goes up and down, this will follow, of course. Other example here is the inclination, for example. So I check here this line, and then you can see that I can change the angle, and now I have control over the super elevation of the deck. And what is special here, this part where you have the barrier is not influenced by it. It has a fixed angle. So if I go to this side, you can see all the other part of the deck will change, but this one has a fixed angle. So again, you can define a relation between a line, which will probably be through this point, with a fixed angle in this case, and this follows this point. So if this moves up, this angle stays fixed, but will move up also. So in the cross-section, you have different types of parametric lines that you can create. Just a parallel line, through points with an angle or with a relative angle, linked to two different lines. So many possibilities to define how these lines should behave. Next to that, we have the reference points. Reference points can be used, for example, here to put a bearing. This could be a bearing, or it could be a connection with a pier. It could be a lamppost, so you can add reference points to it that can be used for smart placement. And you can also see that the analysis model is being included here with the other colored lines. This is a grid, a point grid, and this is used for the tendons. So if you access a point grid, you can still access the parameters here. So, for example, I have a row of 7, or 2 rows, sorry, you can see here 2 rows, and then in the other direction I have 7, so you can still control, okay, the spacing should be different, or the spacing should even be controlled by a variable. Yeah, so let's say I want to here just have 5, for example, then you see you can change this to 5. If I update my model, this change will, of course, be applied to my geometry. So cross-section, main principle, you have your parametrical lines and reference points. You define then a boundary which uses some of these points, and the relation between the parametrical lines will then be kept and will define how your cross-section will variate. So we see here, this is linked to a variable. Yes. So you see here that this is linked to a parameter, height of the section. So what does this mean? I can define in my main girder a height of the section, or the name that you can give, doesn't matter how you name it, height of the section, which has its own, let's say, default value. And then when you assign it, or when you assign this variable to a parametrical line, you just do this also here. You can say, okay, it shouldn't be assigned to any, or it should be assigned to the height of section variable. That means you can control it now outside of your cross-section. If there is no variable set, then it's just a fixed line. You can modify it here, but you cannot control it. So this is important when you design and get more detail, more depth to your model, that you will be adding variables to it. You don't need to have it, then you get a fixed model which doesn't vary along the axis, for example, but you can still modify it here. So if we check again the main girder box and the variations, so we are in main girder box cross section. This is the girder. So if you check the cross sections, we see here again which cross section is applied with a variance and variation. Then we can see what variables from the cross section are actually being used in this 3D model. So here we see height of the section, which just comes from the cross section. Actually, each one of them will be visible here. So you see web width, half, bottom thickness. These are all variables coming from your cross section. So if you generate this in a cross section, this will be automatically added to the tables here. You don't need to do anything. It's automatically done. What you have to do, or what you can do, is define how the variables will be used. So here you can see this different values, like the default was for something 4 meters, but now you can see actually there is a lot of differences. We can see this also in the 3D model. This is the default height, let's say. This is fixed, but then we have some variation. Where does this variation come from? How can I control this variation? We can see here that this the values are being changed. So how actually can you do this? You can just set this right here. I can say this should be 5 meters, for example. 5 meters, I can apply, and then everything will be 5 meters high. Okay, let's say this should be 3 meters, for example. Everything should be 3 meters, apply. And then if I regenerate my 3D model, so here we can see now this model here is being generated like this. Okay, so let's check these variations. Everything is 3 meters. Yes, not within how it should be. So how can I control it? This is done with the variations tables. So again, the link, you have a cross section, which with parametric lines, you can set variables to assign variables to the parametric lines. They will be used in your cross section. You can just enter them as a table and just put the values by yourself. Or what's more interesting, the next step would be then to create a variation table or formula, in this case, a table. So if I would check this, height of section, then we see here that we have this type of construction, this type of variation for the bottom of the cross section. It means the height of the section. So by station along the axis, you see 0 to 155, you get the different heights, 3.7, 5.2. So from this point to this point, 3.7 meters, and then from where you have the pier, you have 5.2 meters. So you see here how it's generated. You see also which type of transition is used, linear or parabolic. So this table, with the graphical representation that you clearly see how it will behave, I can assign to my variations in the cross section. So you can say, okay, I just added to one cell, for example, let's say this one here, and then it will be calculated. You see this jumps to 5.2, or I can apply it to just drag and drop it on top of the column header, and then you will see now this will be generated, and all the heights corresponding to the stations will be calculated. So you don't need to define each station individually. Just from this station to this station, this type of transition will be used, linear, parabolic from there to there, and then all these values are calculated. If you add a point to it, a station to it, it will be automatically calculated what value it will be depending or corresponding with the variation table. So if I now will not forget to turn off these things here, I think this is enough to just turn off that one. And then if I regenerate, then my 3D model will be generated. And now it should be the original state again, where we have the deck bottom corresponding then on connecting with the piers again here. So now we have this height setting. So let's say if we want to adapt something, this can be done in this variation table. And let's say this should now be, and I will exaggerate a little bit so we can see the difference. This should be 8 meters. So you can just assign the value to it. This will be adapted. The variation also will be adapted as soon as you regenerate everything will, so the tables will adapt and the 3D model will adapt also. So let's say regenerate. Now the model will be recalculated and will include, now you see here 8, will include this variation that this is now changed. This is what is done internally. What is also interesting is that AllPlan Bridge has an open interface by going through a TCL file. And this is a text format that you can read and you can just modify it. So if you want to have external access to this file, you can just say, I will save this project here. And so this is, let's say, 01. And I will also open it, this file, with a text editor. And then you have all the descriptions here from the axis, from the cross-section, from the variations described in this text file here. So you see, okay, this is the axis, the profile being described, and here we have already the variations, so the height of the section. We see this is this 8, so I can change this in the text file and put this again to 5.2, for example. So that means you can copy-paste things from other software. You can also play in this table to do some, or in this text file to do some optimizations, for example. Okay, so save the file, no need it anymore. And now I can import it. So remember, this is this 8 meter. I can import it, this file again. So just modify it externally. Do I want to regenerate and overwrite? Yes. And now my 3D model will be, or the full model will be regenerated. And now you can see again that this is the correct height. So this can be an interesting case where you have this open interface that you can use to change the values and adapt some elements of it without, or just by accessing a text file. Okay, about the tendons here. So we have the tendon generation. We saw in the cross-section that there is the tendon grid, the point grid here, and the tendons are used. And when you define the tendons, you can choose what point will be used. So let's take a look at that. We have this tendons here. You can see that actually it seems there are redundant points, but this is because you have different stages and you also have tendons which are then overlapping. So probably stage 1 goes there, where you have the end of these tendons here, and then you have another where the tendons are already embedded in the structure for the next stage. Yes, so these tendons are then defined on the points, and because you have multiple points, you can just choose which one you would like to have there, and then you have enough space for the other tendons to go in between. So it can also be generated or controlled by parameters if you need more distance to it. I think we will see this here. Like at the start, they will be, or here in the middle, they will be very close together, and here where you have this multiple tendons connect together, you have a bigger distance between them. This is also controlled by the variation tables. So you can define a tendon in different ways. You can set it through points without having the points variating, but here you can see the points, there is some variation going on with the height of the tendons, with probably the distance between them in 2 directions, and this is what we've set here as a variation table. So check the tendon height, for example, and then you see the evolution of the tendon within the main girder, the deck. So at station 0, this is the height. And then it goes to 3 meter, for example, 3.6. So depending on where you have the piers, so you will have this tendon height being variable like this. So this is something that you can get from a calculation, for example, and input the values there. This is the spacing in the height. And then you see again along the length of the bridge that the spacing horizontally at the start, of course, where you need to have the anchors, the spacing is a little bit wider, and then the parts where there is no connection, no anchors needed, it's closer together. And the same thing for the spacing vertically. So vertically, we have this 0.2 spacing, and then 10 centimeters, let's say in the bottom of the deck where there is no interaction with other tendons, and then above the piers you have again more spacing, so there is more space between the tendons also. So this is what you can control. So these variables, they control the tenon grid. So same principle, if you check again the section, like you had with the parametrical lines, same principle is here with the point grid. You can see the offset here, or spacing, is defined by spacing horizontal, and spacing here is controlled by spacing vertical. And then the offset that we have here, there is no offset horizontally, but there is an offset vertically. So this is the height of the tenon grid, where it's positioned so that it flows along the 3D model from the start to the end. Yeah, so same principles of the parameters and the variations that you can set. You can start with a very simple cross-section and add to it for the geometry, add to it for the tenon grid, and then add variation tables to see how they will be controlled. Now let's dive into one of these tendons. Here you would like to have, like maybe depending on what kind of construction you want, do they need to be stressed? At what point do they need to be stressed? Do you need to have blisters or a wall where this web would be thicker, so the tenon will be outside of the wall a little bit, so you can still have access to the anchor and stuff. This is what we will check now. So for the tendons, let's say, so you also have different phases. For the stressing and stuff, they will be used. Let's just go in the modeling of the tendons here. So we have the view of the tendon model, where for each tendon, let's take this one, for example, here. So you see this tendon being highlighted, and you can see also its parameters. So at this station, which grid point it uses, you can see it here in the cross-section, and then you can go through the different sets. So if I look from the side, for example, and then you will see that it jumps from one point to the other point. So for each segment, and then you can check here where it's located, and here also, and then so you can see it going through these points, and this is what the tendon will follow. You can still interact with these points, so you can even change the grid point, that reference point that the tendon uses. If you want to switch it from there to there, you still have full control over it at the end. An example that I want to show here is for this tendon that we have here in the middle, for example. And I will zoom in on this number 4 or 5. So this tendon here at the top. I'll zoom in a little bit. So we see this, this tendon here. And then I want to see it so where it will be then going on the inside of the wall. So we see here it's still inside of the web. And I would like to be here to jump a little bit on the inside. So what point do I need? I can check here from the station point. You can see here this is this point, and now I can change a value where it should deviate from its position defined by the grid. So let's say this should now, and I always forget it's plus or minus, so 1 meter to the side, and then you can see here it will be located there. If I regenerate, maybe this is a little bit too much. Let's say 0.5, can recalculate in the tendon geometry definition. So there you can see also that it's now being positioned like this. It will still follow the grid. It's just that there is now an offset to define. So no need to define this in the beginning. You can change this afterwards depending on information that you gain, like anchor type or whatever you need to be able to construct them to see this also in a detailed model. So you have full control over all these things, all elements and all parameters. Okay, I think this is it for this hands-on introduction of AllPlan Bridge. We are now at the end of our presentation, and I hope you enjoyed the workshop. We will now have a Q&A session in case there are any questions.
Oke, jadi menarik ya teman-teman ya. Jadi sekarang kita akan masuk dalam sesi tanya jawab. Teman-teman yang mau silakan slide dulu. Saya akan ingin. Hi Stefan, are you ready?
Yes.
Okay, so I will try to read one by one because we have a few questions. I don't think that we can answer all of that, but I will try to start. Okay, it is a question. Are there any plugins or features from AllPlan to integrate AllPlan with structural analysis software such as START or RISA 3D or only with the SKIA? Can you answer that?
There is no direct plugin for AllPlan, but the main exchange of information is through IFC. So you run an IFC model, you can take the geometry from the IFC model into the analysis software to do some calculation. There is now a new development. I think Ralph will show something or could show something about this in the BIM Plus webinar. There is a BIM Plus a plugin that can convert a 3D model, maybe from IFC, to analysis, to a statical analysis model. And this can then be used and transferred to Excel file or kind of Excel file where you have all the information, and this can be integrated into or used in other calculation software.
Oke, jadi untuk pertanyaan dari teman ini nanti mungkin di sesi kedua akan lebih dijelaskan. Nanti masih ada satu sesi lagi dengan Mr. Ralph berkaitan dengan itu ya. Oke, we are going to the next question. Is there any maximum number of the rebar that you can put or model in AllPlan? Will it be becoming so heavy or something like that in theory?
I'm not sure about the maximum data because in AllPlan you have the project structure, so you can structure your project to have a very large amount of rebar, just split in different parts, but there is a maximum number of mark numbers that you can use. So number of mark numbers is 9,999 on one drawing file, so you can have multiple sets of this maximum number, but there is no hard limitation. It's just the size and how you organize your project.
So in principle, no limit, is just how you structure your project, right?
Yes.
Okay, we are going to the next question. In case that in Indonesia we have maximum number of 12 meter lengths, how can AllPlan help us to locate the splice and also apply the length left automatically?
Yes, so you can set in AllPlan the bar length that you would like to use, 14 meters, 12 meters, for example, and then depending on the function you use, AllPlan will split automatically the rebar and define the overlap depending on the concrete grade and the standard that you choose for calculation. So this is integrated in AllPlan. You can also choose not to use any splice, to use just a factor of total length, but there are different possibilities. It's also possible to splice rebar after it has been placed.
Okay. So in principle, it's possible, and then you just need to set it. Okay. Next question: how effective is a bar class check in AllPlan?
How effective is the class check?
Bar class check.
Yes. So you can do a class check. It's a hard class check. So there is no tolerance that you can set. It's just there is a clash yes or no. But in BIM Plus, you can do a clash check with tolerance, and you can define clash check between different type of components. So in AllPlan, it's rebar versus rebar or rebar versus concrete inserts. But in BIM Plus, you can do more types of clashes.
So you can say that in BIM Plus, we can emphasize or we can make the clash check is even better, yeah?
Mm-hmm. Yes.
Okay. So in actual construction stages, revision to the project may happen. How AllPlan handle this modification if you already create a shop drawing? Will the drawing will be react automatically? And how you handle this modification in the real project?
Okay, so you have the two options. In AllPlan, when you model something and you make views and sections, everything will be auto-updated. You can choose to freeze this and say, okay, now I create my plan and my plan has a revision and will not change. But you can also choose to update yes or no your views and sections. So if everything is auto-updated, you have a revision of a plan, you create a new revision and everything will be automatically updated.
Okay, so this may be the last question due to the time frame. Okay, how to export 3D reinforcement to CAD software, either 2D or visual, not as just a line.
Okay, there was a short part I didn't hear. Can you say it again?
in AllPlan, you can create a 3D reinforcement. Is it possible to bring this 3D as a 3D into a other CAD software?
Yes.
Because some software you just bring only a line when you bring it into the
Yes, so AllPlan has then complex and intelligent reinforcement. If you export it, you will get a 2D representation, but not a 3D reinforcement because it's a special kind of object. You can, in AllPlan, choose to convert it to 3D solids. So then in AllPlan, you get solids and you can create 3D WG, and then you can open this WG with the other software. But the best way to do is this by IFC. So export AllPlan rebar to IFC. You have a full intelligent rebar model that you can check in other software. Open it, check the attributes. A good example of this is BIM Plus, but there are also other software that you can check the rebar. So you have all the information about the placement, diameter, and things like that.
Okay, one last question, yeah, Stefan. So, what do you think? What is the advantage of the AllPlan 2021 compared to other software like Tekla, like Revit and something, in your opinion?
So with AllPlan 21, this is the new version. The focus was very much on performance. So to be able to do more large-scale projects in a more efficient way. So there are less limitations on software and can use the hardware better. But it's a continuation of what AllPlan was already able to do. So now it follows the current trends. So you can do complex reinforcement on large-scale project. I would say that is the main benefit.
So that is the thing that you are trying to highlight as the benefit of using AllPlan. Now it's even faster, isn't it?
Yes.
Okay. Okay. I think that's enough, Stefan, due to the time. So I will try to close. Jadi teman-teman, terima kasih sudah mengikuti sesi daripada AllPlan Engineering maupun AllPlan Bridge ini. Jangan lupa nanti kita masih ada sesi berikutnya setelah istirahat. Jadi saya serahkan kembali ke MC. Terima kasih.
Ya, terima kasih.
Terima kasih banyak Bapak Siswanto selaku moderator pada siang hari ini.
Thank you Mr. Stefan.
Thank you Mr. Stefan. Thank you, Mister.
Thank you, Mister. Aduh. Dah, Mister.
Where are you, Mister? Oh, here. Oke, dadah, Mister.
Aduh, aku tadi itu kan lagi lihat-lihat. Coba nyanyi, Mas.
Apa?
Nyanyi. Iya.
Kalau ku pandang kelip bintang nan jauh di sana. Ding. Tak sayupku dengar bagai melodi yang menggema. Cukup. Nanti dilanjut di akhir acara.
Oh, dilanjut akhir acara, nggak boleh sekarang aja itu udah dangdut gitu.
Tadi sih
aku
banyak
juga maunya
request.
gitu, dangdut, nggak boleh.
Nggak boleh nanti. Kita masih fokus dulu ke forum engineeringnya.
Oh gitu. Ya udahlah.
Jadi acara yang ditunggu-tunggu sama seluruh peserta. Kita mau ada pop quiz, tapi sebelumnya kita mau nyapa teman-teman dulu yang ada di live chat YouTube.
Hai.
Mana ini? Halo, absen dulu. Di live chat YouTube.
Tapi ini ya. Ada satu tadi itu kita ini nggak cuma dari orang-orang Indonesia aja yang nonton, tapi teman-teman WIKA yang dari luar negeri itu juga nonton.
Iya, jadi bukan cuma dari Indonesia aja, tapi dari teman-teman kita yang ada di luar negeri juga ada. Tadi ada dari tim proyek Aljazair juga.
Iya, udah mantengin ya.
Dari jam 3 pagi tadi sudah standby.
Iya, karena beda jam dari Indonesia sama di sana.
Ada selisih 6 jam sama di Indonesia.
Ada yang dari Dubai juga.
Ada yang dari Niger juga.
Luar biasa memang proyek-proyek WIKA itu mendunia sekali.
Bahkan kemarin kalau kita lihat juga ada teman-teman yang dari India. Aku baca di live chat YouTube itu dari India. I am Kamil, please speak English ya. Oke, dari Semarang hadir. Dari mana lagi ini? UII. Oh, hadir semongko. Tarik sis, mongko.
Hadir.
MC-nya cantik, dua-duanya cantik ya. Terima kasih.
Kayaknya yang ngomong juga cantik cewek.
Batam hadir, Padang hadir. UII Jogja, Unsrat hadir, Yogyakarta hadir ya. Sekaligus mengingatkan jangan lupa share link ke teman-temannya biar bisa ngikutin acara siang hari ini.
Universitas Majalengka ada Gundar nih deket nih di sini. Bandung.
Dari UMY. Hostnya udah makan belum?
Oh iya. Tapi sebelum ini kita pop quiz dulu, kita mau ada play video dulu karena ada surprise tambahan hadiah. Oke. Panitia, teman-teman nonton dulu ya karena ini seru banget. Yuk kita tonton videonya dulu.
Ada video quiz. Oke.
Itu dia. Jadi buat semuanya harus pantengin terus nih dari pemateri-pemateri yang ngomong sampai besok ya. Itu jawabannya apa? Di menit keberapa pembicara itu ngomong apa tadi? Ya, Bim
Wika Jaya.
Bim Wika Jaya itu di menit keberapa? Makanya harus fokus.
Oke. Bisa dilanjut ya?
Ya, lanjut aja.
Kita
ke
lanjut
pop
ke
quiz.
acara yang sudah ditunggu-tunggu, pop quiz.
Udah tampil ya di layarnya. Jangan lupa daftarnya pakai ID peserta ya.
Ya, jadi kalau ada yang mendaftar tidak menggunakan ID peserta otomatis hangus.
Jangan sampai udah jawab capek-capek, banyak-banyak tapi hangus.
Iya, pikirannya udah panas ngerjain pop quiz, ternyata ya nggak dapat apa-apa.
Iya, betul banget.
Oke. Kita mulai. Wah, ini sudah banyak yang masuk ya.
Oke, udah banyak.
Menggunakan ID
Terus
peserta. Oke.
Oh iya, tarik sis. Tetap ada nama ya, tarik sis.
Iya, jadi diingetin lagi ya, ID peserta. Bukan nama peserta, apalagi ada yang ngisi tadi tarik sis semongko namanya.
Semongko.
Itu memang namanya atau apa itu tadi?
Jangan lupa pakai ID peserta. Ini udah mulai banyak, udah 69, 70.
Ayo. Ikut. Oh, makin banyak lagi yang ikut.
Karena hadiahnya memang sangat menarik gitu. Dan ada surprise lagi karena hari ini juga ada door prize tambahan.
Ada door prize tambahan?
Ada door prize tambahan. Ada tiket hotel.
Tiket hotel?
Iya, dan abis pop quiz ini kita jadi ngundi 1 tiket hotel nih buat teman-teman, siapa tahu ada yang beruntung buat mungkin ada yang mau liburan di Jakarta. Ada tiket Best Western Cawang.
Ya, jadi menginformasikan kepada seluruh peserta voucher Rp250.000 untuk 40 orang pemenang di hari ini. Kemudian nanti ada door prize tiket Jakarta Surabaya PP plus voucher hotel dari Best Western Papilio. Kemudian ada voucher hotel Best Western La Grande Bandung. Kemudian ada voucher hotel Best Western Hive Cawang Jakarta. Persembahan dari WIKA Realty.
Wah, luar biasa sekali WIKA.
Banyak
jadi makanya abis pop quiz ini kita bakal ngundi lagi nih gitu. Nah, kayaknya udah siap mulai ya, kita hitung mundur ya.
Oke.
Dari 10. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Selamat bermain.
Mulai.
Dika Tampan memimpin. Terus ini kalau udah ada nomor peserta itu udah agak bingung kita nyebutinnya. Tapi tetap ada beberapa yang pakai ini ya.
Ya, perlu diingat lagi ya, sebagus apapun nilai kalau tidak menggunakan ID peserta otomatis hangus. Jadi wajib menggunakan ID peserta.
Tapi memang kalau dilihat kayak gini seru banget ya. Kita ngelihat teman-teman main cepet-cepetan gitu, jawab-jawab. Tapi ada kayak perasaan gimana ya? Deg ser gitu.
Pasti dong.
Iya.
Kerja ini yang pasti jadi motivasi utamanya itu hadiah sebenarnya.
Iya, motivasi utamanya hadiah.
Dicari kan. Iya, masih dilanjut.
Ini Dika Tampan nih kayaknya cepet banget nih cara jawabnya juga benar.
Dika Tampan, sebagus apapun kamu tidak akan mendapatkan hadiah.
Mohon maaf Dika Tampan.
Enggak Mbak, aku nggak nyari hadiah, aku yang penting nongol aja kan.
Mungkin mau disebut aja. Hai Dika Tampan.
Dika Tampan, vokalisnya Kangen Band ya ini ya.
Itu Andika Kangen Band ya? Andika ya namanya?
Iya, Andika Babang Tampan.
Babang Tampan. Apa adeknya?
Ya, saudara.
Udah mulai kembar.
Iya, saudara kembar.
Itu kayaknya kamu aja deh.
Ini ada WF11. WFE 11.03031. Waduh.
Aduh, ini.
Baru disebut langsung disusul ini.
Ayo yang lain yang masih terus berjuang biar bisa dapat hadiah nih.
Ayo kemarin yang belum dapat hadiah masih nanya gimana caranya dapat hadiah popis. Yang ngerjainnya yang cepet dan benar.
Iya, pastinya harus memperhatikan dulu seluruh materi yang ada.
Iya, betul sekali dan mengikuti aturan mainnya.
Iya. Pakai ID peserta ya?
Iya.
Ini Dika Tampan nih udah mulai tersusun Dika Tampan. Sepertinya udah mulai melemah ya. Lelah ya udahlah nggak dapat gitu ya. Ya Dika Tampan ternyata turun ke bawah. Ya siap, ini kita hitung mundur aja ya. Udah mulai melemah nih kayaknya nih. Untuk Oke, kita hitung mundur dari 10 9 8 7 6 5 4 3 2 1. Yeay, selamat. Ini dia para pemenangnya.
Sudah muncul?
Sudah muncul nih, udah mulai muncul nih. Nah, ini dia.
Selamat kepada 5 peserta.
5 peserta. Yang 2 pesertanya ini
Menyusul.
udah muncul nih. Ding 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 ding. Dia jalannya kayak ini penguin ya?
Penguin.
Ting nenet.
Oke. Selamat untuk para peserta. Terus kita mau break dulu?
Enggak, kita ngundi dulu ya. 1 tiket hotel door prize yang Best Western Cawang.
Oke, siap.
Oke. Makin deg-degan nih kayaknya. Bisa buat kalau yang tinggal di Jakarta bisa buat staycation lah ya,
Iya.
lumayan banget.
Di antara
Oke,
kesibukan
udah siap.
kerja,
Ini udah muncul ya.
kuliah, masih bisa staycation
Atau
kan?
mungkin kalau misalnya lagi banyak kerjaan bisa kerja
Iya.
di situ sih sambil karena pasti kan suasananya lebih baru lagi gitu,
Betul
bisa
sekali.
merefresh otak.
Iya. Apalagi kondisi pandemi kayak gini ya, mau jalan-jalan juga mikir, mendingan staycation aja.
Iya, betul.
Oke, kita mulai 3, 2, 1.
Dikocok.
Cak.
Udah dikocok.
Cak.
Cak.
Sabar, masih menunggu ternyata.
Nggak apa, biar
Nggak
teman-teman
apa-apa.
makin dekat.
Iya.
Nah,
Memang
mumpung lagi kayak
sengaja.
gini, itu sebenarnya teman-teman berkesempatan buat berdoa.
Ya, betul sekali.
Berdoa sebanyak-banyaknya gitu.
Biar dapat
Disolawatin,
hadiah.
biar dapat hadiah. Dan jangan lupa di hari
Oke.
terakhir kita masih ada 1 buah motor gesit dan hadiah-hadiah lainnya pastinya.
Yes, untuk kali ini ternyata voucher 250.000 dulu.
Oke.
Ya, yang akan
Kita
diundi.
undi voucher 250.000 dulu. Ini dia untuk yang 5 pertama.
Ya.
Ada
Mustiadi
Mustiadi.
dari Universitas Mataram. Fauzan dari Universitas Hasanuddin. Ada Fatahila Furqon. Ada Irfan Syah Andika Putra. Ada
Dan
Nilo
ada
Sintaratna dari Universitas Warma Dewa.
Selamat. Jadi ini udah sudah. Ya udah, mungkin nggak apa-apa. Nanti masih ada lagi karena tadi ada sedikit terkendala. Voucher hotelnya diundi setelah ini.
Ya,
jadi pantengin terus.
Memang harus ngikutin acara ini sampai akhir nanti.
Iya,
ya.
biar nggak
Oke?
nyesel.
Oke, jadi kita mau break dulu.
Iya, break dulu. Ya udah langsung aja kali ya.
Ya.
Selamat makan siang teman-teman semuanya.
Kita jumpa lagi di jam 1 siang. Dadah.
Indogress, more than just style. Indonesia, salah satu kekuatan ekonomi baru dunia yang terus bertumbuh. Kelancaran distribusi barang dan jasa adalah salah satu penopang kekuatan ekonomi Indonesia. Maka untuk mempercepat pembangunan dan pemerataan pertumbuhan, diperlukan dukungan sarana transportasi terbaru. Dimulai dari kota Jakarta dan Bandung sebagai sentral pertumbuhan ekonomi Indonesia. Setiap harinya, sekitar 145.000 orang melintas antara kedua kota tersebut dan menghabiskan 3 hingga 4 jam dengan kendaraan darat. Bayangkan jika ada alat transportasi umum yang dapat menghemat waktu tempuh tersebut. Kereta cepat, siap melesat untuk mendekatkan jarak dan mempersingkat waktu. Sebuah sarana transportasi umum masa depan yang melaju dengan kecepatan 350 km per jam, hingga jarak ratusan kilometer pun dapat ditempuh dalam hitungan menit. Demi kenyamanan maksimal selama perjalanan, kereta cepat hadir dengan interior premium, gerbong restoran, dan pramugari yang siap melayani sepenuh hati. Lebih dari sekedar transportasi umum, kereta cepat juga akan memunculkan titik-titik pertumbuhan baru. Halim sebagai gerbang baru ibu kota. Karawang sebagai pusat industri. Walini sebagai pusat agrowisata dan pendidikan. serta Tegaluar sebagai kota teknopolis. Pertumbuhan baru itu kami wujudkan melalui Transit Oriented Development, sebuah inovasi berorientasi masa depan, membangun daerah perumahan, bisnis, industri, dan hiburan yang terintegrasi dengan konsep hijau ramah lingkungan dan akses transportasi publik maksimal. Transit Oriented Development menciptakan area urban yang meningkatkan kualitas kehidupan, serta memaksimalkan potensi ekonomi melalui area bisnis yang menarik investasi, sehingga diproyeksikan akan menyediakan lebih dari 70.000 lapangan pekerjaan selama 25 tahun ke depan. Inilah langkah awal untuk mendekatkan masa depan, memacu alih teknologi, dan mendorong kreasi serta inovasi. Karena tak seharusnya kita menunggu lama untuk menyambungkan asa anak bangsa demi mewujudkan asa Nusantara bersama kereta cepat.
Sebagai bagian dari bangsa, BUMN adalah roda Indonesia mencapai asa. Peran dan fungsinya strategis, menggerakkan semua sumber daya. Bergerak, berjalan, berlari, menyelam semakin dalam, terbang semakin tinggi. Cita-cita BUMN bisa menjadi nyata, kala tata nilai budaya dibangun untuk kemaslahatan semua. Akhlak bukan akronim biasa. Akhlak adalah kemudi BUMN membangun bangsa. Akhlak adalah inti agar BUMN semakin mendunia.
Kita juga perlu sebuah fondasi yang kuat, sebuah nilai yang menjadi panduan kita untuk bergerak. Hari ini juga saya ingin menetapkan akhlak sebagai core value.
Amanah.
Kami memegang teguh kepercayaan yang diberikan.
Kompeten.
Kami terus belajar dan mengembangkan kapabilitas.
Harmonis.
Kami saling peduli dan menghargai perbedaan.
Loyal.
Kami berdedikasi dan mengutamakan kepentingan bangsa.
Adaptif.
Kami terus berinovasi dan antusias dalam menggerakkan atau menghadapi perubahan.
Kolaboratif.
Kami membangun kerjasama yang strategis.
Tata nilai Wijaya Karya lahir dan tumbuh sebagai budaya. Agility.
Kami insan WIKA bertindak terengginas dan cepat terhadap peluang dan perubahan bisnis.
Caring.
Kami insan WIKA bertindak proaktif dan peduli terhadap pemangku kepentingan.
Excellence.
Kami insan WIKA memberikan hasil unggul bagi pelanggan dan pemangku kepentingan. Agility, caring, excellence.
Core values BUMN sejatinya selaras dengan core values WIKA. Pada tata nilai budaya keduanya terdapat beberapa perilaku kunci yang berkaitan.
Wijaya Karya siap menjalankan core value akhlak dan ACE berjalan seirama dengan penuh tanggung jawab. Saya meyakini bahwa solidnya core value berkontribusi terhadap identitas, karakter, dan segala aktivitas WIKA yang kuat. Ketika semua lapisan WIKA dapat menyerap dan menerapkan akar budaya akhlak dan ACE, insya Allah akan tercipta insan ACE yang berakhlak.
I am your city. I house you, feed you, care for your loved ones. I provide you with work and pleasure. I am a living, breathing, unstoppable organism made up of you, people. My drinking water is disappearing, depleted by demand and leaking away in a maze of crumbling infrastructure. My buildings are failing, threatened by age and poor design. My sanitation system is outdated and overwhelmed, endangering our health and safety. And I'm getting hot, dangerously hot. Soon, I may be too hot for you to live in. If we're going to have a future together, things need to change. We can't keep using the same short-term thinking. We need to plan for those who come next. You created me, and now I need you to stand with me. Build me better, never failing. I am your city, and we are one.
Caring. For those who design, for those who produce, for those who build, and for those who live in buildings. Caring for the safety and benefit of all, making lives easier, more convenient, and more comfortable. Caring about people, listening to what matters to people, and taking into account their needs. Helping everyone to grow. Responding to the multiplicity of challenges in today's world and adapting to the diversity of the lives that populate it. Caring about today, but also caring for the future, taking responsibility to lead the change and build a tomorrow that is in harmony with its environment. Where some merely sell a product, we care about people's lives. Weber, we care.
PT Suprajaya 2001, your best construction partner.
Indogress, more than just style.
Kala potensi usaha jasa konstruksi sangat berperan dalam kegiatan pembangunan lainnya. Dengan adanya industri jasa akan memberikan peluang yang besar bagi penyerapan tenaga kerja yang memiliki keahlian di bidang industri, jasa konstruksi, dan bangunan. PT Lingga Indo Teknik Utama didirikan secara resmi pada tanggal 11 November 2008 di Bekasi. PT Lingga Indo Teknik berkantor pusat di Mega Office Park, Blok OP3, nomor 6, Kota Harapan Indah, Bekasi, Jawa Barat. PT Lingga Indo Teknik bergerak di bidang jasa konstruksi. Tidak sedikit telah menyumbangkan dharma baktinya dalam pembangunan dan perkembangan Indonesia sampai saat ini.
PT Lingga Indo Teknik Utama secara legal berdiri sejak tanggal 11 November tahun 2008. Bidang konstruksi adalah bidang yang saya gelutin selama ini sejak tahun 1993, dan bidang ini adalah menjadi bagian dari hidup saya sampai dengan saat ini dan merupakan passion bagi saya. Untuk saat ini, PT Lingga Indo Teknik Utama sudah memiliki lebih kurang 10 atau 11 cabang proyek yang tersebar di seluruh Indonesia, mulai dari Sumatera Utara, Palembang, Lampung, Jabodetabek, Jawa Barat, Jawa Tengah, Kalimantan, bahkan sampai ke Papua. Tentu kami mempunyai komitmen, di mana komitmen ini kami canangkan di setiap tahun, yaitu siap. S, strength, I adalah intelligence, A adalah agility, dan P adalah priority. Siap.
Lingga, siap.
Sebagai penyedia jasa pelaksana konstruksi, PT Lingga Indo Teknik Utama akan selalu berusaha menomorsatukan kepuasan pelanggan dan memaksimalkan kepercayaan konsumen sebagai pengguna jasa. Untuk menjadikan PT Lingga Indo Teknik Utama sebagai perusahaan yang unggul dalam bidang industri dan konstruksi. PT Lingga Indo Teknik Utama bergerak di beberapa jenis pekerjaan seperti embankment, excavation, cut and fill and clearing, konstruksi jalan dan saluran, dinding penahan tanah, pemasok material, rental alat berat, dan dump truck. Untuk terus tumbuh dan mendorong pembangunan infrastruktur yang berkelas, PT Lingga Indo Teknik terlibat dalam beberapa proyek konstruksi yang strategis. Di dalam era digital saat ini, PT Lingga Indo Teknik Utama mencoba untuk terus inovatif di dalam menggunakan teknologi terkini. PT Lingga Indo Teknik Utama mengalami kemajuan yang cukup besar dan pesat, semua ini karena pelayanan, kualitas produk, ketepatan waktu yang selalu menjadi prioritas dan disertai dengan harga dan biaya yang kompetitif. PT Lingga Indo Teknik Utama berhasil mendapatkan beberapa penghargaan. Keberhasilan dan kesuksesan PT Lingga Indoteknik Utama pun tak lepas dari dukungan dan doa seorang istri. PT Lingga Indoteknik Utama menyediakan barang atau jasa yang bermutu tinggi, mampu berdaya saing yang kuat di pasar dalam negeri atau internasional untuk menjadikan PT Lingga Indoteknik Utama sebagai perusahaan yang unggul dan tangguh dalam bidang industri jasa konstruksi.
I am your city. I house you, feed you, care for your loved ones. I provide you with work and pleasure. I am a living, breathing, unstoppable organism made up of you, people. My drinking water is disappearing, depleted by demand and leaking away in a maze of crumbling infrastructure. My buildings are failing, threatened by age and poor design. My sanitation system is outdated and overwhelmed, endangering our health and safety. And I'm getting hot, dangerously hot. Soon, I may be too hot for you to live in. If we're going to have a future together, things need to change. We can't keep using the same short-term thinking. We need to plan for those who come next. You created me, and now I need you to stand with me. Build me better, never failing. I am your city, and we are one.
Caring. For those who design, for those who produce, for those who build, and for those who live in buildings. Caring for the safety and benefit of all, making lives easier, more convenient, and more comfortable. Caring about people, listening to what matters to people, and taking into account their needs. Helping everyone to grow, responding to the multiplicity of challenges in today's world, and adapting to the diversity of the lives that populate it. Caring about today, but also caring for the future, taking responsibility to lead the change and build a tomorrow that is in harmony with its environment. Where some merely sell a product, we care about people's lives. Weber, we care.
PT Suprajaya 2001, your best construction partner.
Berdiri sejak tahun 1960, WIKA telah bertransformasi dengan penuh inovasi. Dalam kurun 60 tahun turut aktif membangun tanah air, PT Wijaya Karya Persero Tbk menunjukkan pertumbuhan dan perkembangan yang luar biasa. Dari semula hanya perusahaan yang bergerak pada instalator listrik dan pipa air, WIKA kemudian bertransformasi menjadi perusahaan jasa engineering, procurement dan construction, serta investasi yang disegani. Dengan memanfaatkan pengalamannya, WIKA menjawab peluang yang makin terbuka luas dengan tidak pernah berhenti melakukan terobosan di bidang usaha industri. Berbekal pengalaman manufaktur di industri komponen otomotif sejak tahun 1995, WIKA menyambut baik penawaran kerjasama untuk memproduksi motor listrik gesit. Motor listrik gesit sendiri merupakan impian anak bangsa yang ingin mewujudkan tanah airnya yang mandiri dalam bidang transportasi, teknologi, dan industri. Karena dukungan pemerintah yang tinggi pada motor listrik gesit mendorong terwujudnya kerjasama yang terjalin untuk produksi, pemasaran, dan operasional. Kemudian WIKA melalui anak perusahaannya, PT Wijaya Karya Industri dan Konstruksi, mendirikan pabrik baru untuk memproduksi motor listrik gesit, yaitu PT WIKA Industri Manufaktur. Populasi motor di Indonesia mencapai 140 juta unit. Dengan rata-rata penjualan per tahun 6,6 juta, ceruk pasar yang sangat besar, dan pemain di kelas gesit masih belum ada. Gesit diciptakan sebagai kendaraan roda 2 berpenggerak listrik yang ramah lingkungan dan hemat energi. Gesit adalah wujud nyata riset mobilitas transportasi yang selaras dan handal. Ia adalah implementasi real kendaraan roda 2 yang mengakomodir kehematan energi. Dan gesit adalah bukti bahwa Indonesia sejatinya mampu bersaing pada otomotif global. Untuk proses produksi terdapat 20 stesen, dan di setiap stasiunnya dilakukan beberapa tahapan, mulai dari assembling motor controller hingga dyno test. Untuk menggerakkan elektriknya, gesit dibekali baterai dengan tipe lithium-ion 72 volt dan 20 ampere hour. Motor listrik gesit menggunakan tenaga listrik dengan daya motor listrik 2 kW dengan peak 5 kW. Dari daya ini, bisa menempuh jarak sejauh 100 km dalam daya baterai penuh. Untuk performanya sendiri, gesit mampu melaju hingga 70 km per jam. Untuk pengisian daya baterainya sangat mudah dan cepat. Gesit hanya membutuhkan waktu 3 sampai dengan 4 jam. Dan baterai untuk sepeda motor elektrik gesit adalah evolusi dari baterai baru dikembangkan oleh PT WIKA Industri Manufaktur. WIMA bekerja sama dengan PT Gesit Technologies Indo dengan saham 90% dari WIKA Industri dan Konstruksi. Dengan fitur pintar yang serba baru di dashboard digital, nantinya panel indikator motor listrik gesit ini akan tampil pada smartphone dengan tampilan digital yang modern dan informatif. Untuk mendukung dan memperkuat serta menjaga kestabilan ketika dikendarai, motor listrik gesit dibekali dengan fitur suspensi yang kokoh. Untuk suspensi depan mengandalkan tipe suspensi telescopic shock. Sementara itu, untuk bagian belakang motor listrik gesit menggunakan suspensi tipe swing arm with monoshock. Kedua fitur suspensi tersebut tentunya akan memberikan kenyamanan kepada para pengendara maupun penumpangnya. Dengan suspensi tersebut, akan memiliki tingkat kestabilan yang tinggi meskipun dikendarai di jalan yang kurang rata atau penuh bergeronjal. Motor listrik gesit ini menggunakan sistem transmisi timing belt untuk memutar roda belakang yang diklaim unggul pada durabilitasnya. Bahkan penggerak motor listriknya dijamin tidak mudah terendam air atau terguncang saat melewati jalanan Indonesia yang syarat lubang dan genangan air di musim hujan. Motor listrik gesit dibekali lampu day running light, di mana lampu tersebut memanjang hingga ke samping bodi yang memiliki fungsi sebagai stop lamp dan lampu sein. Jalur dealer yang ada akan terus dikembangkan di seluruh Indonesia dengan dukungan after sale service, mendekat pada customer dan praktis. Dengan penggunaan personil charging dan mengembangkan charging station mandiri, Gesit memanjakan pelanggannya untuk ketersediaan energi. Gesit hadir dengan 3 varian warna, di antaranya merah, putih, dan hitam doff, dan akan dikembangkan ke warna yang lain. Diproduksi di atas lahan seluas 2.400 meter persegi, dengan produksi per bulan sebanyak 4.000 unit, 1 seat atau 150.000 unit per tahun. WIMA akan terus melakukan pengembangan dan evaluasi, sehingga bisa menjadi tuan rumah di negeri kita sendiri. WIMA siap maju bersama Indonesia dalam menghadapi masa depan dan tantangan global, serta mewujudkan visinya, menguasai pasar sepeda motor listrik di Asia Tenggara.
Sebagai bagian dari bangsa, BUMN adalah roda Indonesia mencapai asa. Peran dan fungsinya strategis, menggerakkan semua sumber daya. Bergerak, berjalan, berlari, menyelam semakin dalam, terbang semakin tinggi. Cita-cita BUMN bisa menjadi nyata, kala tata nilai budaya dibangun untuk kemaslahatan semua. Akhlak bukan akronim biasa. Akhlak adalah kemudi BUMN membangun bangsa. Akhlak adalah inti agar BUMN semakin mendunia.
Kita juga perlu sebuah fondasi yang kuat, sebuah nilai yang menjadi panduan kita untuk bergerak. Hari ini juga saya ingin menetapkan akhlak sebagai core value.
Amanah.
Kami memegang teguh kepercayaan yang diberikan.
Kompeten.
Kami terus belajar dan mengembangkan kapabilitas.
Harmonis.
Kami saling peduli dan menghargai perbedaan.
Loyal.
Kami berdedikasi dan mengutamakan kepentingan bangsa.
Adaptif.
Kami terus berinovasi dan antusias dalam menggerakkan atau menghadapi perubahan.
Kolaboratif.
Kami membangun kerjasama yang strategis.
Tata nilai Wijaya Karya lahir dan tumbuh sebagai budaya. Agility.
Kami insan WIKA bertindak terengginas dan cepat terhadap peluang dan perubahan bisnis.
Caring.
Kami insan WIKA bertindak proaktif dan peduli terhadap pemangku kepentingan.
Excellence.
Kami insan WIKA memberikan hasil unggul bagi pelanggan dan pemangku kepentingan. Agility, caring, excellence.
Core values BUMN sejatinya selaras dengan core values WIKA. Pada tata nilai budaya keduanya terdapat beberapa perilaku kunci yang berkaitan.
Wijaya Karya siap menjalankan core value akhlak dan ACE berjalan seirama dengan penuh tanggung jawab. Saya meyakini bahwa solidnya core value berkontribusi terhadap identitas, karakter, dan segala aktivitas WIKA yang kuat. Ketika semua lapisan WIKA dapat menyerap dan menerapkan akar budaya akhlak dan ACE, insya Allah akan tercipta insan ACE yang berakhlak.
Indonesia dianugerahi sumber daya alam yang melimpah. Beton, Sulawesi Tenggara, disinilah tersimpan kekayaan berupa aspal alam. Kekayaan langka yang hanya ditemukan di 2 tempat di dunia. Aspal alam Beton, yang kualitasnya telah mendapatkan pengakuan dunia itu, turut diproduksi oleh PT WIKA Bitumen, entitas anak PT Wijaya Karya Persero, Tbk. Dengan 2 tambang seluas lebih dari 400 hektar di Lawele dan Kabunka, material aspal dibawa menuju pabrik. Berbekalkan mesin modern dan canggih, serta didampingi tenaga ahli, aspal WIKA Bitumen diproduksi dengan kualitas terbaik. Untuk distribusinya, WIKA Bitumen juga membangun jeti Banambungi. Dari daerah inilah 2.000 ton aspal dihasilkan setiap tahunnya untuk mendukung pembangunan konektivitas di Indonesia. Kualitasnya menegaskan kesiapan WIKA Bitumen untuk memenuhi kebutuhan aspal nasional untuk menghasilkan infrastruktur jalan yang berkualitas. WIKA Bitumen juga menunjukkan kepeduliannya meningkatkan kualitas hidup masyarakat dengan membangun fasilitas air bersih. Tidak lupa, mobilitas yang kerap menjadi rintangan juga dijawab dengan membuka serta memperbaiki akses jalan di wilayah tersebut. Bekerja, berkarya, dan bermanfaat untuk bangsa. WIKA Bitumen, commitment to deliver excellent product.
Aku bahagia, hidup sejahtera di khatulistiwa. Alam berseri-seri, bunga beraneka, mahligai ramah-ramah, bertajuk Jaya Jingga, surya di cakrawala selalu berseri. Alam indah permai di khatulistiwa, persada senyum tawa, hawa sejuk nyaman, wajah pagi rupawan, burung berkicau ria, bermandi embun surga. Selalu cita, insan di persada yang aman sentosa, damai makmur merdeka di setiap masa, bersyukur kita semua. Selalu bersari, alam indah permai di khatulistiwa, negari tali jiwa, hawa sejuk nyaman, wajah pagi rupawan, burung berkicau ria, bermandi embun surga, bersuka cita, insan di negara yang bebas merdeka, hukum damai sentosa di setiap masa, bersatulah kita semua. Aku bahagia, di khatulistiwa. Aku bahagia. bahagia. Aku telah tahu kita memang tak mungkin, tapi mengapa kita selalu bertemu? Aku telah tahu hati ini harus menghindar, namun kenyataan ku tak bisa. Maafkan aku terlanjur mencinta. Senyuman itu hanyalah menunda luka yang tak pernah ku duga. Dan bila akhirnya kau harus dengannya, mengapa kau dekati aku? Kau membuat semuanya indah, seolah takkan terpisah. Aku tak tahu hati ini harus menghindar, namun kenyataan ku tak bisa. Maafkan aku terlanjur mencinta. Bila memang hatimu untuk aku, salahkah ku berharap kau memilih diriku? Cinta, aku telah tahu kini harus menghindar, namun kenyataan ku tak bisa. Maafkan aku terlanjur mencinta. Tapi mengapa kita selalu bertemu? Aku tak tahu hati ini harus menghindar, namun kenyataan ku tak bisa. Maafkan aku terlanjur mencinta. Ternyata hati tak sanggup melupakan.
Kak Rizal. Tanya dulu dong, kita ngobrol dulu, boleh
kita
nggak?
ngobrol dulu.
Kak Rizal juga kita ngobrol dulu dong, Kak.
Bentar, aku
Luar
nggak kuat,
biasa.
pengen nangis kok rasanya.
Kenapa?
Aduh, menyayat hati tadi suaranya.
Bagus banget. Pakai mic di sini boleh, Kak Rizal? Kita stay dulu dong, Kak.
Stay dulu.
Kita juga mau ngomong-ngomong.
Karena
nih sama
banyak yang
Kak
nanya
Rizal.
juga Mas di live
Iya.
chat YouTube.
Itu yang main keyboard siapa ya
Iya.
gitu.
Kemarin kan penyanyinya doang, sekali-kali keyboardisnya juga
Iya,
dong.
bener.
Iya.
Coba Vanessa sapa dulu dong teman-teman, kenalan IG-nya apa gitu.
Halo semuanya, aku Vanessa Bella. Dan jangan lupa follow IG aku @vanessabella_a_.
Oke, Kak Rizal, kenalan juga dong, Kak.
Nama saya Rizal.
Maaf. Aduh, grogi nih deket-deket.
Nama saya Rizal. Jadi ada tambahan Caulo itu nama palsu. Tapi
Oh gitu. Jadi dipanggilnya Caulo.
Enggak, Rizal Caulo.
Oh, Rizal Caulo. Terus enggak sih, sebenarnya kita mau ngobrol-ngobrol aja gitu. Biar ada yang nemenin aja, nggak berdua doang.
Oh, aku yang nyanyi jadi.
Iya, Mas Bayu nanti mau nyanyi.
MC-nya situ nggak ditanya saya. Saya nanya nggak ada mic ini. Soalnya diambil sama.
Ya udah aku yang nanya. Sebenarnya udah berapa lama sering kayak gini? Kalau Vanessa sering manggung juga ya di mana-mana gitu ya?
Iya, udah sering sih.
Luar biasa. Suaranya bagus banget ya.
Bagus banget sih.
Makasih.
Ya ini kan juga penontonnya juga banyak, berapa ratus ribu ya tadi yang nonton.
Bener.
Jadi siap-siap aja followersnya membludak habis ini nanti.
Gitu ya.
Kucing garong udah siap nge-follow semua.
Tapi tadi ada kan aku juga sempat update ya, dan ada beberapa teman-teman aku yang di WIKA itu nonton, dan mereka itu bilang, No tolong dong salamin buat yang nyanyi gitu.
Oh my god.
Namanya Iwan katanya.
Namanya siapa?
Iwan.
Oh Iwan. Ya.
Mas Iwan udah disampaikan ya Mas Iwan? Ya ada. Ya ada, makasih. Gimana? Orangnya ada di luar WIKA, lagi di proyek Bandung.
Oke, kalau gitu terima kasih.
Terima kasih Vanessa, terima kasih Kak
sama Mas
Rizal.
Rizal.
Iya, nanti kita ngobrol-ngobrol lagi ya.
Iya, pengen tahu aja tadi Mas Rizal Caulo ya.
Mas Rizal Caulo. Nanti kita ngobrol-ngobrol lagi Mas Rizal.
Iya, tenang aja
Terima
Mas
kasih,
Rizal,
Mas
nanti
Rizal,
juga masih mau
Vanessa.
tampil lagi. Terima kasih Mas Rizal. Ya.
Oke, ini yang ditunggu-tunggu.
Jadi
Kita balik lagi.
peserta juga udah nggak sabar ya habis makan siang.
Udah kenyang,
udah siap ngikutin acara.
Udah dihibur sama yang cantik juga.
Iya, betul sekali.
Dan sekarang ini dia saatnya kita door prize lagi.
Jadi kita mau bagi apa ini, Mbak Retno?
Bagi door prize voucher untuk 15 pemenang. Terus ada juga hotel Best Western di Jakarta untuk 1 orang pemenang.
Oke.
Ya, itu luar biasa banget, bisa ngajak keluarga buat
Betul.
staycation tadi ya kan. Yang tadi sempat ditunda, jadi sekarang di jam ini nih gitu.
Jadi hadiahnya
15.
mendapatkan 1 kamar hotel selama 1 hari. Ya kalau memang kurang pengen extend ya biaya
Boleh,
sendiri.
iya karena Best Western dari WIKA Realty itu benar-benar nyaman banget gitu.
Cozy
Jadi bisa
banget untuk
merefresh
staycation.
otak.
Betul
Benar
sekali.
banget.
Oke, langsung kita
Langsung aja
mulai,
kita mulai ya.
Untuk voucher Rp250.000
Oke,
untuk 5
siap.
pemenang pertama.
Di
3, 2, 1.
Kocok. Up. Ada Delvi.
Delviani.
Terus ada Ervina. Ada Zulfikri.
Zulkifli.
Ada Husnul.
Ada
Ada
Prima
Prima Siwi.
Siwi dari Politeknik Negeri Semarang. Oke, selamat untuk 5
Untuk 5
pemenang pertama.
Terus kita akan ngundi 2 lagi. 2 kali lagi maksudnya ya. Berarti ada 10
5
lagi.
pemenang kedua. 3, 2, 1. Ada Ferry Fajar. Ada Anissa. Ada Abdul Haris.
Ada Mina.
Ada Yusril. Oke, selamat untuk 5 pemenang kedua. Kita lanjut untuk yang ketiga.
5 pemenang ketiga.
3, 2, 1.
Oke, ini dia ada Tritini.
Kemudian ada Anna Dewi.
Ada Muhammad Faris. Ada Lalu.
Rahman.
Ada
Kemudian
Nabila.
Nabila Izzatul. Selamat untuk 5 pemenang.
Iya 15 dong.
5 pemenang ketiga maksudnya.
Oh iya.
Total 15.
Oh iya benar. Total
Oke.
sama untuk 15 pemenang yang
Ya.
udah dapat voucher. Ini dia selanjut ini
Untuk pemenang hotel di Best Western Cawang,
Iya.
Jakarta. Kita acak 3, 2, 1.
Iya. Ini. Up. Selamat buat Muhammad Aziz Komarudin mendapatkan
Selamat.
1 malam ya.
Ya, nanti
tiket
untuk hadiahnya
menginap
akan
di Best Western.
dihubungi oleh panitia.
Iya. Oh ya, jangan lupa kita mengingatkan juga batas konfirmasinya nanti sekitar 2 minggu ya.
Iya, betul. Jadi harus diambil dalam 2 minggu ya.
Iya.
Iya.
Dan buat teman-teman terus ikutin acara ini sampai selesai karena jangan lupa ikut kuis yang tadi.
Iya, betul sekali. Karena masih banyak kuis-kuis. Masih ada hadiah juga.
Iya, dan jangan lupa tag @bimwika.
Ya.
Terus tag
Form Engineering, kemudian
Iya.
PT Wijaya Karya. Jangan lupa juga untuk komen, like, subscribe channelnya
channel
BIM WIKA.
Karena kita juga ada hadiah buat para Instagramers buat instastory-nya yang paling menarik dan paling seru.
Iya.
Dan jangan lupa jawab pertanyaan tadi, di mana tuh kata-kata tadi tuh
Iya.
ditemukan. Oke.
Dicatat ya, dicari nanti dikirim jawabannya via DM ya.
Iya, via DM
Via
@forum
DM, betul
engineering.
Oke.
Langsung
Jadi
aja.
langsung aja untuk selanjutnya. Ini nanti ada paparan lagi dari AllPlan.
AllPlan lagi yang akan disampaikan yang dia akan dimoderatori oleh Bapak Siswanto. Oke, sudah terhubung.
Pak Siswanto.
Halo.
Ya, sudah.
Ya.
Halo, Pak Siswanto.
Selamat siang, Pak.
Selamat siang, Pak. Jumpa lagi ya Pak kita, Pak.
Halo, Pak. Pak Siswanto. Ya.
Sudah makan, Pak?
Ya, sama-sama semuanya sudah makan kan ya, saya harap ya.
Alhamdulillah.
Ya, Pak
Baik,
Siswanto,
Pak.
silakan, Pak.
Baik Pak.
Terima kasih Pak.
Ya kalau gitu
Dengan saya Siswanto di sini.
kita serahkan ke Pak
Kita
Siswanto
dari
ya
PT
Pak.
Piranti Sarana Teknologi, perwakilan resmi AllPlan di Indonesia. Kalau tadi kita belajar mengenai AllPlan Engineering serta AllPlan Bridge, untuk sesi selanjutnya kita akan mendengarkan pemaparan dari Mr. Ralph. Mr. Ralph Pullinger ini akan membawakan pemaparan tentang Open BIM for Structural Engineer dengan tema A Collaborative and Managed Approach to BIM and Structural Engineering. Mengenai rekan saya ini saya akan sedikit bawakan. Saat ini beliau adalah Sales Enablement Manager bagian Collaboration and Engineering di AllPlan Jerman. Ralph adalah seorang structural engineer sejak tahun 1990 dengan pengalaman lebih dari 18 tahun pada jenis-jenis konstruksi yang berbeda-beda. Sebelum bergabung dengan AllPlan, Ralph bekerja pada Autodesk sebagai support engineer untuk area Northern Europe. Ralph sudah bekerja selama 4 tahun di AllPlan dan dia menangani khusus tentang BIM Plus, sebuah platform CDE dari Nemetschek serta Skia Auto Converter. Dia mempunyai ketertarikan pada integrasi dari model analisis maupun visual scripting serta bagaimana keduanya dapat membantu pada keseluruhan proses BIM. Untuk teman-teman yang ingin mengajukan pertanyaan, silahkan nanti terhubung dengan platform sli.do. Kami dengan cara search di Google, lalu masukkan kode #FE20. Oke, mungkin lebih baik kita akan segera melihat presentasi dari Mr. Lab ini. Kami persilahkan.
Hello, and welcome to today's workshop entitled Open BIM for Structural Engineers, a collaborative and managed approach to BIM and structural engineering. My name is Ralph Pullinger, and I'm the Sales Enablement Manager with Collaboration and Engineering for AllPlan. In this workshop, we shall show you how structural engineers can work within the Open BIM framework, analysing and designing structures in a coordinated, collaborative and managed environment. We shall be using AllPlan 2021, AllPlan BIM Plus with the SIA autoconverter, and introduce you to SIA Engineer, a sister company within the Nemetschek brand. My name is Ralph Pullinger. I've been with AllPlan for 4 years, and I am responsible for supporting AllPlan sales partners in the areas of collaboration and engineering with specific support of products including AllPlan, BIM Plus and SIA autoconverter. I've been a structural engineer since 1990 with over 18 years of experience on various construction projects. I've spent the last 12 years in industry covering software. Today's agenda looks something like this. As usual, we'll start off with a basic introduction to the topic. I've split the workshop into 4 main chapters: geometrical modelling, analytical modelling, analysis and design, and update. We finish off with the usual, again, conclusions and hopefully lots of questions. So why do we do this? Well, whether you like it or not, structural engineers are part of the design team. Designs must be validated to prove that structures can withstand the forces and actions imposed upon them. But information has typically been lost or recreated at key design stages. An open BIM approach to this process protects the information, and a managed and integrated BIM workflow means that the designs are more efficient. The workflow looks something like this. We start off with a geometrical model, and we create a model that we can share for analysis and design. that model must first of all be created or converted into an analytical model. Certainly the basis of one that we can use for our additional information. We take that initial model, we supplement it with more information, which now enables us to create an analytical model fully with boundary conditions, loads, combinations that we can analyze and create a design for. Finally, the results of that analysis and design need to find their way back into the primary model so that it can be updated to create a coordinated set of documentation. Our requirements are simple. The workflow or process must be managed, it should be collaborative, it should be available anytime, anywhere, it should be independent of modeling solution, and it should also be independent of the analysis solution chosen. In today's workshop, I'm going to use an example project, or one that's very similar to one that I did over 30 years ago when I was at university. Then, as now, it was called Designed and Detailed. Back then, it was designed and detailed to an old UK code, CP110. Now, it's all been changed and supplemented, and now we're designing to Eurocode 2. Only some slight differences, but none that we can't take care of. It's a fairly standard concrete frame building with main beams, edge beams, 5-meter slabs, and about 3 or 4 stories. I've added some engineering license to this project with the incorporation of some openings and an additional set of stairs to conform to fire safety regs. So let's start looking at Chapter 1, Geometrical Modelling. Our objectives for this chapter are simple. We want to be able to model the elements correctly. We want to be able to create documentation, or at least the first stages of documentation. First and foremost though, we really need to be concentrating on the geometry and not worry about any analytical features, as in other solutions on the market. It would be great if somehow we could look at some pre-analysis validation methods so that before we dive straight in for rigorous analysis and design, we can do some simple checks. Ideally, we would like to aggregate the model or models in a neutral environment, bringing together models from different disciplines maybe, such as architectural and MEP, as well as structural. For this chapter, I'm going to be using AllPlan 2021 and AllPlan BIM Plus. Here we are in AllPlan. As you can see, my model is pretty well advanced. I've created columns, beams, foundations, slabs, a small steel framed unit to take some plant, and some angles to restrain the curtain walling or brickwork as the architect sees fit. Fairly regular design, nothing really outrageous with regards to form and function. We have a lift pit at the bottom, we have several holes, and we have 6 sets of stairs. If we break this down a little more, you'll see here that for the ground floor we have a slab we have columns, we have edge beams and foundations. Moving up, we have a typical floor, which again has columns, slabs and beams. Similarly for the second and third, and then for the roof and plant, we see the steel frame. This building is made up of a combination of load-bearing and non-load-bearing elements. As you can see in my model view, I've created all the floors required within the project, but also using AllPlan's drawing manager, I've been able to create views of other floors ready for documentation. So as you can see here, I have extracted a view, and that view is now ready for placing on a drawing. I've created some annotation with regards to labeling the elements to indicate their sizes and depths, their lengths, etc., etc., possibly some thicknesses. I've labeled up the grids, and I've created additional labels for columns, beams, and dimensions for holes, etc. Even the steel elements have been labeled very, very crudely. These plans have been created by using the horizontal section tool inside of AllPlan, which allows me to look at predetermined slices of the building and show details above and below in the correct format. The drawings that I've extracted, or views that I've extracted, ready to be placed on drawings, can be seen using our layout editor. The layouts have been updated to reflect the current drawing conditions or modelling conditions. Let's have a look at the foundation plan to begin with. So this is a direct use of the view that I've created for the foundations. I've done exactly the same for a typical floor plan and a roof layout. This method of working within AllPlan is very economic with overall files, and very, very fast and efficient with regards to computer time. Even sections and even stair details can be created using this process of isolated sections and isolated views or plans of individual components. So once we have a model and once we have the beginnings of documentation, we must be able to validate the elements and their size and their materials that we have in our what we term geometrical model. So the first stage of this overall process is to start and share the model for different purposes. For this, we will upload the model to BIM+, which is our neutral environment for exchanging information. We establish a connection to the project, and we upload the model to the BIM+ project so that we can collaborate with a much bigger audience than just the modeler and at his desktop. And here we are in BIM+. This project I've already created, assigned a location, and there is one member, myself, and one model, that we've just seen in AllPlan. If I go to the viewer, which is called BIM Explorer, you'll see exactly what I mean. So this model is a direct copy of the one on my desktop, except this one is available to everyone on the project, and it is available anytime from anywhere, because BIM Plus is based on the cloud. In BIM Plus, I can do all the usual spinny, zoom in, zoom out, and pan that you would expect, but I've also got access to other tools which enable me to visually check the model without doing too much interrogation. One of these is sectioning. I can section in the X, Y, or Z, or even in any direction based on an object. So I want to section in the Y in this instance, going across my building, and I'm going to color the view so that sections and edges appear red, and I'm going to color those in to give us a better representation of what we're actually cutting through. So as I move my section plane through, you can see that I am slicing through various pieces of concrete, and these faces are being colored in red to highlight where we're actually taking the section. As well as visualizing the model in this way, we can record what we see by taking snapshots or slides of our views. Here, just taken a very quick slide of the section view. But quick rename that to section Y, and then we can get back to our model. We can change the section plane to X, and again it remembers the settings that we had before, and we can slice through and again visualize on what we've got within the model itself. Now we know that information exists in a model in many formats, not just by the elements themselves, but also by attributes. There are many attributes in a model that may or may not be correct. Where is the best place to edit those attributes? Is it in a graphical environment, or is it in a spreadsheet with lots of control and lots of facilities to edit large amounts of data at the same time on multiple objects? I think we know where we're going with this. What I would like to do next is to show you how we can use Excel to do some very quick preliminary checks of various elements within the model to see if they're going to stack up to a detailed analysis and design in a later chapter. Here we are in Microsoft Excel. Almost exactly the same as everybody else's Excel. The universal engineering tool of choice. In my Excel, I have a special BIM Plus tab. That tab allows me to log in and connect to my BIM Plus account and see the projects that I'm currently working on. The projects load up, and I am able to choose the one that I want to access to get at the information to review, amend, publish. Once I've connected to my project, I can import the objects from that project. Those objects are categorized into various IFC disciplines, that of the building model, a recess model, and a help model. Okay, so the help model contains some specific symbols and symbology and smart stuff that AllPlan creates. recesses, slab openings, and then the building model itself contains all the main elements that we want to look at. So beam, column, foundation, walls, etc. In this example, I want to have a look at the beam objects that are within the model. BIM Plus allows Excel to connect and to extract that information. As you can see, there's quite a few beams in the project. Question is though, are some of these beams correct, or are they just as a result of pure modeling? So what we can do is we can look at, let's say for instance, only the first floor beams. Okay, so we can highlight those. And we can also look at the beams that are, let's say for instance, just concrete, because I know we've got some steel ledger angles for the curtain walling, so I can just highlight the concrete beams. Okay, so I get a very small subset of that information that I wanted to work with. Lots and lots of information here. Okay, and as you can see, we've got some steelwork information, and we've got some height, depths, widths, and lengths of beam as well. Okay. So what we're going to be doing here is a very, very quick span to depth ratio calculation. So I'm just going to move to a nice clear column, and because I know that these beams sit under a slab, but for a structural purpose that slab is taken into account with the depth of the beam, so I can use a constant slab depth of 150 millimeters. That applies to all of my entries. But what do I want to do with this? Okay, so I want to take my depth of my beam and add that to the depth of the slab. So here is the height of the actual element, and here is the width of the actual element or beam. So I'm going to take this entry here and add it to this cell here. There is my total depth. So I want to now calculate my span to depth ratio, and I can do that by using some very quick maths by taking my length and dividing it by my total depth, and I get a ratio of 15.4. So I can now copy this formula to the rest of my rows, and I get a very quick calculation based on the criteria, the elements that I have. But furthermore, I can do some lovely formatting based on the data that I've just created. In order to do that, I must unprotect my sheet. If I highlight this now and I look at conditional formatting and look at some color scales, I can see a graduation of color based on span to depth ratios. So the lower the ratio, the worse it will be. If I wanted to know where these elements are, I can use my BIM Plus tab to connect to BIM Explorer within Excel. And then if I've got a beam, let's just activate the whole model, And because I know I'm just looking at the first floor beams at the moment, I can just turn my buildings off and just turn my first floor on. I'm looking at this entry here, for instance. Where is that? There's the beam. And I can see all of the properties within my beam itself. If I click on a beam or a different beam, then it takes me straight to that beam inside of the BIM Explorer window. So very quickly, we can do some validations with Excel, BIM Explorer, and some simple maths. And returning back now to our presentation. So what have we done in Chapter 1? We've created a geometrical model of the structure, and that is now ready for the next stage. We've started to create project documentation, such as drawings and schedules. And we've also allowed more than one person to validate the model through BIM+. Just by way of comparisons, I am estimating the time that I've spent in the project already, and also estimating the time saving by the end of the chapter that I'm in. So in this particular instance, I've created a geometrical model that I'm using for documentation, and I haven't saved any time in the overall process from a structural perspective at this stage of the design. Okay, that is probably as you would expect. Okay, so I reckon or estimate that I've currently spent about 2.5 hours creating and getting the model to this stage, and that also includes some preliminary drawings, etc., sections and so on and so forth. Okay, so as it stands currently, many engineers would now take those drawings that have been produced by this lovely process called BIM, and will now recreate that model from an analysis perspective based on the information that we've already created. So what I'm going to show you next is essentially how we take that information and we create an analytical model, or the beginnings of an analytical model, directly from what we've already published to BIM+. So in this chapter, we are going to create an analytical model from the shared information we've just created. We are not going to recreate information, we are going to add to existing information. Furthermore, we are not waiting for an engineer to come back to us with sizes. We can carry on doing the design documentation because we know with BIM things update, labels and dimensions will automatically update as well. So we're pretty safe going forward in the knowledge that we can carry on doing exactly what we need to do. The engineer can now start to use the information that we've created, but slightly repurpose it for an analytical perspective. So the benefit here already is that the modeler has not had to worry about any analytical features such as analytical walls, analytical beams, analytical columns, etc., and joining those analytical features up like other systems, other solutions on the marketplace do. So this is a much more flexible method and way of working. What I'm going to show you next is how we take that model and how we create an analytical model that can be used directly by the analysis tool of choice.
Lily was a little girl, afraid of of the big wide world. She grew up within her castle walls. Now and then she tried to run, and then on the night with the setting sun, she wanted to swim, so forever.
Now, the aim of this chapter is to take the existing geometrical model that is comprised of real objects such as columns, foundations, and slabs, etc., and convert them to their analytical equivalents. Now, analytical equivalents of these objects are quite simple. They are either 2D planes to represent walls and slabs, or 1D lines representing the beams and the columns. Foundations can be recognized and thought of as either simple supports, or if the foundation gets too large, it can be thought of as a 2D support as well. But that's more of an engineering decision rather than a modeling decision. Now, some systems insist that you allocate analytical lines when you model the actual objects, and that can lead to great confusion, and also it means that you need a special sort of modeler to be able to take into account both the actual real world elements and the analytical elements. In this approach, we definitely separate out the two disciplines. So the modeler can get on and model, and the engineer can take what the modeler has produced, convert it into analytical features, and then analyze and design. So in this chapter, what we're going to explore is how we take this model and convert it into an analytical model. Now, over the last few years, several brands within the Nemetschek group have been collaborating together to create a function which is now known as SIA Autoconverter. SIA Autoconverter has been written by our colleagues in SIA, and it comes off the back of the BIM Plus database. So we are sharing the same information with the same team. Okay, so I just, in this particular instance, because it's the first time that I fired this up today, I will be choosing my team and then choosing the project that I want to work with within the SIA application. As you can see, when I turn my model on, it is exactly the same. Okay, so we can have a look at this model and we can select objects and we get the attributes exactly as we have before within BIM Plus, albeit that's in a slightly different format, but they are exactly the same objects with exactly the same values. There are several functions in this SIA Autoconverter, and we are going to concentrate initially on the generating the analysis model from the structural model. And this is organized into a series of steps. So there's 6 steps to create an analytical model. So the first step we've already sort of done by selecting the actual model itself, but we can even go down and select only parts of the model that we want to select or start with from the IFC structure. Moving on to the next port of call, we are going to what is termed clean the model. So in this instance, we might be, which is already turned off by default here, we might turn off the foundation class. And that's because I know from an analysis perspective, I'm going to use node supports for my columns and line supports for my walls. As you can see, currently we still have the non-load bearing steelwork around the outside of the building. Okay, these are simple angles. And if I highlight one, I can see here that I've got an attribute which is load bearing, which is set to false. If I exclude those from my model, all of my steelwork disappears. Okay. Also, in this particular analysis run, I've turned off the stairs, which are these child geometry objects here. So there they are, and they're gone. So what we're doing is we're just finding the information that we want to work with. But notice that we have here my lift pit walls still in existence. Okay, so these are load bearing because they're retaining soil and they will be anchored ultimately to my base. But I'm just going to design those in a different fashion going forward. What I'm looking for in this very first analysis run is my frame results. So if I have a look at some of the other attributes within my wall, and because I know that I've got a wall, this wall height is unique to the lift pit, I can actually turn my height off and my lift pit walls disappear as well. So now I have a model that I'm really happy with and can proceed to the next step. So the next step is where we recognize the objects that we have in front of us. So this is the first part of creating that analytical model, where we take our actual real world objects and repurpose them to be analytical objects. But we're not creating totally separate models because the elements are joined together by a unique UUID or grid type facility where we know which analytical object is associated with which real world or geometrical object. In that way, we know what to change and how to change it at the end of the process. So as you can see here, we have some basic settings for recognizing the objects, and we have some really clever and intuitive algorithms built in to SEER Autoconverter, one of which will automatically pick up parallel members. This is for when you have maybe two braces in the model side by side that are acting together. So from an analytical perspective, we would wish to combine those into one analytical object, which has got twice the amount of stiffness than a normal angle within the brace or flat within the brace system. We can also here remove or discount objects that are within or outside certain tolerances. So if I have a very thin wall still within my model, which is quite obviously cannot be load bearing, I can discount that by setting a minimum 2D thickness. When we go further and we look at the members, we can tell which system is going to generate which type of analytical object. So the beams in my project are being mapped to 1D objects. The walls are being mapped to 2D, the columns to 1D, and the slabs to 2D as well. Within cross sections, we have the ability to map automatically libraries based on attribute name. Here I've mapped section name out for my cross section. Furthermore, because we are actually learning as we go, SEER Autoconverter knows which sections to place as a map from the sections that I've placed in my model. So this is an example of SEER Autoconverter learning as it goes. It starts to create a library and applies the same syntax rules for the sections that is initially manually mapped and then will be automatically mapped going forward. And it learns, it keeps on learning, and it builds up this database on the cloud that it uses from project to project to project within your particular team. The same also applies to some extent with materials, in that I can select an attribute from the model, from the objects within my model, and that can be mapped to a material within the BIM Plus database. In this case, I'm mapping plain ordinary concrete to a specific grade. So in this way, I can keep my materials general when I model, and I can map it to a specific material ready for analysis when I'm creating my analytical model. So having successfully concluded mapping of cross sections, members and materials, I can move on to the next step. And the next step is to actually recognize the elements, the structural elements. Just by hitting the button, it is now going to go through all of the objects within my model and automatically create a 1D or 2D representation of the actual objects. Now, as I mentioned before, this is the semi this is a relatively easy thing to do. And as you can see here, it completed in a very short space of time. And you can also see now that we have in the model, in purple, unfortunately, and also in a lovely brown colour still, you can see the 1D and 2D objects. If I turn off my original model, which is currently ghosted, you can see these objects more clearly. You can see definitely that the nodes are plentiful and that they don't align. Okay, so if we were to just start analysing this model now, it wouldn't work. It would be worse than a deck of cards because it doesn't assemble. It's not a coherent structural model. So that's what we have to do next. We take this model and we join all the bits together to make it work. So if we have a look at the alignment settings, first of all, now that you can see that we now have the local axes turned on, so you can now see the X, Y and Z axes for the individual elements. And we have some general alignment settings. So how much should we move a node to make it consistent? Okay. And if we hover over the eyes in these dialog boxes, we get a very well constructed tooltip. How much should I extend my members? Should I extend them by maximum of 25% or less? Now, the algorithm behind alignment settings is quite clever in that it will hunt for and recognize what we would call dominant planes. So dominant planes is essentially something that is primarily horizontal or primarily vertical. And then it looks for sloping planes, such as roof planes. And it will endeavor to create the most simplistic form possible based on the criteria that we have here and the actual locations of those elements, those members within this recognized model. There are some other settings down here to the left, such as members being represented as ribs, that I will turn off for this for this example, and that's because this sort of concept is very, very specific to certain applications, whereas most applications can certainly deal with 1D members as part of a 2D plate, for instance. When we're happy with the general alignment settings, we can move on to more settings. So for instance, I can choose how elements behave, so whether or not I need to or freeze them on certain axes, say for instance, or where their system lines are. So if we just have a look at, let's say for instance, the system lines for a beam, you can see that it's based within the middle of the section. The column is within the middle, the plate for my walls, and as you can see behind this dialog box, as I select a member group, it gets highlighted in the model so that I understand exactly where these things should go. Now it could be that I want my my plate to be eccentric in the Z direction, which means that I'm essentially pushing my plate surface, my analytical surface, to the top of my my slab. In doing so, my beams will follow that that direction, because I've already associated my my beams with my dominant planes, as it were. For this example, I'm just going to stick with the defaults, because I really want to show you what happens next. So we have a misaligned model currently, and if I now go to the final step, which is align these objects, what will happen now is that SEER autoconverter will take the misaligned model, which you can, or the recognized model, which you can see in the background, which is here, and it's going to create an aligned model where those nodes are now perfectly and consistently aligned, joined up, and literally ready to go. As you can see with this slab that has been recognized and aligned by SEER autoconverter, we see that it is a structural layer. It has nodes, it has an alignment, and lots of other particular functionality from a structural perspective has been attributed to the slab. Even the material has been correctly assigned to the one that I chose right at the very beginning of the process. So, as part of the same project within the Nemetschek group, we needed a format that was both flexible, recognizable, could be read by anybody, and was so widely available that it was almost by default open. And we asked ourselves, what is the most familiar tool on an engineer's desk? And that is Microsoft Excel. So we have two ways now of taking this model, this initial analytical geometric model, and getting it really ready for analysis and design. The first method is that we can save this model back to BIM+, which means we're using the same cloud-based technology to restore the model that we've just created as an aligned model back into BIM+. Okay, so this is specific to SEER autoconverter at the moment, but because this toolkit is available to anyone, or this method is available to anyone through the programming interface of BIM+, many more solution providers could choose to go down this path, this direct connection path back to BIM+ as well. And the other method that we've come up with is, as I mentioned, is based on Excel. And this is called the SAF format, which is the structural analysis format. Okay, and again, what we can have here is which way the primary axis is and the version of SAF that we are targeting with our extract. So I'm just going to very quickly save this file into an Excel format, and I'm going to open that directly from SEER autoconverter, which is all it's going to do is just fire up Microsoft Excel, and we're going to have a look at the constituent parts within the SAF format. So the first page is all about the project. Okay, so it's what it was called, when it was created, and some unique other IDs, very similar to IFC in some respect. The second tab is all about the model, what it was called, the discipline attributed to it, and then we've got some other lines which are going to form part of the tracking process of any particular SAF file. Then we start to look at the materials, and as you can see here, we've got the materials that are now in use in the model. we've also got the cross sections that are in use in the model. And then we have the nodes. And then we have the beams, the surfaces, and so on and so forth. Okay, so we have lots and lots of different objects, all coming together to form a unique description of the model. It's exactly the same model as we've got in BIM Plus, as we've got in AllPlan. It's just a different visualization of that information, which is, it's hard to understand sometimes, but even Excel is BIM, and you should all probably know that already. So yeah, so we've now got two different ways of creating the model ready for structural analysis. And what I'm going to do now is just go back and get ready for the first stages for that analysis and design. So back into presentation mode. What have we just seen? Okay, right. So we've created an initial analytical model, and that's ready for the next chapter within this workshop. And that model is connected. It's been visually checked, and we're pretty happy with the sizes, and we know that everything is fixed and joined up, ready to go. So we're not going to get too many unexpected problems in the next phase. Now I keep on talking about other solutions, and this is where typically we see issues arriving in that models are either not joined up, or other items have been put in to make them join up, which has gone outside of the control of the modeler, for instance, and I've got no idea of what these particular solutions have done in order to create an analytical model that will assemble and be able to be analysed and therefore designed. So we know that because we've split it up, we've split the different disciplines up, the different methodologies, we've arrived at a model that is ready for analysis. Now to date, I estimate that I've been in this project roughly about 3 hours, but at this particular moment in time, I think I've saved at least 2 hours based on my experience to date. Okay, so where does that 2 hours come from? So that 2 hours is coming from me not having to rebuild that model in the analysis and design tool. It's also come from not having to wait for the documentation, the drawings that have been produced initially for me to work off. So there's two aspects here that it enables me as an engineer to be more productive. So that time that, yes, okay, I've been waiting for the geometrical model to be produced, but I can be getting on with other things. I'm not having to wait. So this is where we start to see the time savings creep into the overall process of this particular workflow. Okay, so it's a bit like many things. When you take them individually, you don't see much. But when you take them together as part of a combined workflow, you start to see real savings in the end-to-end time spent. The next chapter we will be looking at is analysis and design. Now I'm going to be using SIA Engineer for this, and I will admit now that I am not an expert on SIA Engineer, but I will take you through the rudimentary steps to create an analysis model within SIA, and also show you the workflow that is involved in creating a new analytical file, so that we understand what has to be updated back in the geometrical model, which will be our last chapter. So the objectives for this particular chapter is to finish off that analysis model, that analytical model that's initially developed by the previous chapter. And for that, we're going to need to add boundary conditions such as supports. We need to add loads and combinations, and quite obviously we need to analyze, we need to do some form of code check, certainly on some of the steel members and the concrete ones. We might even do some RC design, say for instance for one of the slabs, and then I can show you how we get that particular result back into AllPlan. So without further ado, what I'm going to do is fire up SIA Engineer and get going on some analysis and design.
Somebody to heal, somebody to know, somebody to have, somebody to hold. It's easy to say, but it's never the same. I guess I kinda like to wait until the pain. Now the day bleeds into nightfall, and you're not here to get me through it all. I'll let my guard down, and then you pull the rug. I was getting kinda used to being someone else. I'm going under, and this time I fear there's no one to turn to. This all or nothing way of loving got me sleeping without you. I need somebody to know, somebody to heal, somebody to have, just to know how it feels. It's easy to say, but it's never the same. I guess I kinda like the way you help me escape. Now the day bleeds into nightfall, and you're not here to get me through it all. I'll let my guard down, and then you pull the rug. I was getting kinda used to being someone in love, and I tend to close my eyes when it hurts. Sometimes I fall into your arms. I'll be safe in the sun till I come back around. For now the day bleeds into nightfall, and you're not here to get me through it all. I'll let my guard down, and then you pull the rug. I was getting kinda used to being someone you love. Now the day bleeds into nightfall, and you're not here to get me through it all. I'll let my guard down, and then you pull the rug. I was getting kinda used to being someone you love. I'll let my guard down, and then you pull the rug. I was getting kinda used to being someone you
And here we are in SIA Engineer. So this is what we are faced with when we first start SIA, and the first task for this is just to import a model through the bin plus exchange mechanism. So we are connecting to BIM Plus via a login, secure login. And once we've logged in, we'll be able to see all of the teams and projects. So team, project, and then model and a revision that we want to work with. And the information that we'd previously created in AllPlan and then through BIM Plus and SEER Autoconverter has now been interpreted by SEER and is coming into SEER Engineer itself. It tells me what it's been able to map successfully from the source database to SEER's database, and now it will essentially recreate the model that I've already done in AllPlan and BIM Plus into SEER itself. And here we go. So as you can see, it's exactly the same as BIM Plus and AllPlan. Now I'm a bit fastidious when it comes to doing things, so I am going to create a file just in case. Always good practice. Now, as I mentioned, I'm no expert in SEER Engineer, but I do know that I've got to set some specifics up first before I go too far. So I'm using Eurocodes, and I'm going to use the British National Annex, and I'm going to not use masonry, I'm not going to use aluminium, and I'm not going to use timber. But I'm going to use steel and concrete, and the concrete I want to be grade that's 2835, and steel grade S275. Okay. Now, initially I want to be able to put on some supports, some boundary conditions, okay? And we have here under model data and support, we have line on 2D member. So I'm going to make my supports fully fixed, and I'm going to select 2 members and 2 edges for supports. Now I want nodal supports at the bottom of all of my columns, so let's just change the view here so that I can see all of my columns which are at different levels. And I'm going to go for support in node, and again these are all going to be fully fixed, and I can select all of these nodes, and I now have supports at the bottom of all of my columns. So based on the data that I have been given from design, moving on to the loads now, I need to set up just 2 load cases in addition to the self-weight load case. So load case 2 is going to be dead, and load case 3 is going to be finishes, also part of the dead load. And which I guess we can also assume would be dead, and I think we will in this instance. So we'll change load case 3 to imposed, and we'll change that to a variable so that it's now a different load group. Okay. If we have a look at the load groups, we see that we've got load group 1, which is permanent, and load group 2, which is Cat A domestic, but we're going to change this to Cat B offices because that's what that's the intended use of this particular building. Now that we have our load cases and load groups, we need to apply some loads. Okay, so we're going to start at the top and work down. We have a surface load on a 2D member, and that surface load to begin with, using our imposed load that we still have set here, is 0.6. Acting downwards, so that's a minus. And now we need to fix that surface force onto a panel. So we can select a line, and as you can see here, it cycles through all of the connected members. Here is the one that we want. Just by double clicking on that, we are able to enter into it. So there's 0.6 put onto the roof slab. Now the floors for the imposed or live load also includes an allowance for partitions, and that comes to 3.5 kilonewtons per meter squared, again acting down, and we've got 3 floors in which to put that on. So we can again go with our minus 3.5. Okay, and then we can choose the member that we want to put it onto. And there we go. Now changing to dead load, because the self weight is going to be automatically applied everywhere. On the roof we have 1.5. And again, just cycling through the members to find the right one. And then we have on the floors, we have 1.25 finishes and other dead. As like I said, this is not a real life building because there's probably going to be other load cases that you would consider. You would definitely want to consider wind, and you'd probably want to consider services as well. But in this particular instance, we have our building all lined up and ready to go. Now the other thing that that can go on the building are some line forces, and these are for the external cladding, which is essentially a dead load. So if that was on a beam, well, I know I've got my beams all along the edge here, so that's really quite easy to work with, because I can put that directly onto the beam, or I can put it onto the edge of a 2D member again. If I put it onto the edge of a 2D member, what that's going to do is apply the load through the slab and onto and into my beam, or it could be that I've got a bit also with the cladding, I might have a slightly eccentric loading on the beam, which might induce a twist or torsion into that beam. So I'm just going to put this load on. We're in dead, which is good. My value is minus 3.5, so times the 5, which is minus 17.5. Let's say kilonewtons per meter run. and we want to select the beams. Now, what's happening is we're using local directions for the force, which is not ideal. So we want, I think it's Y. Yep, there we go. For the force, and that's going to take it to the local coordinate system of the beams that I am choosing. And I'm only going to load up one side, or one edge, I should say, of both sides for now, just to get some extra loading into the model. Okay, right, so we're just about ready to go for so a very quick analysis run. But one thing that I always quite like to do before I go too far is we just have a quick check of the data to see, to make sure that everything is okay. And it's very quickly, it's done a data check and it found no particular problems, so we'll move on to the calculation side and we'll just set that going. Okay. And what we can see here then is we're looking at a maximum translation or deflection of about 11 millimeters, which I'm pretty relaxed about at the moment. But let's have a look at what those results actually look like, shall we? So first of all, I was always told check the deflected shapes of anything that you analyze first, because you should be able to recognize purely from the deflected shape if it's behaving normally, and then you can start looking at the forces and reactions. If it doesn't look right, it probably isn't right. And it's stuck with me for loads of years. Okay, so we can look at, I'm going to look at the 2D displacement, but I'm only going to want to look at the 2D displacement of this particular slab, and I want to have a look at it from a combination perspective of service, dead, and I'm going to have a look at it in the global Z direction. So let's just very quickly have a little look at that. And pretty much almost exactly what we were expecting. We've got looking at some heavy duty or some heavy deflections in the middle of the large span, which is as we would expect, petering out towards the built-in wall. But as you can see, if we take a slice through the middle of this slab, it's going to be more or less exactly what we were anticipating with regards to deflections. We can also now have a look at, rather than deflections, we can have a look at possibly, let's have a look at internal forces within that slab, and combinations again, but ultimate. And if we have a look at moments in the X direction or moments in the Y direction, we can see that, let's just take that for current, just to tidy it up a little bit. We can see that we're generating some moments in the slab. And if we zoom in on some of those again, we do have averaging that we can take into account over points or supports. And then let's have a look at the moments in the X direction. Yep. So we get a fair idea of how the slab is acting under load, whether or not it's going to be adequate for design purposes. So we may or may not want to up the depth of that slab, but yeah, we'll take that for further analysis. So let's have a look at our beams now. We're going to have a look at some, certainly at these top beams to begin with. So let's just, we can ultimately do something like this, and we can just select, not quite. We can select these beams here. In the frame, and then if we have a look at 1D deformations for combinations in the service state. Again, we're looking at about 12.9 in this main concrete beam above, but the ones above here, not too bad. We can move on to internal forces now for the current selection. We'll do another combination. We'll set that to ULS, and we get an idea of what forces we're looking at with regards to axial, shear, and moments. So we're looking at some max moments here of about 105. Not too bad anywhere else, but certainly within the capabilities of the concrete beams that are there currently. So as I mentioned, we're just going to have a look at some very quick design here in SEER Engineer. Nothing too extravagant, so apologies if this doesn't quite meet your criteria, but this is going to be slightly dirty, very quick. So I'm going to have a look at some, just go straight in and do some checks on all of the steel members, and I'm going to have a look at with that ULS set, and just to do some, and as you can see here, it's pretty good. If we have a look at the service checks, oops, we're looking okay. Just to make sure the setup's all right, and then we have other check data as well that we can certainly get to grips with. So what I'm looking at is some auto design functionality here with regards to these members. Okay, so if I have a look at this auto design functionality, so let's have a look, go straight to cross-section data, and let's have a look at these large PFCs on the outside of the plant platform up here. So if I refresh this one and go to auto design, I'll see that my it's it's so well in, it hardly registers on the utilization ratio. So what we can do is we can certainly reduce the size of these steel channel sections. So if I come down in size, you'll see my utilization ratio go up. But there might be other considerations that I need from a fixing perspective. Okay, so for me, 100 mil depth and 50 mil wide is going to be a little bit tight. So I'm going to go with just a straightforward 125 mil deep, 65 mil wide channel section, but still a significant saving in weight and therefore material. Okay, and a quick refresh, and we're still well in with those beams. So that beam there, if we just let's have a look at come out of that, go with this, that is now a smaller channel section. So we've just swapped out one channel section for another section. But the next part of the problem is, how do we communicate that back to the detailer? I mean, just think if there was many changes to be made as a direct result of this analysis and design. Okay, could be really hard work for the detailer. So we've got to figure out a way of communicating all of this back to the detailer. Okay, so what we're going to do is use the same workflow, but almost in reverse. So we're going to take this analytical model that we've just completed with the design, and we're going to push that back into BIM+. So we're going to do an export back through to BIM+. It's going to connect, and we are going to not overwrite. We're going to create a new revision. That is going to be revision 2, and that is going to be first. Well, let's just do this properly. Okay, so let's just call it analysis run dated. And where are we at? Oh, good question. So 22nd December 2020. I can do export of the loads as well, because what I would like to do is visualize the loadings that we've done inside of BIM+, and that's going to allow other people to connect to BIM+ to see exactly what I've done from a structural engineering perspective. So one of the feedback that we got when we were doing some preliminary testing of our methodology was that not only does it streamline the overall workflow, but it does give others visibility of the work and the information that I've created and done and used in order to validate my design. So you frequently get asked, well, you know, why is that slab now 225 mil thick when it was 175 mil thick? 50 mil might not sound like much, but over the height of a building, it's quite significant for weight and therefore foundations and also headroom ultimately. But if you can actually show that you've got loads and the type of loads and the deflections, etc., that are attributed to those issues, then it means that all members of the design team are equally as informed. So that's now uploaded to BIM+, and I can get on with the next part of the process. And here we are. We are back in SEER Autoconverter, and we're looking at the original model that we sent over from AllPlan into BIM+, and remembering that SEER Autoconverter is looking at the same BIM+ database. So if we turn this one off and we turn the aligned model on, and if you remember what that looks like, okay. So we also now see next to the align model, we see this little clock face, which tells us that we have 2 revisions now of the same model. So this occurred after the or before the analysis, and then this one occurred after the analysis. Okay, and you can see some subtle differences in colors there as well. If we have a look at the loads, then if we turn some of these on, then we will see where they occur and what they look like. Similarly, we can turn on the dead. Okay, so we get an idea of where they are, and so on and so forth. Okay. So the question now is, once we have 2 analysis models, what can we do to determine what's changed and what we have to do from a modeling perspective, and also how do we communicate that from a modeling perspective? That part of the process we will cover in chapter 4. And moving on to just finishing off with our outcomes for chapter 3, what do we have? Well, pretty certain we've got a valid design. My total estimated time in the project to date is 4 hours, and I've still saved that initial 2 hours from not having to recreate the model from scratch in my structural analysis solution. So what that we need to move on to is updating. I should also add that behind the scenes, I've also created a file which contains the amount of reinforcement that I require for my roof slab. And if I've got time at the end of the next section, I'll show you exactly how we do that in AllPlan. I hope we've got enough time left, but I really want to sort of like go through this whole process with regards to how we build a structure, how we analyze it, and how we update it. That is my primary goal for today's workshop, but hopefully we'll have time and I can show you some of the other things that we've got inside of AllPlan by way of closing. Okay, right, so the next part, our final chapter in this, is how do we update the model that we have in AllPlan. Okay, so we have now an analysis model with 2 revisions, before and after revision, but we've got to be able to convey that amended design back to the primary model. We've got to allow the modeling solution to redocument any drawings, etc. Ideally, we would like an audit trail of the tasks and the responses from the designated person, so that we can ultimately create a coordinated design and then convey all of that information to the design team. So fairly run-of-the-mill stuff, really. How do we do that? Well, let's go on to our final bit of how the workflow works. So here we are back in SEER Autoconverter. We now have 2 analysis models with different revisions. We have a revision 2 and a revision 1. And what we want to do next for this update process is to compare both revisions, but from a structural analysis perspective, not from an elemental perspective. This is using the same revision compare engine that is built into BIM Plus, so you can see still how SEER Autoconverter is actually fully embedded even into BIM Plus. So we're going to compare revisions of the analysis model, and we can only do that when we have 2 models that are comparable. So we want to compare the aligned 2021 revision 1 with revision 2. We can set up different filters, i.e. what do we want to just look at. So from my perspective, all I want to look at is possibly just the section names, and we can look at and find the structural cross-section name. Okay, and then we can compare for update. So what we're looking for to identify is any names that have changed from revision 1 to revision 2. And as you can see, we have some area loads coming through, and the modified cross sections are visible on the top. We can expand this to see what the changes are and where they occurred on what member. So we can see here that we have the original channel section, which is 300 mm deep, going to a new channel section which is only 125 mm deep. So our next problem is, how do we communicate this to the modeler? Well, rather than a full-on automatic update, which means we lose control, we are going to create tasks, and those tasks are going to be saved in BIM Plus, assigned to a responsible person with a task description, i.e. change this member to this member, and these are the members that are affected. Okay, but now, remembering again what I said towards the beginning about how we are creating a linked approach, so that from a actual element perspective, we know what members are being changed. We can add a due date and a task priority. So let's make this high, and we're going to save these tasks back through to BIM Plus, so that we understand and can see what needs to happen. So if we switch back now to BIM Plus, we will see, if we go to the issue manager, we have a modified cross-section task that has come from SIA Autoconverter. Furthermore, when we highlight this task, the members are automatically coloured in red, and we zoom to the area in question within BIM Plus. We can see that it's high priority, it's still open, and we have a due date. The type is structural design, and if we save this task now, then we can convey that information to the modeler. And here we are back in AllPlan. What we've managed to do is create an initial model, create an analytical model from that, analyze and design, and then we've corrected some sections, and we've passed on what is required to be done to the model back into BIM Plus as a series of tasks attached to those objects. We can also see those tasks here as issues in AllPlan. When I select the particular entry in the issue manager, you will see that the objects that are required to change are immediately selected and highlighted in a view. It just so happens that it's the central perspective view now inside of my plan view. It's not a problem. It tells us which objects are required to change, and if we double click on this entry, then it also will tell us what needs to be done to those 4 elements. So those 4 elements need to be changed from one size to another. So now that we know that, we can go to our beam, and we can change it from one size to another. 125, 65, and because our alignments are all correct, we can update those very easily. So I'm just going to work my way through, and I can use the pipette to pull out the correct attributes, and then just the last one to go. You might think this is a bit laborious, but the benefits you will see as I complete the exercise. So that's all 4 beams now closed, and what I'm going to do, I'm just going to revert back to my plan view here. So plan view fully expanded. Let's just zoom in to double check to make sure that the documentation is consistent. Yes, so the labels have updated all automatically, as I would expect. So now what we can do is finish off the workflow process. So the final stage of this process is to upload this model back to BIM Plus as a revision. And in so doing, we are then synchronizing the geometrical model with the analytical model and all of the updates that have happened in between. So this is just going to be a nice easy revision. Plant platform beams amended, and I'm going to upload the model to BIM Plus. In BIM Plus now, we can see that we have more revisions of the same model. So here we have revision 1, and now we have the fresh revision 2 of the model. We can do a revision compare here, or we can do something really simple, and we can just have a look and inquire as to see whether or not these beams are now the right size, which they are indeed. So what we can do is we can go to issues, and we can formally sign this issue off as closed. And in so doing, in the dashboard, we will now see that the task or issue went from open through to solved to closed. And that concludes the workflow for an integrated structural analysis and design and modeling solution. So before I go, I thought I would just show you a little bit more of AllPlan and what it can do in the domain of reinforcement detailing. I've taken the liberty of loading in some additional drawing files here, and to make it a little bit clearer, I'm going to turn off some of the levels that I don't need, and I will now go back to the first because that's one that I do need. I've activated the main beam with the provided reinforcement files, and what we have or will have is a model with the main beams, and we have some details here with regards to what the actual drawing is going to look like. So you can see here that we have essentially a 2D detail view of the reinforcement, and I should be able to go to my objects and first floor, and I can essentially turn my transparency on for my beams, or even turn those beams off, and you'll see the reinforcement dangling out of the slab. So now we have the reinforcement in 3 dimensions, and also if I was to turn off the slabs, now you get a better idea of where that reinforcement is and what it looks like in 3 dimensions. So I've also taken the liberty to upload that same information to BIM Plus, and we can take a look to see what that looks like now. And here we are back in lovely BIM Plus again, looking at the model. As you can see here, we've got a 3rd revision, which is the reinforcement that I've added. And to take a look at that reinforcement, there's several things that we can do. We can just basically, well, first of all, we need to turn it on, and then we could turn all the other items off. And that also includes the aligned model that we no longer need. And here we just have the reinforcement that we want to look at. Okay, so we can also look at this in relation to the building objects, but we can do something interesting with the building objects in that we can make them semi-transparent, which we can also do in AllPlan, but it looks a little bit nicer inside of AllPlan. BIM Plus, sorry. Oh, getting confused right at the end. So we can see the bars. Again, when we highlight the bars, we get information about them as well. So if we turn the building objects off, we've got an information here about the links or stirrups that have been modelled inside of AllPlan and passed to BIM Plus. So hopefully you can see that together with SIA as well as AllPlan and BIM Plus, we have a nice little structural solution. And thinking about how this can develop further, we're pretty sure that we can integrate the reinforcement design for both 1D and 2D elements directly back into BIM Plus, which can be picked up by items and smart parts such as Python parts or Python beams, etc., for detailing purposes. So with that, I will now hand back to the presentation to finish off and wait for some questions. Thank you very much. So welcome back to the presentation. We've just finished off chapter 4, and what have we got at the end of chapter 4? Well, we have a fully coordinated design so that we have our model in tune with our analysis and design, which means we've got no discrepancies, and we are pretty sure that what we have is what the design validation has called for. So as I've been doing throughout this workshop, I've estimated the time that I've been involved in this project to date, and I reckon that the time that I've spent in the project is about 5 hours. But because of the automated process that's going on with transferring changes back to AllPlan, I think now that my savings are approximately 3 hours, which means conventionally I maybe would have spent 8 hours on this particular project, but in this instance with the integrated workflow, I'm estimating that I've actually only spent 5 hours doing the work, with the added benefit of the audit trail. So I know who has done what and when and why, which means that I've got a great system for tracking change and for doing those reviews, those design reviews, as you progress on through the project design. So in conclusion, and by way of a summary, this is what we've done today. We've created a geometrical model, we've reused the information, we've added to that existing information as well. So we've created the analysis model, we've analysed and designed the elements within the structure, and we've passed the information back to the modeler so that the structural geometrical model was updated and fully coordinated. Essentially, we've ticked all the boxes, all those prerequisites that I talked about right at the beginning of this workshop. So I'd like to thank you for your time today. I hope you've enjoyed it. I hope you've found it interesting. And Then, as usual, in closing with this workshop, if there are any questions, please feel free to ask them, and I will be here at the end of my microphone waiting to answer them. Wish you all a good day, but if there are any questions, please don't be afraid to ask. Many thanks for your time today.
Sejak jumpa kita pertama, ku langsung jatuh cinta. Walau kau tahu kau ada pemiliknya, tapi ku tak dapat membohongi hati nurani. Tak dapat menghindari gejolak cinta ini. Maka izinkanlah aku mencintaimu. Atau bolehkan aku sekedar sayang padamu. Maka izinkanlah aku mencintaimu. Atau bolehkan aku sekedar sayang padamu. Memang serba salah rasanya tertusuk panah cinta. Apalagi aku juga ada pemiliknya, tapi kau tak dapat membohongi hati nurani. Tak dapat mengingkari gejolak cinta ini. Maka maafkan jika aku mencintaimu. Atau biarkan ku mengharap kau sayang padaku. Maka maafkan jika ku mencintaimu. Atau biarkan ku mengharap kau sayang padaku. Mengharap kau sayang padaku. Sayang padaku. Sayang padaku.
Oke, jadi menarik sekali ya teman-teman ya. Kalau tadi dilihat apa yang ditunjukkan oleh Mr. Ralph. Hi Ralph, morning.
Hey, good morning, good afternoon.
Okay, so we will start with the Q&A, but I will try to wrap it up what your presentation is ya. Oke, untuk teman-teman, jadi tadi dilihat yang ditunjukkan oleh Mr. Ralph adalah kombinasi atau kerja bareng antara AllPlan Engineering dengan AllPlan BIM Plus. di mana AllPlan BIM Plus adalah merupakan common data environment daripada Nemetschek. Jadi yang ditunjukkan tadi adalah Skia Converter, satu dari sekian banyak add-on yang ada di dalam BIM Plus. Jadi nanti kita akan segera mulai saja dengan pertanyaan-pertanyaan. Kita sudah lihat ada beberapa di sini, jadi akan segera kita sampaikan. Oke, Rob, ready?
Ready.
Okay, now first question is, okay, what is an open BIM? Answer that.
Yeah,
Open BIM.
So open BIM is really easy. It's BIM without boundaries. So it's not reliant on one vendor solution. It's about many solutions working together openly, freely, without barriers.
Okay, so that is the definition of the open BIM.
For me, yes. Yeah. You go online, you might see others, but condensing it down and making it really simple to understand, it's BIM without boundaries, no hurdles.
Okay. Next question. Regarding to data exchange, what is the difference regarding the IFC in Skia regarding the export file from IFC AllPlan and IFC 2x3?
So, I mean, there's the differences with the IFC and CO is more or less none at all, because it's an IFC-based file. So the only thing to watch is whether the IFC file is using the analytical template or it's using the standard building template. But the reason why we've done what we've done with the solution with autoconverter is that we don't rely on that IFC interface. We don't rely on the objects coming in unconnected, which is what you will get if you use a standard IFC based file to do it. So it's just a matter of the file type, the template that it's used, and whether or not it's suitable or not.
Okay, is that also the reasons why you have the direct Revit connection in Plus?
We don't rely on the model itself, the physical model, because you've got to take that and you've got to transform it into an analytical one for it to be able to be analyzed. And by that, it's essentially making sure that it's all joined up, there's no gaps, and it's essentially doesn't behave like a pack of cards or dominoes and fall over. So the important thing is to make sure that it's all node to node, edge to edge, and stacks up.
Okay, I can see that you are making the model in the AllPlan and then sending to the BIM Plus, then using a Skia converter, you convert something, right? Okay, who actually determines the type of analytical element?
So that's why we've split the workflow. So the feedback that we got when we did our original research on the project was the fact that engineers wanted to keep control over the analytical model, how it reacted to the physical, but the modelers were the ones with the knowledge that were able to build up the model and produce the drawings and so on and so forth. So we've basically split the workflow. So it's the engineer that decides what analytical features are going to be created, and it's the modeler that just models the actual elements themselves. So a wall, sometimes it's easier to model a column as a wall, and sometimes it's easier to model a beam as a wall, but they're not necessarily the right elements to use. but the engineer knows what elements to use.
Okay.
Okay.
Okay, so is that also the reasons why you don't have the analytical model and physical model in the same model?
Yeah. Well, there's that's one reason is because we split it out so that it's connected but different, and also it relieves a little bit of the overhead with regards to other objects inside of the actual BIM model, as it were. And then we've got the purpose of the engineer working on his working on the actual model itself. So it has a dual benefit really. So we keep it separate because it's easier that way, and we keep it separate because the engineer really needs to work on one part of the overall model as opposed to the both parts of the model.
Okay, so another question is coming. What analytical application can be used with AllPlan or Skia Auto Converter? Is that the only solutions, or you can have...
No. We've got many solutions that can be used with this solution, and we have a format which is based on Excel, and we are also expanding the reach of that format either through our own programming, through our own development, or through the analytical solutions development. So Autodesk Robot, Bentley STAD, we've got Axis VM, Sophistic. There's several other third-party solution providers around the world that are joining this band of support for this format.
So is that mean that in the near futures there will be more and more possibility of working as collaboration with other solution?
Yes. Yeah. We envisage many more joining our merry band.
Since you mentioned about the Excel, and we can see that you are using Excel quite often on your presentation, is there any other applications or is there any other module that connected into the BIM Plus that can help us on the modeling and all of the checking, maybe on the scheduling or something like that? Can you explain about that?
Yes, we use Excel a lot because it is a great tool for manipulating information. We also have Excel within, we can also use Excel within AllPlan as well. But BIM Plus is the one that aggregates the data, gets it into a format with all the attributes. Excel's just another connector for it, basically. We also have an add-in for Microsoft Project, which allows us to visualize the way the project goes together. So the way the construction project, the building, the bridge, or road go together, how it's how each task in the schedule relates to the object on the ground. But if there are ideas for other add-in solutions, not just for Excel or Project, then we'll look at those. And because BIM Plus is an open environment, anybody can program on it, then many different solutions can be developed on top of BIM Plus. And in fact, we've got virtual reality done by a third party, we've got catalogs done by a third party, and we've even got some of our own hooks in for precast as well.
Can you name the extension of the file that you can read either directly or indirect into the BIM Plus?
So the
extension of the file, the AutoCAD, Revit, or something like that.
So yes, we can read in. Obviously, the AllPlan can go straight in, and then we've got native supports for SketchUp as well. But importantly, because BIM Plus is that open BIM environment, it's the primary file type is IFC. So any application, any solution that can output an IFC file to the IFC standard, that's the important thing, because if it doesn't adhere to the IFC standard, then it gets really difficult. But then we can read those in. Obviously, from a coordination perspective, the models ideally should be in 3D. We are building in additional support for 2D information as well in the coming releases of BIM Plus. Whether or not that will extend to DWG, I don't know. That might be another development further on down the line.
Okay. Due to the time limit, I think that is the last question that we can give to you. So really appreciate your time, Rob.
Thank you.
Jadi teman-teman, sekian tanya jawab kami dengan Mr. Rob. Jadi kita akan serahkan balik acara ini ke MC ya. Terima kasih. Thanks, Rob.
Okay. Thank you very much.
Thank you, Mr. Rob dan Pak Siswanto ya.
Yeah, thank you, Mr. Rolf and Mr. Siswanto.
Oh ya, bahasa Inggris. Thank you. Tadi materinya bermanfaat banget ya, memang.
Jadi sebagai gambaran, memang dari BIM WIKA itu menggunakan AllPlan sebagai salah satu softwarenya.
Nah, Mas, sebelum kita ke door prize, mungkin kita nyapa teman-teman dulu boleh kali ya?
Boleh dong. Kita mau ngecek nih siapa aja yang masih standby sampai saat ini.
Iya, karena kita mau tahu antusiasnya dulu nih sebelum door prize masuk.
Iya. Sudah ada?
Sudah ada. Oke, sebentar ya. Oke, Mas, BTW Mas, hari ini ada door prize apa aja nih nanti? Ini udah ada nih Mas tapi.
Jadi hari ini nanti kita ada door prize voucher 250.000 untuk 20 orang pemenang. Kemudian ada hotel di Bandung ya.
Iya.
Kemudian ada tiket Jakarta Surabaya PP plus hotel.
Plus hotelnya. Jadi selain bisa pergi ke sana jalan-jalan juga udah dapat tiket hotel juga ya. Jadi nanti bisa kalau mau diperpanjang ya tinggal tambah sendiri aja.
Iya, tinggal extend biaya sendiri tapi.
Lumayan.
Oke, ini sudah.
Halo.
Udah mulai menyapa dangdutan pasti ya, ada ya yang
tetep
dangdutan.
Ya, masih memantau.
Utara Jember.
Wah, hai dari Utara Jember. Tadi itu memang dari ujung ke ujung ya, dari Medan ada, terus dari Makassar juga ada, Sulawesi ada, dari luar negeri juga ada.
Dari Aljazair tadi juga ada.
Hai MC
Kece. Aduh, terima kasih.
Terima kasih.
Itu pasti kamu, bukan aku yang dimaksud.
Enggak, King Nazar.
Masih ya. Oke, dari Palembang hadir, dari Jember Barat hadir.
Iya, NTB, hai.
Madiun hadir. Rezeki anak soleh. Dari Palangkaraya. Banyak ya?
Banyak, ada Nias, ada NTB, ada Madiun.
Ada Jogja Nias, ada dari
Majalengka.
Nias juga.
Yang dari Nias banyak ya?
Ada dari Bekasi juga, jauh banget ya dari Bekasi ya. Ada dari Padang.
Terus ada lagi dari Samarinda, banyak banget hari ini.
Ada dari BIM WIKA juga, yuk berdoa,
luar biasa, ada yang dari Papua Barat.
Oke, mungkin udah nggak sabar mau dapat door prize.
Kita langsung aja
undi
sambil
langsung
berdoa
aja.
Ya teman-teman semua sambil berdoa. Jadi door prize kali ini ada 20 voucher, terus ada hotel Best Western yang ada di Bandung dan tiket PP
Jakarta Surabaya untuk
dan
satu orang pemenang.
Iya, dan plus hotelnya.
Oke, langsung aja kita undi yang pertama untuk voucher ya.
5 pemenang voucher pertama. Acak. Ada Fernanda,
ada Hana,
ada Leika. Kayak nama presentasi kita ya tadi.
Leika.
Ada Muhammad Nabil dan ada Bali
Sundoro. Selamat untuk 5 pemenang pertama.
Kita acak lagi untuk voucher 5 pemenang kedua.
Ayo yang belum dapat berdoa, banyakin berdoa.
Banyak
lumayan buat tambah kuota.
Ada Intan. Iya, buat ya biar kuotanya nggak habis biar besok, apalagi besok lebih lama lagi ya.
Iya.
Ada hadiah.
Dapat hadiah.
Makanya aku juga tadi kepikiran ya.
Ada Nur Syafira.
Ada Harwin.
Selamat untuk 5 pemenang kedua.
Next
Kita lanjut
lagi
ke pemenang
5 pemenang ketiga.
Ya.
Siap. Ada Subhan.
Kemudian ada Muhammad Saiful.
Terus ada Rizky Ramadan.
Ya.
Lahirnya di Ramadan kayaknya. Terus ada Alven.
Alven.
Ini
lahirnya di Eropa berarti.
Kenapa?
Pegunungan Alven.
Wah, luar biasa.
Oke, selamat untuk 5 pemenang ketiga. Lanjut ke 5 pemenang keempat.
Kocok up. Ada Gusti. Ini orang Bali ini pasti.
Beli dari Bali.
Ada Reza.
Kemudian ada Ariandi.
Terus ada Aldi.
Kemudian ada Ega Marcel Tama. Oke, selamat untuk 20
pemenang voucher ya.
Ya. Yang akan kita lanjutkan untuk pemenang
selanjutnya.
Door prize
yang ditunggu-tunggu.
Hotel 1 hari di Bandung
Ya,
dari
lumayan
Best
ya.
Western ya. Persembahan dari WIKA
Wika
Realty.
Realty.
Selamat kepada Rama Priya Adi Kusuma dari Universitas Teknologi Yogyakarta ya.
Lumayan tuh dari Yogyakarta bisa ke Bandung jalan-jalan.
Iya.
Hotelnya udah ada, tinggal ongkosnya aja.
Dia sendiri.
Buat refreshing. Oke, kita
Oke, selanjutnya
lagi.
Jakarta,
Ini
Surabaya
tiket
PP dan 1 hotel. Selamat kepada Dendi Yunianto dari Universitas Sultan Ageng.
Ini di
Tirtayasa.
Oh, di mana ini Sultan
Banten
Ageng?
ya?
Banten ya?
Banten. Oh iya,
Wah,
betul.
luar biasa. Lumayan ya,
Selamat.
bisa jalan-jalan ke Surabaya.
Ya.
Bisa
Aduh.
hiburan ya, cari waktu weekend gitu kan. Jumat, Sabtu, Minggu.
Bisa
Lumayan ya.
quality time sama keluarga. Bisa
Iya.
quality time sama istri anak kalau udah berkeluarga.
Ini ya belum beruntung, nggak apa-apa,
Ya.
nggak apa-apa, karena besok masih ada lagi.
Iya, masih ada door prize, masih ada pop quiz.
Masih ada pop quiz, pokoknya besok dan besok tuh lebih banyak lagi
Tuh.
hadiah door prize-nya.
Iya, door prize-nya ada banyak apa aja? Mbak Retno?
Ada pastinya ada voucher lagi.
Iya.
Terus ada tiket liburan Jakarta Jogja.
Iya, ada juga tiket liburan Jakarta Lombok.
Ada juga tiket liburan Jakarta Bali. Terus
dan
ada
yang
juga
utama
ada motor gesit.
Yeay.
Bisa berkendara sama pacar itu ya.
ya, tapi pastikan batas absensi sampai hari ini pukul 23:59 yang nantinya akan direkord untuk undian motor gesit. Ya, pastikan
Iya.
kalian absen sendiri, nggak ada yang titip absen ya.
Iya, pokoknya pastiin kalian hari ini harus absen dulu
Ya.
karena pengundian motor gesit itu dari absen kalian.
Iya, betul sekali. Ada satu
Apa nih?
chat yang bagus tadi.
Apa tuh?
Rezeki udah ada yang ngatur, guys.
Iya, tapi tetap aja walaupun rezeki sudah ada yang ngatur, jangan lupa tikung di 1/3 malam.
Betul sekali. Oke.
Jadi nanti malam harus sholat tahajudnya
Tahajud
dikencengin ya.
Biar
Dari
dapat
jam 2
motor
pagi sampai subuh deh tuh nggak berhenti-berhenti biar dapat
Ya Allah,
motor gesit.
motor gesit, motor
Ya Allah,
gesit, motor gesit, motor gesit. Nah, itu. Oke.
Oke.
Kita udah
Jadi,
melewati hari ketiga
iya,
sekarang
kita
Mbak Retno.
sudah melewati hari ketiga nih. Tapi 3 hari ini tuh kita udah ngapain aja sih Mas Bayu?
Ya, jadi agak flashback dikit ya. Kita sudah melewati 3 hari. Yang hari pertama kemarin ada ArchiCAD, kemudian
Iya.
ada Autodesk. Di hari kedua kita ada Leica, ada Glodon dan juga divisi engineer WIKA. Di hari ketiga ini tadi ada WIKA Beton dan dari AllPlan.
Wow.
Untuk hari keempat ada siapa aja, Mbak Retno?
Tentu karena 3 hari ini kita udah dapat ilmu yang sangat banyak. Di hari keempat kita juga ada pembicara-pembicara luar biasa lagi.
Ya.
Yang pastinya ada Bapak Ridwan Kamil.
Oh, Bapak Ridwan Kamil ya.
Iya, terus ada Prof. Oviar.
Prof. Oviar.
Iya, sebelumnya terima kasih Prof. Oviar kemarin sudah membantu skripsi saya karena saya skripsian pakai buku Prof. Oviar. Terima kasih Prof. Oviar.
Sangat berjasa ya.
Sangat
Prof.
berjasa.
Oviar. Oke, kemudian ada siapa lagi, Mbak?
Ada dari Microsoft dan ada dari Modular. Semuanya membahas tentang kayak Smart City,
Ya.
terus nanti Prof. Oviar akan membahas tentang Smart Infrastruktur,
Yes.
dan nanti dari Modular sendiri akan membahas tentang Smart Construction.
Wow.
Di mana kita kan kalau kalian tuh udah ada yang tahu ya, ada RS yang digalang. Itu kan pembangunannya cepet banget ya, 1 bulan bisa membangun rumah sakit seperti itu. Nah, itu
Wow.
gimana nanti akan
Ya.
mungkin akan dijelaskan oleh Modular.
Iya. Besok juga masih ada Bentley, kemudian ada Bima Konstruksi dan pastinya masih banyak lagi.
Iya, pastinya masih banyak lagi. Jangan sampai teman-teman ketinggalan.
Oke. Kita juga mau ngucapin terima kasih banyak untuk para peserta, pembicara, dan juga sponsor yang sudah mendukung acara Forum Engineering ke-11 ini.
Iya.
Ada PT Wijaya Karya Persero Tbk.
Ada WIKA Beton.
Kemudian ada PT Piranti Sarana Teknologi.
Ada WIKA Gedung.
Ada PT Duta Kreasi Bersama Realtindo.
Ada WIKA Realty.
Ada PT Microsoft Indonesia.
Ada WIKA Rekayasa Konstruksi.
Ada PT Jakarta Cakra Tunggal Steel.
Ada WIKA Bitumen.
Ada PT Utomodek Metal Works.
Ada WIKA Industri Manufacture.
Ada PT Suprajaya 2001.
Ada WIKA Industri Konstruksi.
Ada WIKA Industri Energi.
Ada WIKA Serang Panimbang.
Dan ada Lingga Indo Teknik Utama.
Yap, tanpa para sponsor ini kita tidak akan bisa jalani acara hari ini 1, 2, 3 bahkan sampai besok Mas Bayu.
Betul sekali. Terima kasih juga untuk para peserta yang sudah antusias ya mengikuti acara, sudah meramaikan kolom komentar di IG, di YouTube. Masih kita tunggu sampai besok.
Iya, karena jangan lupa tetap memeriahkan di IG dan tag @bimwika, @PT Wijaya Karya dan Forum Engineering karena akan ada hadiah.
Iya, dan pastinya setelah acara ini selesai dari BIM WIKA dan Forum Engineering akan memberikan konten-konten yang bermanfaat buat kalian semua.
Iya, baik Mas Bayu nih, sebelum ditutup mungkin nanti kita akan ada hiburan kali ya.
Oh iya, kita panggilin dulu penyanyi kita.
Penyanyi kita yaitu Vanessa dan Rizal. Hai, kita nyapa ya.
Hai Kak.
Mau nyanyi apa nih abis ini?
Untuk closing aku mau bawain lagu ciptaan aku sendiri dan
Karizal.
Iya,
wah, luar biasa.
Iya, luar biasa.
Luar ciptaan lagunya diciptain sendiri. Belibet nih, grogi nih. Di samping orang yang cantik soalnya.
Minder ya.
Minder. Udah kesaing duluan. Itu ciptaan sendiri.
Iya.
Udah lama atau baru nih?
Waktu itu diciptainya sih 2 tahun yang lalu ya.
2 tahun yang lalu
lagi kemerdekaan Indonesia tanggal 17 Agustus.
Judulnya apa ini? Judul lagunya?
Himne Pemuda.
Himne Pemuda.
Dengar-dengar pernah dinyanyiin di Kementerian Pariwisata kalau nggak salah ya?
Iya benar.
Oh, luar biasa. Mungkin teman-teman bisa tepuk tangan ya karena luar biasa banget ini.
Mungkin bisa diceritakan lagunya ini tentang apa?
Oke, lagu ini tuh kita tulis untuk membangkitkan jiwa nasionalisme para pemuda-pemudi Indonesia untuk menjadi benteng masa depan Indonesia.
Waduh.
Luar biasa.
Luar biasa sekali lagunya. Oke, mungkin para peserta
jadi di acara ini spesial banget ya karena ternyata Vanessa mau nyanyiin lagunya karena nggak ada di mana-mana, cuma ada di acara ini atau acara-acara formal lainnya.
Iya, betul sekali. Oke, mungkin para peserta udah nggak sabar ya, pengen dengerin. Kita juga mau minta maaf juga kalau selama hari 1, 2, dan 3 kita ada banyak kesalahan.
Ya, baik kata yang disengaja maupun tidak disengaja.
Ya. Oke,
Yaudah,
akhir kata
gitu,
saya Bayu.
Saya Retna Iswandari.
Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.